Hey, it's Andrew Brown, your favorite cloud instructor over here on FreeCodeCamp, bringing you another free cloud certification study course. And this time it's the Azure Fundamentals, also known as the AZ-900. And the way we're going to achieve Microsoft certification is by watching those lecture videos, doing those hands-on labs. And as always, I'm going to provide you a free practice exam so you can go get that certification, put in your resume, put it on your LinkedIn, and go get that cloud role you've been looking to get. If you love these kinds of cloud certification study courses, the best way to support more free courses just like this one is to purchase the paid optional materials. It's going to help you increase your odds of passing the exam, and it just helps the production of these courses. And if you don't know me, I'm Andrew Brown, and I've taught a lot of different cloud certification study courses here. We've done AWS, Azure, GCP, Kubernetes, Terraform, you name it. I've taught it, but that's about it. Let's go ahead and learn some Azure, and I'll see you soon. Ciao. Hey, this is Andrew Brown, and welcome to the Microsoft Azure Fundamentals. And we're asking the most important question first, which is, what is this certification? Well, the Azure Fundamentals is the entry-level cloud certification for Microsoft Azure, or Azure. And you'll see me alternate between those pronunciations. They're both accepted, so whichever you prefer. There is no prerequisite for this certification. But you should probably have a little bit of IT experience, but if you don't, it's totally fine. If you're totally new to cloud, you'll still be okay here. The key topics that we are covering is understanding the basics of cloud computing, exploring the benefits of using cloud services, and looking at those core services, those being computing, networking, storage, and databases, understanding identity, security, governance. So, one example for identity would be Entra ID, previously known as Azure AD, something you'll hear again and again through all the Microsoft certification courses. Understanding how pricing works, things like subscriptions and cost management tools, and learning about the tools available for managing Azure resources, such as Azure Portal or the SDK or the CLI, and things like that. Microsoft Azure is the second leading cloud service provider in the world, the first being AWS, but let that not discourage you, because Azure is still an extremely great cloud service to use, and it's used quite a lot. So Azure Fundamentals is a very common starting point for people breaking the cloud, similar to the AWS Cloud Practitioner. So both are really great entries into cloud. Who is the certification for? Well, consider this fundamental certification if you're new to cloud and you want to learn the fundamentals and benefits of adopting cloud services in general. You are from a non-technical background, such as an executive, management, or sales level, and you need to acquire strategic information about cloud for adoption or migration. You'll want to understand the capabilities of Azure and how to build basic solutions and deploy cloud services in your organization. Very, very basic, but I mean, the objective of these fundamental certifications is not to really teach you how to build cloud workloads. That is more at the associate level, but we'll talk about that later on. Or you're a senior cloud engineer or solution architect or cloud architect who needs a reset or refresh their knowledge after working with Azure for multiple years, but maybe you didn't notice some things change, so it's a great revisit to get an idea of what is going on here. So what is the value of the certification? Well, the fundamentals provides the most expansive view possible for cloud architecture and Azure. I like to say this is going to provide you a bird's eye view, or the 50,000 foot view. So we're going to cover a lot of stuff, but it's not going to be as detailed as you would imagine. But the idea here is to promote big picture thinking, zooming out and assessing the cloud and Azure landscape for changes, trends, opportunities, and being strategic about the approach and process for our cloud journey. Okay? The Azure Fundamentals is not a difficult exam. It will not validate that you can build cloud workloads. For technical roles such as developer, engineer, or DevOps, it's not going to be enough to obtain those roles, but it's possible that it could shortlist your resume for interview. The exam covers content not found in other certifications, so strongly recommend that you take this as your foundational certification. A lot of people like to skip fundamentals because they think that they're easy. Yes, the certification's easy, but the exam content has a lot of stuff in it, especially mine, because I pack in a ton of stuff that I'm not going to put at the next level, because I'm going to assume that you're taking this course and getting all that knowledge there. The AZ-900 lays a good foundation for specialization for Azure certifications and is a stepping stone for professional development in cloud services. So definitely there is value in the AZ-900. Let's go take a look at the Azure roadmap. And this is not all of the Azure certifications and Microsoft certifications. They just have too many. I cannot fit them all on screen here. And I think all the course codes are up to date, but they're changing them all the time. So it's possible that they might be incremented by some versions. But in the entry, we have the Azure Fundamentals. There are other fundamental certifications. We have the AI-900, which is for AI. We have the DP-900, which is for data. We have the SC-900, which is for security. But again, I don't have room for all that, so I'm not showing them on here. So I'm showing you the path that is commonly completed after taking the AZ-900. So you have some associate certifications, you have a couple expert certifications, you have specialty certifications. There's definitely more associates, there's definitely more specialties, but there's always the two pros, or experts, I should say. So getting my handy pen out here, very often what people go for after the fundamentals is the administrator, the AZ-104. This is the most common path for those that are going to their next step in their Azure journey. And a lot of times people are going for that solutions architect expert, which is over here. But before you do that, you really want to go and grab that developer, the AZ-204. These are this is the most common strategy right here is these. But of course, it really depends on what you're doing. If you're doing security, you have the SC-900, and then there's 3 different associate level security certifications. If you are going after data, that's a whole different track. So it's going to really vary based on that. But again, this is the most common track. And even if you go do all of this and you want to do something else, that's totally fine, because this is going to lay a very, very strong foundation and give you really good skills in Azure. So how long does it take to study for this certification? Well, if you're a beginner, we're looking at about 30 hours. And this is someone that's never written or used Azure or any cloud provider, or never written any code or held a tech role. Technically, the certification doesn't require you to code, but I really want to make sure that I set you up really well, because in Azure, coding and scripting and that kind of stuff is way more important than any other cloud provider because you come across it a lot more. And so I've stuck in a bunch of coding stuff, and it is very challenging for beginners, but I want to try to get you best prepared as possible, because when you go to the associate level with like the AZ-104, it is so much more difficult. So I made this much harder than it had to be to prepare you for the next level, despite the exam, okay? So again, 30 hours on that side. If you're experienced, then you're already working with Azure, or you've worked in AWS and GCP and you are trying to pick up Azure. It could be as little as 6 hours. So, generally the study time is 24 hours. And I would say it's split between lectures and labs, and then you have your prax exams. So just make sure that you put your time in with the prax exams. Prax exams are very, 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 very important for Azure, because Azure has all these different question types, and we'll talk about that in a moment. But yeah, the recommended study is 1 to 2 hours a day for 14 days. Take your time, let it absorb. You could finish it in a couple days, but don't do that. Make sure that you are acquiring the knowledge for long term, and the best way to do that is to take your time and not try to pass it in a weekend. What does it take to pass the exam? Well, you got to watch those lecture videos. You got to do those hands-on labs and follow-alongs within your own account. Strongly recommend that you do some paid online prax exams. We give you a full free prax exam, like a full set, which is on our platform there. We have a lot of prax exams. You can get that at exampro.co/AZ900, and it really helps support the course here. Where do you take the exam? Well, you're going to either take it in person at a test center or the convenience of your home. So I would just say, just a second here. Sorry about that. Bako is knocking on my door. Bako's the other Andrew, who you'll hear me talk about Bako a bit throughout the course, but he's the other person that works with me that's never on camera. You never see him, but he helps do a lot of the work over here with the platform and creating the content. But anyway, so Azure delivers exams via, I got to re-click here, and the click's not working. There we go. Pearson VUE is the proctoring system that Microsoft uses. in the past, there used to be a bunch of ones. There's Criterion, which Google used to use, Google Cloud. There's PSI Online, which AWS like to use. But for whatever reason, both AWS and Microsoft exclusively only use Pearson VUE now. And I think GCP is now using PSI Online and everyone else uses PSI for whatever reason. But yeah, you have to use Pearson VUE. And you can do it online, or Pearson VUE has a network of test centers that you can go to in person. Personally, I recommend that you go in person if you can, because if there is a test center near you, the whole environment is controlled. It's going to be a lot less stressful. Whereas if you do it from home, if you have family or you have the least ideal place to set up, because you have to have a non-cluttered room and they have to inspect your room and things can go wrong. So I'm just saying, if you have that opportunity to go to an in-person test center, leverage that. If you can't, that's okay. Do what works for you. But understand that these certifications are proctored. So when you go sit that exam, there's someone who is monitoring you to make sure that you are not cheating. In terms of the content outline, there is 3 domains. I think there used to be more, but they grouped them into 3. I'm not sure why. Each domain has its own weighting, and that determines how many questions in a domain will show up. So we'll take a look there. Something that's really interesting about Azure exams is that they don't give you the same amount of questions per person. So they'll give you you might sit the exam and get 35, and your friend might get 40. So I had to give ranges here in terms of the percentage that will appear on your exam. So we have describing cloud concepts, which is 25 to 30%. So you're going to get about 13 to 15 questions. Describe Azure architecture and services. That's 35 to 40%. That is the majority of the certification. Most fundamentals is about learning all the services that the cloud service provider is providing. Then we have describe Azure management and governance. So that's 30 to 35% with 14 to 16 questions. There's subdomains under each of these. So of course, security is in there and all those other things are in there, but we'll have to open up the exam guide to see that, okay? So again, just pointing out that that domain 2 is the largest one there. So make sure that we're going to make sure that we know a wide range of Azure services, but we're also going to make sure we know in depth a bit more about those core services. Let's talk about grading. You got to get a 700 points out of 1,000. So that's about 70%, we say around, because Azure uses scaled scoring, meaning that it doesn't necessarily mean you get 70% and you pass. You could technically pass with 71%, or sorry, fail with 71%, but you could also technically pass with 69%. So just understand, it's not based on percentage, it's based on a point system. In terms of what kind of questions you'll be getting, well, first let's talk about the range of questions, but you can get between 35 to 50. I usually say 37 to 50. It's confusing because I don't know how they determine how many you get. When I sat my exam, I got about 35 questions. Some people get more. It's really, really tricky to nail that down there. So, we say about 10 to 14 questions you can afford to get wrong. There are no penalty for wrong questions, so absolutely always fill in the answers. In terms of formatting questions, we have multiple choice, multiple answer, drag and drop, yes and no. I do need to point out that when you go and take associate level and expert level certifications with Microsoft, they have way more question types. And just to help prepare you for that level of difficulty, and it doesn't appear in these exams, but in our practice exams, we try to put in case studies. So case studies is a much more advanced exam type question. And, I really feel that we need to do that, because if we don't, you're going to feel like you're ready for the AZ-104, and you're going to get totally blindsided because, again, the difficulty ramp is super hard. So again, we're increasing the difficulty for your benefit. So if you feel like this course is hard, that's good, because it's going to make the next one really, really easy for you. In terms of duration, apparently it's 45 minutes. I cannot remember how long it was when I sat it. And when you search the internet, it's very difficult to determine that number. Microsoft does not make it easy to find out that number. You think that they would. Other cloud service providers, their certification exams, they tell you right on the same page. Good luck finding it on Azure. But 45 minutes would still leave us with about 1 minute per time. Again, it depends if you get the 35 questions or 45 questions. So we're going to have to say about a minute. So we'll say the exam time is 45 minutes. Some people say the seat time is 60 to 65 minutes. When we say seat time, we're talking about the time you should allocate for the exam. That includes things like time to review instructions, read and accept the NDA, complete the exam, provide the feedback at the end. Now, personally, I think that the seat time should always be 30 minutes on top of whatever that is. So if it's 45 minutes, it really would be 75 minutes or 70 minutes or something like that. So, anyway, if you got a 45-minute exam, show up 30 minutes or 35 minutes earlier, because if you're checking in, especially online, you got to pull out your government ID. You got to make sure the lighting is right, and then it scans it in. If things go wrong, it's going to cut in your time. So give yourself ample time and don't get stressed out for that, okay? So these certifications for Microsoft are valid forever. This is specific for fundamental certifications. So if you take the any one that has 900 in the name, so AZ-900, DP-900, AI-900, SC-900, PL-900, MS-900, you get in the pattern here. If it says 900 in the name, it's a fundamentals. Those certifications do not expire. And so I just want to make that very, very, very clear. For the other levels, like associate and expert, I think it's 2 years. It's either 2 or 3 years. But the interesting thing is that if you want to get recertified, you don't have to pay to take the exam again. You can take a simpler test to make sure that your knowledge is up to date. And I think it's free. So that's a great advantage that Microsoft has at the associate and expert level, specialty level. But yeah, there we go. And I'll see you in the next one. All right, so I went onto the internet and I searched for AZ-900, and we've ended up on the learn.microsoft.com. The reason I want to show you this page is to get more familiar with where we actually get the information, so that you can read up about it if we didn't answer everything or if anything has changed. But it's good to be familiar with these pages. So once you're here on the AZ-900, what they'll have down below here is the study guide. Now, the study guide used to be in a PDF format, and for whatever reason, Azure has just made it a website with all the other study guides here. I really don't like this format. I find that it's very hard to find information and to read it. I really prefer the old PDF, but that's never coming back, or if it is, it's somewhere else and I don't know where it is. But what we can see over here is the actual breakdown. So we have cloud concepts, and so we see things like defining cloud computing, share responsibility model, the different deployments of cloud, and a bunch of other stuff here. You can see describing the cloud service types. Now, at one point, they actually removed this, and now it's back, so that's really interesting. I don't know why they ever removed it to begin with, but it's good to see that that is returning. We have, I call this global infrastructure and cloud networking. So they call this core architectural components, which I suppose some of these things are. But this is more like a billing thing, and this is more global infrastructure. Then we have Azure Compute and Networking Services, so we're covering virtual machines, functions, scale sets, availability sets, Azure Virtual Desktop. Now, we don't have to do all these things, and we aren't going to do all these things because some of these things are really hard, like Azure Virtual Desktop is not an easy task, but we need to know what they are. We are going to launch a virtual machine and play around with that a little bit. We are going to launch an Azure function. Then we have storage services. So we do a lot with Azure storage because it is cheap and easy to use. Then we need to know how to perform different operations with Azure, Azure storage there. Then we have Azure Identity, Access, and Security. So again, this is a subcategory under here, or subdomain. So we need to know a bunch of things about security. I'm just going to tell you that some of the content is going to say Azure AD, some of it's going to say Microsoft Entra ID. Microsoft, for some crazy reason, decided to change the name of Azure AD, even though everybody was fine with it. It confuses myself and Bako and everyone else to this day. So just understand that some of it's Azure AD, some of it's Microsoft Entra ID, but this is really what it's going to be going forward, okay? We have described cost management in Azure. So that's TCO, so more pricing stuff here. Azure Purview, Azure Policy. We have the Azure Portal, which is just the platform which we use everything. Azure Arc, which I guess it's okay to know. We actually do a lot of interesting coding here. So I show you how to do IAC with ARM templates and Azure Bicep and Terraform. So that stuff's fun there. We look at monitoring tools. So we look at Azure Service Health, Azure Advisor, all sorts of fun stuff. Now, there could be other stuff that appears in exam that's not on here. And so we just do a very thorough job to show you basically everything and just to kind of round out your knowledge. But again, it's very difficult to find all the details like the time of the exam and the amount of questions. They really just do not make this easily available here. If anyone finds it, please tell me, because I sure can't find it. And the only way I know is by sitting the exam, and I have to remember those details afterwards. They do show what kind of changes that they make. So they're always making teeny tiny changes, but try not to worry about that too much, because we do ensure to include a lot of stuff here. And this exam is up to date and the fresh and as fresh as it can be as of this recording. But I find that even 2 years out, people are passing. People are passing the current exam with the old one, which is really interesting. So it just shows you that not much changes on those exams. Okay. But anyway, that's that. Another thing I want to show you is the exam sandbox. So this emulates the Pearson VUE kind of experience, and it'll just show you some of the question formats. Now, we are under here for the AZ-900, and it might show us more exam types than what we'll actually see on the exam. So go here. This just has 10 questions. It's going to just show us all the types. So here we have multiple choice. Then we have multiple select. I'm not looking at what the correct answers are or reading any of it. I'm just showing you. Here, I believe that we drag these into these areas here. So that's this one. Then this one is your answer area, and you're bringing them over, and then you're trying to determine the order. So you're changing the order here. Then this one's an answer area. So we go here, and it's just an image, and this is draggable. We have this one here. So we look at this graphic, and we try to match it based on this information. We read it very clearly. This one here, what is this for? Hot area. So hot area is you have a graphic very similar to that other one, but you click it, and it's almost like you're kind of interacting with it, but you're not. It's just an image. Then we have a case study. So this is something that we absolutely give you in our platform, and you will not see this on your exam, but we give you this exam question type anyway, because it's super important to get that kind of experience. You'll notice this one's a little bit more robust in terms of the information. And so there are other things. Yeah. Another thing with case studies is when you do a case study, you basically get a series of questions around this case study, right? And it went to the next part. And it's kind of like a mini exam inside the mini exam. I'll show you case studies in another video. So I know I'm going really quick there, but we'll come back to that. Then sometimes you have these additional tabs. So this is kind of like a mini case study for just a particular question, but they might say, hey, check out the exhibit, and you have to look at the exhibit, come back, and then answer the question. So there's that. And then sometimes there's multiple exhibits. So yeah. But yeah, there you go. So that is the sandbox there. So hopefully that gives you a good idea. The price might vary based on where you live. So if we go to Canada, I'm not sure what the price is in Canada. So we go here, and it still shows $199 USD. If we go somewhere else, does it ever show a different price? Sometimes it does. Okay, for some reason Canada gets a bad price, but some other places do a little bit better. So understand that that price is going to fluctuate based on where you live. But yeah, hopefully that gives you an idea of the exam. And we'll see you in the next one, okay? Ciao. Hey, this is Andrew Brown from Exam Pro, and we are at the start of our journey asking the most important question first, which is, what is cloud computing? So cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. And so when we're talking about on-premise, you own the servers, you hire the IT people, you pay or rent the real estate, you take all the risks. But with a cloud provider, someone else owns the servers, someone else hires the IT people, someone else pays or rents the real estate, and you are responsible for configuring cloud services and code, and someone takes care of the rest of it for you, okay? So to understand cloud computing, we need to look at the evolution of cloud hosting going all the way back to 1995, where if you wanted to host your website or web app, you'd have to get a dedicated server. So that would be one physical machine dedicated to a single business running a single project, a site or an app. And as you can imagine, these are expensive because you have to buy outright the hardware, have a place to store it, the network connection, having a person to maintain it. But it did give you a guarantee of high security, and they still do as of today. So this model hasn't gone away, but it's been specialized for a particular use case. Then came along the virtual private server. So the idea is we still had one physical machine, but now we were able to subdivide our machine into sub-machines via virtualization. And so essentially you're running a machine within a machine. And so you had better utilization of that machine running multiple web apps as opposed to having a physical machine per project. So you got better utilization and isolation of resources. And so these two options still required you to purchase a machine, a dedicated machine. And so that was still kind of expensive, but then came along shared hosting. And so if you remember the mid-2000s, like with GoDaddy or HostGator or any of those sites where you had really cheap hosting, the idea is that you had this one physical machine shared by hundreds of businesses. And the way this worked, it relied on tenants underutilizing their resources. So, you know, you wouldn't have a sub-machine in there, but you'd have a folder with permissions that you could use. And so you would really share the cost. And this was very, very cheap. But you were limited to whatever that machine could do, and you were very restricted in terms of the functionality you had. And there was just poor isolation, meaning that, you know, if one person decided to utilize the server more, they could hang up all the websites on that single server. Then came along cloud hosting, and the idea is that you have multiple physical machines that act as one system. So this is distributed computing, and so the system is abstracted into multiple cloud services. And the idea is that you basically get the advantages of a lot of the things above. So it's flexible. You can just add more servers. It's scalable. It's very secure because you get that virtual isolation. You get it extremely at a low cost because you're sharing that cost with the users. Where in the shared hosting, it might be hundreds of businesses. We're looking at thousands of businesses. And it was also highly configurable because it was a full virtual machine. Now, cloud actually still includes all of these types of hosting. They haven't gone away, but it's just the idea that you now have more of a selection for your use case. But hopefully that gives you an idea what cloud hosting looks like. And it really has to come down to distributed computing, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at common cloud services. So a cloud provider can have hundreds of cloud services that are grouped into various types of services. And the four most common types of cloud services for infrastructure as a service, and we'll talk about what that is later on, would be compute. So this is where you have a virtual computer that can run applications, programs, and code. Then you have storage. So this is where you would have virtual hard drives that you could store files. Then you'd have virtual networking because you have these computers and storage. So you need to put them in some kind of virtual network. And then you have databases. So just imagine a database that is running in the cloud, or if you're not familiar with databases, just imagine that it's Excel in the cloud, but it powers your web apps. And one thing I want you to know about the term cloud computing is that even though it says computing in the word, at this point, we just use it as a catch-all term. So it could refer to all of these categories. So when I say cloud computing, I could be referring to compute, network, storage, and databases. But you can also say cloud storage, cloud compute, cloud databases, cloud networking, and people will know what you mean. Hey, this is Andrew Brown from Exam Pro, and we are looking at what is Microsoft. So you've probably seen this logo before, and Microsoft is an American multinational computer technology corporation headquartered in Redmond, Washington. And Microsoft makes software, phones, tablets, game consoles, cloud services, which is what we care about here today. And they even have a search engine, and we're not just limited to that list. They have tons of stuff. But Microsoft is best known for their operating system called Windows, and they've been around since the 1970s. So they've been around for quite a while in the tech sphere. So now that leads us to the question is, what is Azure? So Azure is what Microsoft calls their cloud provider service. And so it's called Microsoft Azure, or we commonly refer to it as just Azure. And so here is the logo for it. And if you're wondering what is the name behind this service, it means bright blue color of the cloudless sky. So sure, that's great. And so you'll hear me say cloud service provider frequently throughout this course, and it is abbreviated to CSP, but that's what Azure is. It is a cloud service provider. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the benefits of cloud computing. So what are the benefits? Well, we have a big list here for you, starting with cost effectiveness. So you pay for what you consume. There is no upfront cost. You pay as you go, also abbreviated as PAYG, and you're sharing the cost with thousands of customers. So that's how you're getting that low cost. Another benefit is that you can go global. So launch workloads anywhere in the world. Just choose your region. And you are now in the global market. Another benefit is the cloud is secure. So cloud providers take care of the physical security, and cloud services can be secure by default, or you have the ability to configure access down to the granular level. So you have a lot of security controls that you would have that you would normally not have, or you'd have to build out on-prem. Now, the cloud is also known for being reliable, so you can have data backups, disaster recovery, and data replication and fault tolerance. The cloud is also scalable. You can increase or decrease your resources and services based on the demand. The cloud is also elastic, so you can automate scaling during spikes and drop the demand when there is no longer the demand for that stuff. And it's also current. So the underlying hardware and managed software is patched, upgraded, and replaced by the cloud provider without interruption to you. And I mean, the last one, there is cases of interruption, but generally fewer interruptions than you would have on-prem. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the different types of cloud computing, and we have this nice pyramid on the left-hand side to help us understand how each type builds off the other. Starting at the top of our pyramid, we have software as a service, also known as SaaS. And this is a product that is run and managed by the service provider. You don't worry about how the service is maintained, and it just works and remains available. So you might not be aware of this, but you probably already are using a SaaS product. So examples of that could be Salesforce or Gmail or Office 365. So those are things that would be considered SaaS, and these are really for customers. So it's just you wanting to use software, like general software on your computer, but in the cloud. The next category we have is platform as a service, abbreviated as PaaS. And so here we focus on development and management of your applications. And so you don't worry about provisioning, configuring, or understanding the hardware or OS. And this is really for people that are building apps, but they don't think about any of the infrastructure underneath. Services like this would be Elastic Beanstalk on AWS, Heroku, which is very popular amongst junior developers, which is a third-party service for launching web apps. And then you have the Google App Engine. So those are 3 examples there. And these are really for developers. So Platform as a Service makes it easy for developers to build apps on the cloud without worrying about all the stuff underneath. And at the bottom, we have Infrastructure as a Service, IaaS. And this is the basic building blocks of cloud IT. So provide access to networking features, computers, and data storage space. Don't worry about IT staff, data centers, and hardware. And this is the true focus of our course here, is focusing on this layer. But the thing is, again, on this pyramid is that the infrastructure service can have platform as a service and software as a service on top of it. And so examples of infrastructure as a service would be Microsoft Azure, AWS, or even Oracle Cloud. And so this is really intended for administrators. So that is the 3 types of cloud computing, and there you go. Hey, this is Andrew Brown from Exam Pro, and we were looking at the types of cloud computing responsibility. So we saw the 3 categories there, but we don't really understand what it is that we're responsible for and what is the cloud service provider responsible for. So let's lay out our categories, and we're going to include on-premise into this because technically on-premise could be a private cloud and should be in the category here. So we have on-premise, infrastructure as a service, platform as a service, and software as a service. So when we're looking at applications, it's going to be the customer's responsibility for on-prem infrastructure, PaaS. But when we have software as a service, the cloud service provider is responsible for that. When looking at the data level, it's going to be the same. For software as a service, the cloud service provider is going to be responsible, but for the rest, it's going to be the customer. And then on the next level, for the runtime, it's going to be responsible on the cloud service provider for the platform as a service and software as a service. For middleware, it's going to be the same. For the OS, like the operating system that is running on the service, it's going to be the same. Then when we get to virtualization, now it's the virtualization is responsible with the cloud service provider and above. And then for storage, servers, it's the same. For storage, it's the same. And for networking, it's the same. So you can see that on-premise, you're responsible for everything. And the farther we move up the types of cloud computing, the less responsibility you have. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure's deployment models. And the first model we're going to talk about is public cloud. And that's where everything is built on the cloud service provider. You're not using anything on-prem or in your own data centers. Everything is running within Azure. And generally, this is known as cloud native, but for some reason, Azure calls it public cloud. So that's what we're going to use in the terminology here. And so here I have an architectural diagram where we have a network on Azure, and within that network, we have a virtual machine running and a database running. So that would be an example of public cloud. Then we have private cloud. And so this is where everything is built on the company's data centers, also known as on-premise, because it's within the premises of the organization, like their physical location. And an organization could technically be operating their own cloud, but it would be private cloud, and they could be running some open source cloud software that mimics what Azure would do, such as OpenStack. So it looks very similar, but you just put an OpenStack in there, and it's running a virtual machine or a server, and it's also running a database. And the last on our list here is a hybrid. So with hybrid, you are using both on-premise and the cloud service provider, and they're connected together. And so there's a lot of different networking services that you can use that will facilitate the connection between the two. In this case, we're using ExpressRoute. ExpressRoute is a dedicated connection. It's like having a fiber optic line running from your on-premise data center to the Azure network. So it's just one of the ways you can connect. And if we wanted to understand like the pros and cons, I have this nice little table here. We'll just quickly go through it. So if you're using public cloud, it's more cost-effective. Security, its security controls are stronger by default, but some people might not find the cloud will meet all their security requirements because of government and regulatory reasons, not because the cloud is not secure, but it's just those policies. For level of configuration, it's going to be limited based on what the cloud service provider exposes to you. Still, there's a lot of configuration there. It's just that if you have your own servers, you obviously can do anything and everything with them. For technical knowledge, you don't need to have as much in-depth knowledge of the underlying infrastructure because you're not physically setting up servers or that networking and everything else. Now, coming down to private cloud is the most expensive option on our list. So you're going to be paying a lot of money there. For security, there is no guarantee that it is 100% secure because you just don't have the same kind of visibility that you would have with a cloud service provider with all those dashboards. It's just so hard to build out all that software. But you could meet your security compliance requirements depending on your situation. But this is becoming less and less as more governments and larger organizations move over to the cloud. You can configure infrastructure exactly how you like because you literally have bought the hardware and do anything you want with it. And the technical knowledge, you'll have to have a serious amount of technical knowledge. You might even have a really hard time finding the resources to maintain all that stuff. Then down below, we have the hybrid model. So this could be more cost effective based on what you offload to the cloud and also the cost of actually moving data back and forth. For security, you have more to secure, but technically some things are easier to secure on the cloud than it is in private. So maybe you have a boost in security. You're going to get the best of both worlds in terms of configuration. And for technical knowledge, you're going to need to know both the cloud and like how to set things up on premise. So that's the most work there. And just one more deployment model here. I just want to talk about cross-cloud. This isn't something that is listed on the actual exam, but it's something that you should understand and know. And so cross-cloud is when you're using multiple cloud providers. Sometimes people refer to this as multi-cloud or hybrid cloud. And so I just have an example here. So there's a service called Azure Arc. And what Azure Arc does is it extends your control plane so you can run Kubernetes containers on different platforms. And so you could have AWS on the left-hand side with EKS and GCP Kubernetes engine. And so you could be running virtual machines and they're all treated like they're on the same network. So cross-cloud is becoming very popular with extremely large organizations where they have very unique requirements. But I definitely want you to know what that is because it just gets left out. And it's definitely something that is part of the industry. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of total cost of ownership, TCO. So what is the difference between on-premise, so having your own data centers, and then using Azure? And you'll notice above it, it says CAPEX and OPEX. We're going to talk about that in the next slide. But for the time being, we're going to focus on the total cost of ownership. So to really make sense of this, I always use this graphic here. And if you're wondering what that is, those are icebergs. People sometimes think they look like teeth. And so just to make this drawing a little bit more clear, I've added some penguins and a whale, so there's no mistaking it. And the reason we're using this as a representation is because we have the top of the iceberg, which are the costs that we're generally concerned about, but then we have those hidden costs, those costs that we're not really thinking about that is underneath the water. And if you know icebergs, they can be really big underneath. You don't know. So on the left-hand side, the cost that we generally think of is the software license fees. And then for the cloud service provider, we look at the subscription fees. And so when you're comparing these two, sometimes the subscription fees can cost more than the software license fees. So you'd think, well, we should really just use on-prem because it's more cost effective. But when we take in the total cost of ownership, all the costs involved, we're going to see a very different picture. So on the left-hand side, if you are on-premise, you have to deal with the implementation, the configuration, and the training, but you also have to deal with the physical security of your building. You have to pay for the hardware. You have to pay for the IT personnel. You have to deal with maintenance. Now, on the right-hand side, on the cloud, you still have to do implementation and configuration and training, but that's about it. So there's a big difference in terms of what you have to do. And you might ask, okay, well, what is the amount of savings? Well, generally, people find that when they move from on-prem to the cloud, they save 75%. That's a lot of money, okay? 75% of what you generally would spend. And so now all this stuff on the left-hand side is now Azure's responsibility. You don't take care of those anymore. Azure's going to take care of it for you. So that's total cost of ownership. Hey, this is Andrew Brown from Exam Pro, and we are looking at capital versus operational expenditure. So on the left-hand side, we have CAPEX, so capital expenditures. On the right-hand side, we have operational expenditures, OPEX. And so looking on the left-hand side, capital expenditure is spending money up front on physical infrastructure. So deducting the expenses from your tax bill over time. A lot of companies, larger companies, are used to dealing with capital expenses, and they know how to work their tax bill. And so that's why a lot of people are afraid to move over to the cloud because they're used to this way of operating. But let's talk about some of the things that would be considered a capital expense. So again, it's anything that's physical, and then you're buying it with money up front. So computers, so that would be your server costs. If you were to buy hard drives, that'd be your storage costs. If you bought routers, cables, and switches for your network. If you were purchasing things for backup and archive costs. If you had disaster recovery, so like an uninterruptible power supply would be an example of that. You have your data center costs, so that's your rent, cooling, physical security. Your technical personnel, so you're hiring people to do things for you. And so with capital expenses, you have to guess upfront what you plan to spend. Now let's look at operational expenditure. So operational expenditure is the cost associated when an on-premise data center has shifted that cost to the service provider. So here, in this case, it's the cloud service provider. And the customer only has to be concerned with non-physical costs. So what's examples of OPEX costs? Well, leasing software and customizing features, training employees in cloud services, paying for cloud support, billing based on the cloud metrics, so compute usage and storage usage. And the advantage here is that with operational expenses, you can try a product or service without investing in equipment. So We have flexibility of investment. And we also, from the previous slide, we saw that we have a huge reduction in cost. So there's two reasons, really good reasons to use the cloud. Let's take a look at cloud architecture terminologies. Before we do, let's talk about some of the roles that are around doing cloud architecture. So the first is solutions architect. This is a role in a technical organization that architects a technical solution using multiple systems via researching, documentation, and experimentation. And then you have the cloud architect. This is a solutions architect that is focused solely on architecting technical solutions using cloud services. Understand that in the actual marketplace, a lot of times solutions architect is used to describe both a cloud architect and a solutions architect. And, these are going to highly vary based on your locality and how companies want to use these terms, but this is just me broadly defining them here, so just don't take them as perfect word in terms of what they're representing. So a cloud architect needs to understand the following terms and factors and factor them into their design to architecture based on the business requirements. So we have the idea of availability, your ability to ensure a service remains available; scalability, your ability to grow rapidly or unimpeded; elasticity, your ability to shrink and grow to meet the demand; fault tolerance, your ability to prevent a failure; disaster recovery, your ability to recover from a failure. And there are a couple other things that that should be considered. They're not terminologies, but they're definitely important to a solutions architect or a cloud architect. And these are things you always need to consider as well. And this is just me talking to my solutions architect friends, where they'll always ask me these two questions after presentation. They'll say, how secure is the solution and how much is this going to cost? All right. And so for the terminologies up here, we're going to define these right away, and we're going to figure these out throughout the course. We have two giant sections just on cost and security alone. So there we go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of high availability. So this is your ability for your service to remain available by ensuring there is no single point of failure or ensure a certain level of performance. So here I have a technical architectural diagram that is describing high availability. So the idea behind this is that if you have a server which runs your web application, if you were to run redundant versions of your server, if anything happened to a single server, traffic could always be routed to those other servers, and that way your service would remain available. Now, having multiple servers is great, but even what's better is having multiple servers in multiple data centers, because something could happen to a data center. It could become unavailable because of a networking issue. So by being able to route traffic, or that way, you're going to remain highly available. And running a workload across multiple availability zones, and availability zones is what Azure calls their data centers, ensures that if one or two data center becomes unavailable, your service will remain available. Very, very common to run at least 3 servers across 3 data centers. Now, how would you distribute the traffic or manage the traffic to all 3? And that's where an Azure load balancer comes into play. That green triangle with the arrows, that is the representation of a load balancer. So a load balancer allows you to evenly distribute traffic to multiple servers in one or more data center. And if a data center or server becomes unavailable, so unhealthy, the load balancer will route the traffic to only available data centers with servers. So there you go. That is high availability. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of high scalability. And this is your ability to increase your capacity based on the increasing demand of traffic, memory, and computing power. If you are a growing company, you're going to have to scale up. You're going to have to get bigger and better servers. But there are different types of scaling, and the first type is vertical scaling. This is the most obvious one people are going to think of, and it's called scaling up. And what we do is we just upgrade to bigger servers. We need bigger hard drives, faster computers. That's vertical scaling. But there's another kind of scaling called horizontal scaling, and horizontal scaling is described as scaling out. And what you're doing is you're just adding additional servers, because we saw with the high availability, we have a load balancer. We can distribute traffic to multiple servers, and 3 servers can equal the same thing as one big server. So horizontal scaling is when we add more servers of the same size. Hey, this is Andrew Brown from Exam Pro, and we're looking at the concept of high elasticity. And this is your ability to automatically increase or decrease your capacity based on the current demand of traffic, memory, and computing power. So this sounds a lot like high scalability, but the key difference is that it's automatic and you can decrease the demand, not just increase it. And so the way we would do that is that we would have a virtual machine or server, and if we needed more servers, we would add more servers, and if we needed less servers, we would remove less servers. And so this is going to be accomplished using horizontal scaling. So when we say we're scaling out, this means we're adding more servers of the same size. When we're scaling in, this means we're removing more servers of the same size. And generally, you're not going to use vertical scaling for high elasticity. It's just extremely difficult to vertically scale, because if you have to increase, let's say, your storage drive, and then you decrease it, you could lose data. So it's not a good idea or even feasible to do vertical scaling with high elasticity. Now, how would you accomplish being elastic on Azure? Well, you'd use Azure's VM scale set. So scale sets automatically increase or decrease in the response to demand or based on a defined schedule. And we'll talk about those in greater detail later in this course. And then we have SQL Server or Server Stretch Database. These dynamically stretch warm and cold transactional data from Microsoft SQL Server 2016 to Microsoft Azure. Not something we're going to cover, but it's generally the same concept that scale sets do. So there you go. That's high elasticity. Hey, this is Andrew Brown from Exam Pro, and we're looking at the concept of being highly fault tolerant. And this is your ability for your service to ensure there is no single point of failure preventing the chance of failure. So when we looked at high availability, we had also said that was no point of failure. But when we really talk about that, we're really talking about being highly fault tolerant, because there is the word failure in the word, and that is what being fault tolerant is. And so how do we prevent failure? Well, we use the concept of failovers. So failovers is when you have a plan to shift traffic to a redundant system in the case a primary system fails. And so I have a graphic here that represents a primary database failing over to a secondary database. And I have a bit of a description here. So the idea is that we have a copy of our production database, and we're going to call that a secondary system. And the idea here is that every time something is written to our primary database, it's going to be synced. So it's going to be sent over to our secondary database. So it's up to date with the latest database. And then if the primary database happens to fail for whatever reason, whether it's hardware or otherwise, something's going to detect that there's something wrong with the primary, and it's going to fail over to the secondary. And the secondary is going to be promoted to being the primary instance. And the key thing to understand is that secondary is standby. It's not in actual use. It's only in use when the failover occurs. So what would you use in Azure to build out a highly fault-tolerant system? That's where Azure Traffic Manager comes into play. So with this, and this works at the DNS level. And so the idea here is that you can fail over from a primary system at the DNS level to a standby. This is really great if you have regional failures. You could probably also use a load balancer, but this is the case that I'm showing here. But there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at the concept of high durability. So this is your ability to recover from a disaster and to prevent the loss of data. So this could be solutions that recover from a disaster is known as disaster recovery, DR. And so I'm just going to ask you a bunch of questions to help you think about how to be highly durable. So one question would be like, do you have a backup? So do you have a backup in place? How fast can you restore your backup? Does your backup still work? How do you ensure current live data is not corrupt? So that is the concept of high durability. There's a variety of services to implement it. So it's not just a single service. But there you go. That is the full list of cloud architecture terminologies. So to understand disaster recovery, we need to know more about things around it, like business continuity plans, BCPs, and RTOs and RPOs. So a BCP is a document that outlines how a business will continue operating during an unplanned disruption in services. So it's basically the plan that you're going to execute if that happens. And so here we have a disaster, and you can see that there's a chance of data loss and downtime. And these two factors as RPO and RTO are going to define the length of these durations. So recovery point objective is the maximum acceptable amount of data loss after an unplanned data loss incident expressed as amount of time. So how much data are you willing to lose? And then recovery time objective, so the maximum amount of downtime your business can tolerate without incurring a significant financial loss. So how much time you're willing to go down, okay? So those are the two there. And now let's go take a look at the disaster recovery options that we can use to define in our BCP. So now let's take a look at our disaster recovery options. And based on what you choose, they're going to be a trade of cost versus time to recover based on the RPOs or RTOs, of course. And so sometimes this is represented vertically like a thermostat, or you can do it horizontally here. Both are valid ways of displaying this information, but I just have it horizontally here today. And so we have low or high, or you could say, even though I don't have it written here, this could be cold or this could be hot, okay? So on the left-hand side, we got backup and restore, pilot light, warm standby, multi-active site. Notice we're using the words like pilot light, warm, things that are relating to temperature. So again, cold and hot, all right? So let's just walk through what each of these things conceptually do in terms of architecture. So when you're doing a backup and restore, you basically back up your data, and at the time of disaster recovery, you're just going to restore it to new infrastructure. For a pilot light, the data is replicated to another region with the minimal services running to keep on replicating that data. And so you might have some core services running. A warm standby is a scaled down copy of your infrastructure. So you basically have everything that you would absolutely need to run an application, but the idea is it's not at scale. And so at any time when there's an incident, you're going to scale up to the capacity that you need. And then you have multi-site active, where you have a scaled up copy of your infrastructure in another region. So basically everything you have identically in another region. And so in terms of the RPOs and the RTOs, for backup and restore, you're looking at hours. With the pilot light, you're looking at 10 minutes. With a warm standby, you're looking at minutes. And multi-site active, you're looking at real time. So, hopefully that gives you an idea of, the difference in terms of scale. But let's just look at more detail. So for a backup and restore, this is for low priority use cases, restore data after event, deploy resources after an event, and it's very cost effective. For pilot light, this is where you have less stringent RTOs and RPOs, so that you're going to be just running your core services. You're going to start and scale resources after the event, and this is a little bit more expensive. This is very good for, warm standby is good for business critical services. So you scale resources after the event, and it's it's costly, but it's not as expensive as a multi-site active. So you get zero downtime, near zero loss. It's great for mission critical services, and it's just as expensive as your original infrastructure. So you're basically doubling the cost there, okay?
Hey, this is Andrew Brown from Exam Pro, and we are looking at the evolution of computing, and this is going to really help you to understand the different layers of compute. And so we're going to start from on the left-hand side to dedicated and work our way all the way to functions. So what I want you to know is that when we're talking about dedicated, this is a physical server wholly utilized by a single customer. And so the idea is that this customer has purchased this dedicated piece of hardware. But the thing with this is that you have to guess your capacity. So when you buy it, it's like a capital cost, or you're purchasing for like the whole, like you have to plan how you're going to fully utilize it. So you're going to overpay and you're going to have underutilized servers. And the reason why is that when you first launch your app, it might be small, and then you're expected to grow into that space, but you're just not using that space until you grow into it. So it's considered wasted. If you want to upgrade beyond your capacity, this is going to be slow and expensive. You literally would have to buy a new server that's larger and then move everything over. You're going to be limited by your operating system. So whatever operating system is installed, that's what you're going to have. You're going to have multiple apps. If you do install multiple apps onto a dedicated server, you might have conflicts in resource sharing, but generally it's recommended to only have a single primary application on a dedicated server. You are going to have a guarantee of security, privacy, and full utility of the underlying resources, because that's the whole purpose of having a dedicated server is. Sometimes dedicated servers where you have full control of everything is called bare metal. And that's basically mimics what it was like to have a server on premise or back in the day. And they still exist. So that is dedicated. We'll move on to VMs. So now we're moving on to virtual machines, also known as VMs. And so the idea here is that if you had a physical server and you had the capability of running virtual machines, that's like running a machine within a machine. And so now you're able to run multiple applications on a single machine. The technology that's used to actually run VMs is known as hypervisor. There are some other kinds, but the ones we need to know is hypervisor. So just know that that's the software that makes virtual machines work. You are now sharing the physical server with multiple customers. That is generally a good thing because you are paying a fraction of the server cost. You don't have to buy that server outright. You are still going to be overpaying for the underutilization of a virtual machine because it still has that issue of wasted space because you have to choose a particular size of virtual machine. It's not going to be perfectly fit for your application. You are going to be limited by your guest operating system. So whatever OS that you've chosen, that's what you get. So that's what you have there. If you want to run multiple apps on a single virtual machine, they can still result in conflict resource sharing. But now customers that are isolated from you aren't going to conflict with you. So you could run if you had 3 apps, you could run them as 3 virtual machines. So you're not gonna have that issue. But if they're on the same VM, you still have that issue. So there you go. That is virtual machines, and we'll move on to containers. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of containers. And so this takes it a step further where we have virtual machines and we're running multiple containers. So we're further subdividing the way that we run our applications. And the technology that is used to run containers within a VM or on a physical server is called Docker Daemon. If you're using Docker for containerization, that's the most common one. But that's going to let you run multiple containers, and you can maximize the utility of the available capacity. So this is extremely more cost effective, right? So that available space is always there for you to launch more servers within, or you can expand the usage for your app to take up that available space. Your containers share the same underlying OS, so the containers are more efficient than multiple VMs. But the great thing is that you can have different OSs. So the idea is that each container can technically be running a different OS. And so now you have a lot more flexibility. It doesn't seem like you could improve upon this further, but we will when we move over to functions. So now we're going to take a look at the evolution of computing for functions. And I bet you didn't believe it, but we subdivided it even further. And so we've taken our applications that were running containers and we broke up the apps into little pieces of code called functions. And now we even have more or better utility of our compute. So we have a managed VM running managed containers. So we don't have to worry about the containers and configure them ourselves. Functions are usually taken care of. This is known as serverless compute because you don't set up anything. You just put your code online and it just works. You might choose the memory and the duration that you need to utilize, and that's all you pay for. You're only responsible for your code and data and nothing else. And it's extremely, extremely cost effective, right? Because you are just paying for that individual function to run, and all that underutilized space is the problem of the cloud service provider. It's not your issue. The only downside is that there is a concept called cold starts, meaning that when you launch a function or serverless code, it generally has to provision a server because the cloud service provider doesn't want to be running servers when they aren't being utilized. So you might experience a cold start where you're waiting for a server to start before your code will execute. But there's definitely ways around that. So there you go. That is the evolution of compute. Hey, this is Andrew Brown from Exam Pro, and we are looking at regions and geographies for Azure. So a region is a grouping of multiple data centers, and for Azure, they call their data centers availability zones. Azure has 58 regions available across 140 countries. One thing Azure likes to promote is that they have the most regions out of all cloud service providers. Then we have something what we call a geography. So a geography is a discrete market of 2 or more regions that preserve data residency and compliance boundaries. And the geographies that are available for Azure, we have the United States. Then there's Azure Government US. This is a geography that's only for the US government. so regular citizens cannot use it. Then you have Canada, that's where I'm from, Brazil, and Mexico. And I just want to emphasize that data residency and compliance boundaries for geography. And I just want to give you an example. So imagine you live in Canada and you work for a Canadian company. You want to guarantee that the data will remain within Canada for whatever government regulatory reasons. So then you'd want to use the Canada Azure geography because that data would never leave Canadian soil. So that's the case there. And I just want to give you kind of a visual example. So on the left-hand side, we have two regions. We have US East 1, and we have the Europe Norway East region. And in those regions, I'm not showing it here because I don't want to make it too complicated, but there would be availability zones, and we could launch resources. So we have some servers, virtual machines. Those are the images you see within the regions. And generally, the way regions work in Azure is that when you go to launch a resource, you choose the region at that time of creation. So if you're launching a virtual machine, it's going to give you an option to choose a region, and then you just choose from that list. So yeah, there you go. So I just made my way over to Azure. So I just typed in Azure Global Infrastructure because I just wanted to show you the big map of all the regions and where Azure is available all throughout the world. Because sometimes it's nice to look here. So we can see we have stuff down in Australia. We have regions in Africa. We have a region in South America. We have a lot in North America. We have a lot in Western Europe. And then we have some in Asia here. So we have Japan, China, all over the place. So, if you want to look a little bit more into that, there's a lot of good information here on the global infrastructure pages. But that's about it. I just wanted to show you that world map. So now we're looking at paired regions. So each region is paired with another region 300 miles away. And the reason why Azure does this is so that if one region is being updated, then the other one is still available, meaning that if you're planning to make sure that you never have downtime, you can put your resources in that paired region, and then you're going to have higher availability. So some Azure services rely on paired regions for disaster recovery. So when you turn those services on, they're automatically going to launch in that paired region. One service which would help you leverage your paired region would be a service called Azure. It's a feature of storage, but it's called Azure Geo-Redundant Storage. So it replicates your data to secondary region automatically, ensuring that the data is durable even in the event that the primary region isn't recoverable. And just to give you an example of a paired region, so let's say we're talking about Canada. So with Canada, you'd have Canada Central, and then its paired region is Canada East. For North America, and when we say North America, we're really talking about the United States, it's East US region paired with the West US region. And then for Germany, you have Germany Central and Germany Northeast. So it gives you an idea how far away they are, 300 miles. That's quite a distance, but there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at region types and service availability for Azure. And what I want you to know about service availability regarding regions is that not all cloud services are available in every single region. And there's infrastructure reasons as to why, and there's compliance reasons as to why. So Azure has two types of regions. They have recommended regions. These are regions that provide the broadest range of service capabilities. What that means is that the majority of services are going to be available in this region. And this recommended region is designed to support availability zones. Then you have alternate regions. And these are regions that extends Azure's footprint within a data residency boundary where a recommended region also exists, but they're not designed to support availability zones. That doesn't mean you can't launch resources within them. It just means that when you go to launch a resource, you're not going to choose an availability zone. And these regions are labeled as other when you're in the Azure portal. Now let's talk about general availability. So general availability, abbreviated to GA, is when a service is considered ready to be used publicly by everyone. So if you have a service or product and it was in beta and now you're ready to sell it to people, that means that it's GA. But just because it's ready to sell, there's also the conversation around whether it's actually available to use. And that's going to be determined based on the category that the Azure Cloud Service is in. And so Azure categorizes 3 different types of availability for services. And the first one is foundational. So a cloud service that is foundational is going to be available immediately in a recommended and alternate regions when it goes GA, or at least in 12 months of the time that it was announced. Then you have mainstream. So these are cloud services that will become immediately available in a recommended region or in 12 months when it goes GA. But for the alternate region, it may become available based on the customer demand. And then the last one is specialized. So cloud services that are in this category will become available in recommended or alternate regions based on customer demand. So hopefully that clears up service availability and region types. Hey, this is Andrew Brown from Exam Pro, and we are looking at special regions for Azure. So Azure has specialized regions to meet compliance or legal reasons because they might want to work with specific governments and to meet those requirements, they basically give them their own region. And so the first on our list is the U.S., and we have 3 regions that we know about. So we have the U.S. Department of Defense Central, the U.S. Government Virginia region, the U.S. Government of Iowa region, and then we have an additional 3 that we just don't know about it because they're in secret locations. So maybe they're for Area 51. We don't know. And so the reason why they have these special regions is that if you just want to do business with the government, they need these kind of regulations. Then on the other side, we have China. And so they have a region in China East and China North. And these regions are available through a unique partnership between Microsoft and 21 Vianet. And so Microsoft does not directly maintain these data centers, but they work with 21 Vianet to give you accessibility to these regions. And probably to operate these regions, you'd probably be a citizen of these countries, and you'd also be an employee of the government. So it's not going to be for citizens to use. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at availability zones for Azure. And so availability zones abbreviated to short for AZ, and you'll hear me using that abbreviation a lot in this course, and you should learn to remember that as well. It's a physical location made up of one or more data center. And so a data center is a secured building that contains hundreds of thousands of computers. And if you want a little visual, here is the inside of a data center. And there's a technician working on a rack of servers, and there's a dog in the data center. You should definitely never have a dog in your data center. You'll probably hear me refer to availability zones as a data center because it's the easiest way to think of it, but it actually can be more than one data center. Now, a region will generally contain 3 availability zones. I say generally here because there are cases where there are less than 3, but there's actually very specific reasons as to having exactly 3 availability zones. Data centers within a region will be isolate from each other, so they'll be in different buildings, but they will be close enough to provide low latency. And that low latency would probably be in the sub-milliseconds. I don't know what it is for Azure, but that's generally how it would be designed because you want it to feel like it's on the same network. It's common practice to run workloads in at least 3 AZs, and that's why I was saying that earlier. That's important to ensure services remain available in the case 1 or 2 data centers fail, and this is called high availability, and we'll definitely cover this concept again in this course. Just to give you a bit of a visual, on the left-hand side, what we have is a region called US East 1, and we have multiple availability zones. Azure just labels them 1, 2, and 3. And so when you go to launch a resource, if you look on the right-hand side, you choose your region. So we are choosing US East US. Then we are saying we're going to use the availability zone, and then we choose which one we want to launch it into. So if we choose 2, it's going to go into availability zone 2. That doesn't mean we're going to launch 2 instances. It just means availability zone 2. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at AZ-supported regions for Azure. And so not every region has support for availability zones. And we touched on this in the region section, but we'll touch on it here again. So we know that there are regions called alternate others, and these do not have availability zones whatsoever. Then you have recommended regions, and these are supposed to have 3 AZs. The reason why they might not have them is because it's a newer region, and Azure is promising to add more regions within 12 months or whatever time period that they say. But generally what you want to do is when you have cloud resources, you want to launch them where they have at least 3 AZs. So which regions actually have 3 AZs? And that is Central US, East US2, West US2, West Europe, France Central, Northern Europe, Southeast Asia. So that is where you generally want to run your workloads. Now, what does it look like when you try to go launch a resource and you choose a region that doesn't have an availability zone? What's that going to look like? Well, it's going to look like this. So you're going to availability zone is going to be blanked out, and you'll have to choose no infrastructure redundancy required. And so that would be the example for Brazil South, where it's just there is a single AZ, but it's described as not having AZ, so you just don't choose it in the interface. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at fault and update domains. So an availability zone in an Azure region is a combination of a fault domain and an update domain. So a fault domain is a logical grouping of hardware to avoid a single point of failure within an AZ. And so basically it's a group of virtual machines that share a common power source and network switch. The reason why Azure does this is that so if part of the data center fails, then other servers won't be taken down with it. So let's say there's a fire within the data center in one particular region, it won't affect other hardware that is running. Then you have update domains. And so update domains is when Azure needs to apply updates to the underlying hardware and software. But the thing is that because Azure is updating them, it takes these machines offline. So the idea is that if you run your workloads in another domain, in the update domain, neither domain will be updated at the exact same time. And that way you won't have downtime because of updates. And so the way fault domains and update domains work is that you use availability sets. So availability sets is a logical grouping that you can use in Azure to ensure that your VMs you place in the availability set are in different fault update domains to avoid downtime. And just to really help with that visual here, what I'm going to do is just show you this here. So each virtual machine in availability set is assigned a fault domain and an update domain. And so what you're looking at here is, you see those gray boxes? Those are racks in your data center. A rack is just like, it's like a closet for servers, and all those servers sit on top of each other. And so each of those servers in that is where your virtual machine might be deployed. So if you have a server and it's deployed in fault domain 0 and fault domain 1, it could be in any of the servers on that rack. But then update domains, you just might have very particular servers in that rack that are those update domains. So hopefully that makes that a bit clear. I know it's a little bit confusing, but just remember the concept behind fault domains and update domains. And just to give you a visual of what it would look like in the Azure portal, if you go ahead and create availability set, you would name it. So here I call it production, and you would choose the fault domains and you would choose the update domains. And so I believe that what you're doing there is that you're choosing the amount of domains that you want your virtual machines to be distributed across. And I keep on saying virtual machine, that's your server, okay? So if you say 2 fault domains, that means that when you launch 2 servers and you put them into that availability set, they're going to be across 2 different fault domains. And if you launch 5 servers and your update domains is at 5, that means it's going to be across 5 different servers that are isolated from each other. So hopefully that makes sense, but that's fault and update domains. So I quickly just wanted to show you the fault and update domains that are in Azure here. So the idea is if you're launching a virtual machine and you want to control the availability set, what you can do is you can go down to here where we have availability options. We're going to drop it down and choose availability set. And then we don't have an availability set, so I'm going to go ahead and create one. If I just click there. And so when we create a set, we can say, production set. And so we have these two dialogues here. And so what it is when you say there's 3 fault domains, that means that if you were to launch 3 VMs and you put them all into this availability set, it'll be spread across 3 different racks so that if a rack goes out, 2 other racks are operational, and so your service will remain available. And then down below, it's the same thing. On a rack, there might be multiple machines, and certain machines will be will be scheduled for updates, but they won't all be updated at the same time. So if you're saying this, you'll say spread it across 5 machines, and that's all there really is to it. So I just wanted to show you where that was when you actually launch it for a virtual machine.
Hey everyone, it's Andrew Brown, and welcome to another follow along, and probably the most important one, which is how to create your Azure account. So what I did is I typed into Google Azure Microsoft portal, and so it brought me to here. This page might look a little bit different. It really just depends on where you land in, but a lot of times they make it very easy by having this try Azure for free, getting started, free account. So just find one of the ways in. They probably go all to the same place. So I'm going to go ahead and click Start Free. I'm going to get out of the way so that we can do this. Now, I already have an existing Microsoft account. That's what you need in order to access Azure. So I'm going to go here and say sign in with another account. I'm going to create another account. I'll go ahead and create one. Of course, you probably already have an account, or if you don't, you can go ahead and start typing one in. So I'm going to need an alternate email to utilize for this. So just give me a moment, okay? So I was just thinking about it. I actually already have another email called andrew@teacherseat.com. It's the name of our platform that runs Exam Pro. So I'm going to go ahead and try this and see if that works. You can't sign in here with a work or school email address. Use a personal email such as a Gmail. Okay, so it's not letting me do that there. But maybe we can get ourselves a new email address, and that will be one way in here. Now, of course, you don't need to create an Outlook or Hotmail. You can, of course, use something else, but I'm just going to create a new account to make my life a little bit easier while demonstrating this. I'm going to type in Exam Pro Andrew Brown, and hopefully it will allow me to have that hyphen there. And so I need to choose a password, so just give me a moment. Also, if you're looking for a password manager, or sorry, a password generator, I tend to like this one called passwordgenerator.net because it works really well. So that's the one that I'm going to use, but I'm going to take this off screen here for a moment and just put a password in, okay? So I've just generated out a password, and hopefully it will let me go ahead and create that. So we're in good shape. And so I'll fill in the next information here. So I don't want to expose all my personal information. So I'm just going to fill this in and hit next. So you'll see me jump to the next screen. Okay. And so it is progressing, and we're just waiting for new things to happen here. And so now I have a little puzzle to solve. So just give me a moment. I just want to save the password before I lose it. Okay, I just saved my password off screen here. Let's go ahead and solve this. So please solve the puzzle so we know you're not a robot. How do I solve it? Do I need to put my headphones on? Just give me a moment here and take a look. So let's go ahead and hit next. So use the arrows to rotate the animal to face the direction of the hands. Well, it's already facing it, so I guess we're in good shape. That was not quite right. Oh, maybe the direction of where the hand is pointing. Okay, we'll try that again. So there we go. And we'll try that again. A very interesting challenge. That's the first time I've ever seen that one, but that's interesting. And we'll give it a moment here. And so now we can fill in all of our information. So of course, again, I don't want to expose all of my information here. So go ahead and fill this in. And what we'll need to do is verify our phone number. So we'll fill in all this stuff. And then we'll choose to use a different phone number and all this stuff. And I'll see you back here in a moment. Of course, if you already have an email, you wouldn't have to go through all of this process here, but I'll be back in just a moment, okay? All right, so the next screen that I'm being prompted with is to add a credit card. They say identity verification by card. Of course, this is so that when you want to pay and go to the pay tier, you can. I believe that Azure provides you a sandbox, so you'll be okay, but you'll have limited control within Azure. But what we'll do is we'll go ahead and I will fill all this information. Of course, I'm not going to show you all of this information, but I'll see you back here in just a moment, okay? Okay, that's all filled in, and so it looks like it's still setting up our account up here. It's asking for some feedback. I don't really have any feedback for the sign-up process. I'm just going to wait here till setting up your account is complete, so I'll see you back here in just a moment, okay? Oh, it looks like it's already done, so the account is created. I assume that we can just go ahead and log in. So let's go ahead and sign in here, and we will choose this new account. Now, the cool thing about Azure is that normally when you're logged in, you stay logged in. So It's usually pretty pretty convenient. I don't feel like I'm always logging into my account, but we are in here. And so that's all we had to do to get into our new Azure account. So there you go. All right, so in this video, what I want to do is focus a little bit more on resource providers, because it's very important to understand about registering or unregistering resource providers to get access to particular services. Right now, I am still utilizing the free tier, so in some videos I might be on free tier and other ones I might not be. But what I want to do is make our way over to our subscription. So we'll go ahead and type in subscription in the top. And from here, we'll go into Azure Subscription 1. Yours might be named differently if you named it differently. I'm going to go down over here and look for resource providers. And so in here, we have a bunch of providers that we can utilize. And if we scroll through here, there's a ton of them. And so if we do not have particular things registered, we're just not going to be able to use those services. And this is the type of subscription you have might determine what you're able to actually access. So we can just kind of sort here on the right-hand side by just double-clicking, and we can see what resources we have. So I'm just looking through here, and we kind of have an idea of what they are. So Microsoft Storage is probably storage accounts. I'm trying to look for virtual machines. I imagine there is probably one called Microsoft Virtual Machines, or VM. If we're not sure, I can go ahead and type it up here. So I have VMware. What if I type in virtual machines? So some of these are not registered, but it's just going to be really dependent on what we're running into. Some of these are grouped under the same thing, so it could be a bit misleading in terms of what their names are. But what I'm going to do is just take a look and click into storage and see what kind of information we can get about it. So we'll go ahead and click into this one here. And I'm just trying to see what kind of information we can get. And if we click here in the top, it's showing resource types. So that's kind of showing the kind of operations that we can perform. And if I hover over them, notice it says like locations or operations or storage tasks. So I imagine that these might be specifically tied to API calls. But yeah, if it's not very clear what these do, that's totally understandable. But I'm just going to say that we are going to come across resources and they're not going to work. And we're going to have to enable those resource providers first. One that I think that might happen might be Cosmo DB. I kind of remember having to always activate that one. Cosmo DB. So just give me a second. I'll go look for it, okay? All right, so I did a bit of Googling, and in this one, they were suggesting some resource providers. I think it's talking about Cosmos DB, and I think that Cosmos DB used to be called Document DB, or it was an older version of it. So I'm just curious if we were to type that in here. Let me say Document DB. Yeah, and notice that it's not registered. So Cosmos DB is it's a NoSQL database. If you ever heard of AWS's equivalent of DynamoDB, it's something similar. The question is, can we use this in the free tier? I'm not 100% certain, but it says try for free for up to 30 days. And so all I want to see is it going to complain that we don't have it registered? That's what I'm hoping to happen here to demonstrate this thing about registering. I'm going to go ahead here and hit create. And we have a bunch of different options here. So I'm just going to go ahead and create a NoSQL database. And I'm going to create a resource group. So I'm going to say, my DB. We'll go ahead and say okay. Just follow along. If you don't know the stuff, that's totally all right. Again, I'm just trying to get it to prompt. If you don't want to make this, you can just watch and just see what happens when we see that resource provider complaint, assuming that this is going to trigger it. I'm not sure. And so we need account name. So I'm going to say my new DB. And I'm just going to put a bunch of numbers here on the end. These are global names, so it's treated like a domain name. I have to really figure it out. Apply the free tier discount. Absolutely, yes. And we'll go ahead and give it a moment. So we'll just wait, and we'll go ahead and create. And so it's initializing the deployment. And I'm not seeing any complaint so far. I keep expecting it to say, hey, you need a resource provider here. But it seems to be deploying, so this might not be a good example, but I definitely remember having this issue before. But we'll give it a moment. I'm just going to be back in just a second, and we'll see what the result is, okay? Also, while we're waiting, I just want to point out that a lot of times when things are happening, you can go up to the notifications, and it will give you an update here. And so while this is creating, I could go ahead and give this a hard refresh. And just still notice that it's still showing the deployment in progress. So we can really keep track of where we are or what's happening. Again, I don't know how long this takes to create. This might take quite a while. I just kind of forget. I know it's not going to cost me anything to spin this up, but we'll wait here a bit, okay? All right, so that did actually create. So I guess that wasn't a really good example, unfortunately. But I do know, I'm going to go ahead to that resource group, and I'm just going to go ahead and delete this. Anytime you launch a resource in Azure, you always have to launch it into a resource group. And it's a lot easier to tear down all the resources within a resource group. So I go ahead and hit delete resource group. It has that one database there. I'm going to go ahead and delete it. So I did kind of cheat, and I went out to the internet and I said, what service isn't enabled by default, where you'd have to register it? And one they said was AKS. AKS is for running Kubernetes clusters. That's a little bit out of scope for this level of certification, but I'm going to do it anyway. I really don't want you to do this. I just want you to watch and see what I'm talking about here, because Kubernetes can be very expensive, and I don't want to put you in trouble here or to make this harder for you. So just watch along, and let's see if we can see what happens when we try to launch a Kubernetes service without turning it on in the under resource providers. So I'm going to go here and launch a new Kubernetes cluster. And I'm going to create a new resource group. I'm going to just say my K8's resource group for RG there. We'll say OK. And I'm going to choose something. Again, don't do this. I'm just doing this. We'll go ahead and do dev and test. I'm going to say my K8's cluster. And so it likes the name there. That's fine. I'm going to go with the free pricing tier. If it's free, you can do it as well, but I'm going to tell you, it's not fun to set up Kubernetes clusters. It's going to set up one node pool. We'll go ahead and hit review and create. If you're also noticing, there's always this confirmation step with Azure. I really like this. Like AWS does not do this. GCP kind of does this, but you always go through this process of go through the steps, review what it is that you want, and hit create, and then it has a deployment step. So it's a nice workflow. I really like that about Azure. But we'll give it a moment here to get ready to confirm all the information, and we'll go ahead and see if we can create it. It says validation is passed. We'll go down below and hit create. I'm still expecting it to ask me about container service. And I definitely confirm that this is something you're supposed to have turned on. Now, what we'll do while we're waiting is I'm going to go over here, click back into a new tab. And while that is deploying, because that's going to take a while, I'm going to go ahead back into our subscriptions. And I want to check resource providers, because I know this one is called like container services. So I'm going to type in here container, and it says it's registered. So I feel like Azure's messing with me, because in the past, you've always had to manually turn these on. And I feel like it's just turning them on for me. So what I'm going to do here is I want to see something I don't have turned on, and then I want to go try and use it and see if it actually just turns it on. Because if it does that now, that is great. But always in the past, that's not how it worked. So just let me go look for something, and I'll be back in just a moment. All right, so I just went over to ChatGPT and I asked, what does Microsoft Compute give you access to? And it says virtual machines and scale sets, which makes sense. That's what I recall it doing, but I just wanted to be 100% sure it's going to do what I wanted to do. I also noticed that coming back to AKS, our deployment failed. I'm going to go take a look here. The resource write operation failed to complete successfully because it reached terminal provisioning state failed. That's totally fine. I don't even want to deploy a Kubernetes cluster anymore. I've given up on that. We're going to go ahead and just delete this resource group. And if you're thinking this is a bit messy, I'm just going to tell you, this is what Azure's like. Azure is really great in terms of its offerings, but out of all the cloud service providers, I would just say that it is the most challenging to learn. But anyway, that's going to tear it down. And so what I want to find out is, if I go launch a virtual machine, is this automatically going to turn on to be registered? That's what I want to know. So what I'm going to do is go ahead and attempt to launch a virtual machine, which that is something that is a lot more reasonable to learn at this certification level. But we're going to go ahead and hit create. I'm going to choose an Azure virtual machine. And I'm going to create a new resource group. I'm going to say my virtual machine RG. And I'm going to go here and just say my virtual machine RG. Or not RG, but just put that in there like that. And we're going to go ahead and choose US East. Does not really matter. I just want to launch it somewhere. And I mean, this looks all okay. I'm not going to log into this. The only thing that matters is what kind of image we're utilizing, because that's going to determine the spend. So that is free tier. I'm going to stick with free tier. Let's go ahead forward to our review and create and see what happens. So again, I'm kind of expecting to create this, and I wanted to say that it's not enabled. It wants us to generate a new key pair. I don't really want to download a key pair, but I'll go ahead and do that anyway. That's something you commonly do with virtual machines. I just wanted to create it. So again, I have not enabled that service. While we're waiting for this, let's go ahead and click on notifications and view all the activity. I'm just curious if it's enabling those subscriptions, because usually it tells us everything in here. And so I'm just carefully looking. So I'm going to go ahead and refresh. That was 4 minutes ago. Look here. Register subscription for container service. Okay, so we absolutely do need to turn it on, but it turned it on automatically for us. And I'm just trying to say that in the past, I always had to manually do that. Down below here, register the storage resource provider. So I'm not sure if this is a problem anymore, but I still think it's important to point out that you are supposed to register services before you use them. And that's the only point I wanted to make there. So just understand that that is something that's important to Azure. But now what I need to do is get rid of my that virtual machine I've been launching. So over here, you can see the latest resources. I'm going to go to this one here. And I know it's still deploying. It's creating all these resources. I'm going to go ahead and tear that down. So I'll go here and just say apply forcefully for everything. Yep, I definitely want to do that. And I'm going to go ahead and copy this name here, and we'll tear that down. So that's the only point I wanted to make in that video. I know it was super complicated, but hey, that's Azure. We'll see you in the next one. Okay, ciao. Let's go ahead and actually create some users. And just before we proceed forward to create a user, I just want to point out, you can tell what tenant you are in if you look in the top right corner. So here I'm in my Starfleet tenant. And there's actually, I think you can switch between here. Yeah, that's an easier way to switch between your directories. But generally, that's not how I do it. I'll go to the top here and just type in Azure Active Directory. And when I want to switch a tenant, I just click the Switch Tenant button and click on what I want. But we'll make our way back to the Starfleet tenant that I have here. Here you can see my information, and I've obviously activated Azure AD Premium P2. But before we go ahead and create a user, we're going to have to create a group, and I'll show you why. If I'm going to go ahead, I'm just going to speed through this for a second. But if I scroll on down, I have this option where I need to create assign it to a group. I guess I don't have to, but the problem is I don't have one. And so before I create my user, let's go ahead and create ourselves a new user group. And so we'll go ahead and create a new group here. And we have two options. We have security and Microsoft 365. It explains right here the difference. So 365 is really for giving access to mailbox, calendar, files, SharePoint. We're not doing that stuff here. We're just sticking with regular security groups, which is for Azure stuff. We'll name this developers, and then we'll name this developers. And notice here that the membership type, I have a drop-down. If you're on the free tier, this is going to be grayed out. But this dynamic user is part of P2. And so this allows us to add a dynamic query. And the idea here is that if I start having users and I just say, if a user is from Canada, then they'll automatically be added to this group. And so that's the query that gets outputted. But we're not going to make a dynamic group today. We'll just make our way back here to the new group. And we'll just manually assign stuff, all right? I'll go ahead there and create that user, or that group there. And now that we have that group, let's make our way over to users. So we'll go back here. I'm going to make myself a new user. And on the top here, we'll go here. And we'll name this one Kevin. And we'll have that lowercase. And we will call them Kevin Uxbridge. All right. And you'll notice here it will auto-generate a password. It's 4 letters and 4 numbers. I don't find this personally very secure, but the idea here is that a user is going to reset that password right away, so it's not a big deal, and that's very easy to remember. And now I can go here and assign groups. And if I want to assign them a role, I can do that here. So we'll open that up. We have a bunch of different options. Maybe we want these 2 roles here. And then we have some additional information. I'll go ahead and create this user. And so now this user exists. What's interesting is that I can go ahead and delete users and then recover them. The groups have this as well, where if you go here, and I actually have a user I deleted previously. So it just takes some time to show up. But if you go ahead, you can hit the delete user here. And then they will remain in here for 30 days, and then they'll automatically be deleted. So if someone made a mistake, this is a great opportunity to bring them back. And so I can just go checkbox on Rishan here, and we can just bring her on back, restore that user. All right. And again, you know, this is sometimes a bit delayed, so we might have to hit refresh. There she is. And so, you know, that is the whole group and user stuff there. Let's take a look at how we can enable multi-factor authentication for our users. And so multi-factor stands for MFA. You're probably used to it, where it's a secondary step to confirm your identity before logging in, either via a phone or a hardware device such as an YubiKey. And so there's this button here. This is multi-factor authentication, and it could be disabled for you. It very likely is if you're on the free version of your Azure AD. Just going back up here 1 level. You can tell based on what that is here. So I'm using Azure AD Premium P2. That's definitely going to allow me to have MFA. So if you just don't want to turn on P2 or it's trying to charge you money, don't worry about it. Just watch me do it here. You'll pretty much learn what you need to know. So we'll just go ahead and click that button. It's going to bring us to a different screen here. And here we have our users, and you can see multi-factor authentication is turned off for all of them. So we can go ahead here and turn it on for a single one if I click enable. And so that enables it for Kevin. Then we have some other additional options like manage user settings. And here you can see we have some extra options. So require selected users to provide contact methods again, delete all existing app passwords generated by the selected users, restore multi-factor authentication on all remembered devices. So just some additional things. Another thing we'll want to check out here, it's not very obvious, but we have a service settings button up here. And this will give us more additional options to enforce for our users. So first we have app passwords. So this allows users to create app passwords to sign into non-browser apps, so things that are not part of the website here. And so you can whitelist some IP addresses for them so that they are trusted from those locations. Then for verification options, this is something that's important. We have some options like call to phone. So it will actually, to do the MFA, it will actually call your phone, and you'll tell you the letters and numbers that you enter in, or it can send you a text message, or it can notify you through the mobile application. So you can install the companion app from the Android or iOS store, or the Windows Store. I imagine there's a Windows Store too. And then there's the verification code and mobile app or hardware tokens. So hardware tokens could be with an YubiKey, right? Then you can say, remember a multi-factor authentication on trusted devices for X amount of days. That way they don't have to enter it all the time. Because it might get annoying for some users. Honestly, for me, I want everyone to enter it every single time because that's just how I am. But let's make our way back here and see how we can do some bulk assignment. So what I'll do is I want to enable it for a few people here. So if I go up to bulk update, I can download a sample file. And that's going to go ahead and download that. And you can see I actually did this previously here. So I'll just copy it. And what we'll do is just paste that in there. So we're just pasting in, yeah, that's fine. We're just pasting in their name, right? And the MFA status. You can always get the name from here, just back on the list there. And so once we have saved that file, we can go ahead and upload that. They're the same here, so it's not a big deal. And we'll just wait a few seconds here. This is pretty darn quick. Usually doesn't take minutes, sometimes it takes seconds, but we'll just give it a moment here. And there we go. So that was a long wait. I don't know why, but it verified the 2 there. And so if we go next, now those will be now enabled. There's also this option to enforce. So let's go there. After multi-factor authentication is forced, users will need to create app passwords to use non-browser applications such as Outlook or links. And so that's a great option to have. So I'll just go ahead and enable that as well. So now that's enforced. And so that's all you really need to know about MFA.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Computing Services, starting with Azure Virtual Machines. So virtual machine is going to be the most common type of compute. Whenever you're launching a server, I would just think of a virtual machine. And your virtual machines could either be running Windows or the Linux operating system. Now, the great thing with virtual machines is you get a lot of configuration, so you can choose your OS, the amount of memory, the amount of CPU, you can attach storage to it. The thing here is that because it's a virtual machine, the hardware is shared with other customers. You can get dedicated, but generally it's shared. And then you get a virtual computer, so it seems like you have like 100% of the resource, okay? Then we have Azure Container Instances. So this I would describe as Docker as a service. You can run containerized apps. Probably runs Docker in both Windows containers, because I believe Windows has containers as well. But runs containerized apps on Azure without provisioning servers or VMs. So it makes that a lot easier for you. The next sounds very similar, which is called Azure Kubernetes Service. So it's Kubernetes as a service. Easy to deploy, manage, and scale containerized applications. So the idea here is that Kubernetes is just another way of working with containers, but it's using an open source library. Kubernetes has basically become the de facto for containers. And so we've seen all the cloud providers try to make their own service or orchestration service, but Kubernetes kind of won out. So you'll see it on all platforms. The next one is Azure Service Fabric. This one can be a bit confusing because it's described as many things, but I'm going to describe it here as a Tier 1 enterprise container as a service application or a cloud service. So it's for distributed system platforms. It runs on the Azure cloud or on premise. And the way they describe it is easy to package, deploy, and manage scalable and reliable microservices. And anytime you hear the word microservices, think of also containers. So with Azure Container Instances and Azure Kubernetes Services, that's where you'd also run microservices. Then we have Azure Functions. So this would be event-driven, serverless compute. Anytime we're talking about serverless compute, we're usually talking about serverless functions, which are little bytes of code that you can just upload, and it just works. You don't have to think about the servers or provision anything, and you only pay for the time that code runs. So serverless functions generally run for a very short duration, and as soon as they're done, those underlying servers are shutting off. And the last on our list here is Azure Batch. So you can plan, schedule, and execute your batch compute workloads across 100 plus jobs in parallel. When I say jobs here, it's just the code that you want to run. You can use spot VMs. Spot VMs might not be out at the time of this, but it will be in the future. But generally it's known as low priority VMs. But the idea here is that there are virtual machines that are being underutilized. And so Azure is allowing you to rent them at a more cost-effective cost. And so if you're doing a lot of scientific compute or other things, and it doesn't matter if these services get interrupted and you want to use those low priority VMs, that is a great way to save, and that is the computing services.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Virtual Machines, which makes it easy for you to choose your own OS, compute, memory, and storage, and launch a server within minutes. All right, so let's take a quick look here at VMs for Azure. And this is a highly configurable server that relies on virtualization, meaning that you're running a server without having to actually buy and maintain physical hardware that runs it. You will still have to manage things at the software layer. So you would have to apply your own OS system patches and installing the configuration packages. But the nice thing is that you're not dealing with that hardware. It's just going to work for you. And some things I want you to know about Azure Virtual Machines is that the size of the virtual machine is determined by the Azure image. And so the image defines the combination of vCPUs, memory, and storage capacity. The current limit on a per subscription basis is 20 VMs per region. I would think that if you wanted more, you could just use another subscription. I don't know if they have service limit increase for that, but that might be possible as well. Azure VMs are billed at an hourly rate. An instance or a single instance that you launch is going to have availability of 99.9% when you're using premium disk. If If you have standard disk, I have no idea what it is, but it's going to be less than that. If you want to get 99.95% availability, you're going to have to launch 2 instances within an availability set, and you can attach multiple managed disks to an Azure virtual machine. Now, just to give you like a quick visual of what's actually happening when you launch an instance, because when you do launch a virtual machine, there's going to be other networking components that are going to be created or associated with you, and you definitely need to know all these components here. So I have this nice diagram, and we're going to do a quick run through with it. And I want you to just know that when you do launch a virtual machine, it actually does give you a list of all the components that it creates. This is actually very common with most Azure services, and sometimes what they'll do is they'll put it within a resource group for you so that they're all grouped together, which is very nice. But let's just run through these common components that you need to know, such as the network security group. And this is going to be attached to your network interface. It acts as a virtual firewall with rules around ports and protocols. So that is what's protecting our virtual machine. You have the network interface that handles IP protocols. So that's how the virtual machine talks to the internet or other things on the network. You have the virtual machine itself, or the instance. That's the version or the instance that is currently running. It's going to get a public IP address assigned to it. So that's how people from the internet can actually access the virtual machine. And then you're going to have to launch it within a virtual network. And so you're going to have that VNet. So you'll either choose one or you'll be creating one during that wizard process. So there you go. So now let's take a quick look at the options for operating systems on Azure VM, and let's just define what an OS is. So the OS is the program that manages all other programs in a computer, and the most commonly known operating systems are Windows, Mac OS, and Linux. And when you want to launch a virtual machine, the way you determine what operating system you use is based on the image that you choose, okay? And Azure has a marketplace, so they have so many different kinds of operating systems. You're going to have every possible option you want. And Microsoft has also partnered with specific companies to make sure that they're providing you images that are updated and optimized for the Azure runtime. So let's do a quick run through of these supported or partnered OSs. So we have SUSE, we have Red Hat, Ubuntu, Debian, FreeBSD. Then you have Flat Car Container Linux, Rancher OS, which is for containerization, Bitnami. Bitnami is more like images that have preloaded software on them. They're very popular for their Bitnami WordPress. You have Mesosphere, and then you have images that have Docker with it. So you have a lot of options open to you there. And I always forget about Jenkins, and Jenkins is on the end there. Now, if you want to bring your own Linux version, you can totally do so. All you have to do is package it into a virtual hard disk or a VHD. If you've never heard of VHDs, these are just virtual hard disk formats that you can create using Hyper-V software, which would be on your Windows machine. And just be aware that Azure doesn't support VHDX, which is a newer format. It only uses VHD. Okay, so there you go. So let's take a look here at Azure Scale Sets, and these are used to automatically increase or decrease your virtual machine capacity. So imagine you have a web application behind an application load balancer, and you have an increase in traffic. You want to be able to quickly add more capacity by adding another identical virtual machine, or when there's a decrease in traffic, remove it to save costs, and that is what Azure Scale Sets do. So you're creating scale policies to automatically add or remove based on host metrics. Host metrics could be like CPU utilization or network in. You're going to create health checks, and you can also set a repair policy to replace unhealthy instances. You can associate a load balancer to distribute virtual machines across availability zones, and you can scale to 100 or even 1,000 VMs using scale sets. So one thing you're going to probably want to do with your scale set is associate with a load balancer. And in honest, I don't run any kind of application workload unless it is in a scale set and behind a load balancer, because it's just good practice to do that. And the reason why you're going to want a load balancer is that it's going to help you evenly distribute your VMs across multiple availability zones. And that's going to give you high availability because you definitely want to try to run 3 VMs across 3 AZs to get that high availability. You can also use a load balancer probe checks, and these are more robust health checks than what ScaleSet provides you. So that is just an added benefit there. And when we're talking about load balancers, we have two different choices here. We have the application gateway, and so this is for HTTP, HTTPS web traffic load balancer. And then you also have Azure Load Balancer, and this is going to support TCP and UDP network traffic and things like that. So depending on what OSI layer you need to operate on is going to determine what kind of load balancer you need to use. So let's take a look at scaling policies, and these determine when a virtual machine should be added or removed to meet the current requirements. And you have this little wizard here. This is what the wizard you see or form you see when you're creating a scale set initially with very simple features. But let's just focus on two things, scaling out and scaling in. So scaling it out is when an instance should be added to a scale set to increase capacity. So you choose your metric, which is hard-coded in this case, to CPU threshold. So you choose your metric, the duration, how many VMs you want to add. And then the scale in is the opposite. That's when you're removing something from the scale set to decrease your capacity. And again, that interface is very simple. When you actually go ahead and create a scale set, after you go and update it, you're going to end up with a lot more options. And here are the options. You can see they're extremely robust. And so you have the option to choose one of the built-in host metrics that are already being collected on your virtual machine. So the most popular here, and there's more than this, but the most popular here is CPU, network in, network out, disk read, and write. Then you have your aggregates, so you can decide how you want to group or collect that data before you apply your final operations on it. Then you have your operators, so you can say greater than or equal to. Then you have your actions. You can say increase the count of, so add X amount of servers, or you can say increase by percentage. So imagine you had 10 servers and you want to increase the load by 30%, that would add 3 additional servers. If you want more metrics than just the built-in host metrics, you can absolutely get more, but you're going to have to install a couple things. If you want more app-specific metrics like page performance or page load performance and sessions count, you would install a small instrumentation package for App Insights. And if you want to have more detailed host metrics, so you might have host metrics, but you want them in more detail or more available host metrics, you'd install the Azure Diagnostic extension within your VM. There are a few other scaling policy options that are, well, they're not exactly in that form, but they are around or are associated with them. One is the scale in policy, not to be confused with the scale in option. And this determines what virtual machine should be removed when you decrease capacity. So it's just a simple drop down, and you have a few different options. So there's the default option. This is where it deletes the VM with the highest instance ID, and it's going to do that taking consideration the balancing across AZs and ADs, or it can delete the newest virtual machine, so delete the newest VM. Again, this one's only across availability zones, or delete the oldest VM. So this is going to delete the oldest VM and balance across availability zones. Then you have an update policy, and this determines how VM instances are brought up to date with the latest scale set model. So again, it's another drop down, and you have a few options here. So you have automatic, so increasing the start upgrade immediately in random order or manual. So existing instances must be manually upgraded, or rolling. And so this upgrades roll out in batches with optional pause. And just one other note here is that if you want to do automatic OS upgrades, you can enable this to help ease update management by safely and automatically upgrading the OS disk for all instances. So there you go. Health monitoring is a feature with scale sets you're absolutely going to want to turn on. And what it does is it determines whether your instance, your virtual machine instance, is healthy or unhealthy. So you have that option to disable or enable it. And it comes in 2 different modes. We're going to have the application health extension, which is what we're seeing on the right-hand side here. And this is where you ping an HTTP or HTTPS request with a specific path and expect back a specific status. So the status here would be 200. So the idea is that you could say ping the home page, and if the home page appears, then therefore the server must be healthy, or you can make it your own custom page. That's what I like to do. I have like a health check page. The other mode is load balancer probe. This is only going to work if you have an associated load balancer. And here you can check based on TCP, UDP, and HTTP requests. So this is a little bit more robust. So I generally would recommend using this mode over the first mode, because generally when you have a scale set, you're going to also want to have a load balancer. Now, if you want to replace unhealthy instances, they have an automatic repair policy. So this is an automatic. I mean, like, it's not turned on by default, so you have to explicitly say you want to turn it on. And what that will do is that if it finds an instance that is unhealthy, it's just going to terminate it and then launch a new instance. All right, and so there you go. All right, let's take a look at Azure Virtual Desktop, formerly known as Windows Virtual Desktop. Azure Virtual Desktop on Microsoft Azure is a desktop and app virtualization service that runs on the cloud. Azure Virtual Desktop works across devices like Windows, Mac, iOS, Android, and Linux with apps that you can use to access remote desktops and apps. You can use most modern browsers to access Azure Virtual Desktop hosted experiences. Use Azure Virtual Desktop for specific needs like when security is a concern because all data is saved on the server and cannot be left on the device of a user. Key features and benefits: enable secure and productive remote work on any device. Azure Virtual Desktop provides full Windows 10 and Windows Server desktop and application virtualization on any personal device. Seamless integration with Microsoft 365 apps for enterprise and Microsoft Teams. Reduce costs of licensing and infrastructure. Use eligible Windows or Microsoft 365 licenses to access Windows Virtual Desktop and pay only for what you use. Protect against outages to stay productive. Help keep your team running during outages by leveraging built-in Azure Site Recovery and Azure Backup technologies. Simplify IT management. Windows Virtual Desktop manages the virtual desktop infrastructure for you so you can focus on users, apps, and OS images instead of hardware and maintenance. Keep application and user data secure. Easily apply the right access controls to users and devices with Azure Active Directory conditional access. So that's an overview of Azure Virtual Desktop.
Hey, this is Andrew Brown from Exam Pro, and I'm going to show you how to launch your own server on Azure. And so a server would be considered some kind of computing service, and the one we're going to do right now is we're going to use virtual machines. So go all the way to the top here to search, and I want you to type in virtual machine. I know it's on our dashboard here, but just to get in the habit of always being able to find stuff, it's great to use the search. And then once we're here on the left-hand side, I want you to click Add. And we're going to be presented with a lot of different options. So the first thing we need to do is choose our resource group. We have another resource group that was created here for us for Azure. I wouldn't worry about it. Let's just choose the one that we created. I'm going to name this virtual machine. I'm going to call it My VM. We're going to launch it in US East. If we wanted to choose an AZ, we could. So we go to Availability Zone and choose one. I'm just going to stick to no infrastructure. Then we have Ubuntu here. It's using the latest version. It might be different for you. I wouldn't worry too much about it. Then we need to choose our size. This is going to really determine our cost. Here, this is $89 Canadian. I'm just going to go ahead and hit select here. And we're just going to sort on the right-hand side based on cost. And we're going to choose the most inexpensive server, which is the B1LS. So that's 1 vPCU and half a gigabyte of RAM. Because this is just an example app, we're not going to do any, or a server, we're not going to do anything with it. So we might as well make sure we're not overspending our free credits. We have the option to add a public key. This is what you generally would want to do, but that's a lot of work. And so for this demo, so we're just going to choose password. They're very finicky about the passwords here. That it has to have a uppercase, lowercase, special character, number, and it also has to be 12 characters. So I'm going to type in testing with a capital T, testing, 1, 2, 3, exclamation, exclamation, and then testing with a capital on the T, 1, 2, 3, exclamation, exclamation. So there we go. We don't need any inbound ports. I'm going to say none because we're not SSHing in. I'm just going to click forward here to show you some of the other options. So we could choose the type of disk we'd be attaching. So it's by default on premium. You might want to choose standard or standard HDD. Generally, when you're launching web apps, you want SSD. If we were to choose standard, it would say, hey, you should really use premium. So we're just going to go back to premium. You're going to notice that the disk is encrypted by default, so you can't have an unencrypted disk. That's a very good default option. If we go over to networking, it's going to automatically select our VNet that we chose and the default subnet that it created when we created the VNet. And then here we could choose whether we want an IP address or not. If it had no IP or public IP address, it would still have a private IP address, and that would mean that it's really intended for a private subnet. It has a network security group set onto basic here, and that's pretty much it here. You could also put it behind a load balancer. We're not going to do that. Let's go over to management. Management, we have a couple options here, like identity, auto shutdown, backup. These are all fine. We're just going to leave it alone. For advanced, we could put custom data in here. That means we could provide it a script that it would use to initially set up the server. We're not going to do that. And that's about it. So I'm going to go back to basic, and I'm going to scroll all the way down to the bottom, and I'm going to hit review plus create. And what we're going to have to do is wait for this validation step. That was very fast. It might take multiple seconds for you or even a minute, but sometimes it's faster than others. So now I'm going to go down below and hit create. And we're just going to wait for that deployment to be submitted. It's going to say deployment is underway, and then soon it's going to say deployment is complete. So I'll see you back here in a moment when deployment is complete. Great, so we had to wait a few minutes there, and now it says deployment is complete, and we can proceed to go to resource. And so here's our virtual machine. We have some CPU, some network, some disk, so there's some activity here. If we wanted to gain access to it, there should be a connect button here. We're not going to be able to gain access to it because we just didn't set it up in a way that was the case. We have a few options down the left-hand side, such as the disks that are actually attached to it, and maybe the size here. So maybe if we wanted to resize, change it to a larger size, we could go ahead and do that. But there's nothing really exciting here to do. I just wanted to show you how to launch your own virtual machine. And now that we have our own virtual machine launched, I'm going to go back to overview. We're going to go ahead and delete that because this is now costing us money. It's not costing us a lot of money, but again, we're done here. So we'll just go ahead and delete. We're going to say yes to delete. And now it says it's deleting the virtual machine. And so we're just going to wait until this is finished deleting. And a lot of times you can just look at the progress up here and it'll say deleting the virtual machine. Could take a few seconds. It could take a few minutes. It just depends. So I'll see you here in a little bit when this is done deleting. So after waiting a little while here, it says it's how it successfully deleted the virtual machine. If we want to make sure that it's deleted, let's go make our way over to virtual machines at the top here in the search. And you're going to notice that it's still showing up there, but it said it was deleted. And this is the thing with Azure is that it takes time for it to propagate. So what we'll have to do is just hit refresh, and now it's gone. So just be aware that sometimes the consistency in terms of what you see in the UI is a bit delayed. And so if you remember clicking delete and it says that it deleted it, just have a bit of patience there and hit refresh and just double check to make sure that's the case. So there you go.
Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure App Services, which allows you to quickly deploy and manage web apps on Azure without worrying about the underlying infrastructure. And specifically, this is known as a platform as a service. So Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. And you can choose your programming language, and it can either be Windows or Linux environment. And it's a platform as a service. So if you've ever used Heroku, it is basically the Heroku of Azure. And so Azure App Service takes care of a lot of the underlying infrastructure for you. So it can do security patches of the OS and languages, load balancing, auto scaling, automated manager. And then there's a lot of things that you can implement. And so for integrations such as Azure DevOps, GitHub integrations, Docker Hub, package management, easy to set up staging environments, custom domains, attaching SSL certificates. So you can see that it just basically takes care of everything for you. If it's really hard for you or time consuming for you to do all this on your own in Azure. And the way it works is you pay based on an Azure App Service plan. Honestly, I find these really confusing. I really like how AWS does Elastic Beanstalk because you're just paying for the underlying services. But Azure has all these crazy tiers here. But you have shared tier, which is free and shared, doesn't support Linux. You have the dedicated tier, which is basic, standard, premium version 2 and 3, and the isolated tier. And so another thing I need to note is that Azure App Services is not just for traditional VMs for monoliths. You can also run Docker single or multi-containers. And when you set up a project, you're going to choose your domain name on the azurewebsites.net. Obviously, you can override that with your custom domain name, but there you go. Let's talk about Azure App Services runtimes. And so let's define what a runtime is. A runtime is software instructions that are executed while your program is running. And so runtime generally means what programming language, libraries, and frameworks you're going to be using. And so runtimes for Azure App Services are predefined containers that has your programming languages and probably some commonly used libraries for those languages installed, and probably commonly used languages for web frameworks. And so the idea is that you're going to choose your runtime. It could be .NET, .NET Core, Java, Ruby, which I'm very disappointed in Azure because as of shooting this video, they do not support Ruby for application insights, but yet they have it here in Azure App Services, Node.js, PHP, Python, and there's all the logos if you like seeing the logos. And so Azure App Services generally has multiple versions. So they have like Ruby 2.6, 2.7. For PHP, they have a lot of versions. For Node.js, they have a lot of versions. But I just want to point out that it's pretty common for cloud providers to stop or to retire the old ones at some point, to stop supporting them. That's just because they want to keep things modern. And the other thing is, like, it also helps you keep with your best security practices, because really you should always be trying to upgrade to the latest version for those security patches and things like that. So there you go. Now, let's say you wanted to use a language that wasn't supported on Azure App Services, like you wanted to use Elixir. What you could do is create your own custom container, either for Windows or Linux. And so you just go ahead and create your own Docker container on your local environment. You can push it to an Azure Container Registry. And then the idea is you can deploy your container image to your app service. So I just wanted you to know that you could do that. If there's some languages or other things, or maybe you're using a language, but you need some bundle or packages that are just baked into the container. So there you go. Let's talk about deployment slots. So deployment slots allow you to create different environments for your web application and associate a different host name. This is useful when you need a staging or quality assurance environment, or maybe you need just a developer environment, any kind of environment you want. So think of it as a way to quickly clone your production environment for other uses. And so down below here, you'd have your deployment slots, and there's your slots. So maybe you have app, staging, beta. So that's the different host names there. And so the idea is that not only do you have other environments, but there's also this thing called swapping. And the idea is, like, imagine you decide, like, you make a clone of your production environment, and then you deploy the latest version to it. And then when you decide that it's good, it's in good shape, then what you can do is swap it out with your current production environment and then just retire your old one. And this is called blue-green deployment. And so that is a great way to do deployments. And I just wanted you to be aware of that. So I wanted to talk about App Service Environment because I just wanted to show you how Azure App Service is not just for little toy apps or your small startup, but they can be really useful for larger enterprises. So App Service Environment is an Azure App Service feature that provides fully isolated and dedicated environment for securely running app service at high scale. And so this is going to allow you to host web or Windows web apps, Linux web apps, Docker containers, mobile apps, and functions. And app service environments are appropriate for application workloads that require very high scale, isolation and secure network access, high memory utilization. And again, when you think of platform as a service, you don't think at this kind of scale. So it's really impressive that Azure does this. Customers can create multiple ASCs within a single Azure region or across multiple Azure regions, making ASCs ideal for horizontal scaling stateless application tiers in support of high requests per second RPS workloads. An ASC comes with its own pricing tier, and that's the isolated tier. An ASC can be used to configure security architecture. Apps running ASC can have their access gated by upstream devices, such as a web application firewall, also known as a WAF. ASEs can be deployed into availability zones using zone pinning. I don't know what that is, a zone pinning, but that sounds good to me. And there are two deployment types for ASE. We have external ASE and ILB ASE. And let's go take a quick look at what those look like. So here's a big diagram. And look in the middle there, that's where our Azure service environment is. It's in our own VNet and a subnet. And the idea is that the reason it's called an external ASE is because it exposes the ASE hosted app on an internet accessible IP address. And then down below, if you wanted to connect this, and this is generally what people are probably using it for, but what you want to do is you can connect it to your on-premise via a site-to-site or express route VPN. So that's something you can do with it. And the other part is like you can, because the ASC is within the same VNet, it also has access to resources within the VNet without any additional configuration. So that's really nice. And then the second one here, it's exactly identical, but there's one key difference, and it has this ILB there. And an ILB stands for internal load balancer, and that is basically the only difference. So there you go. So the way you pay when you use Azure App Service is you need an Azure App Service plan, and that's going to determine how much you pay and what's going to be available to you. They got 3 tiers, which we're going to go through here shortly, and we did mention them earlier. I honestly do not like this whatsoever. This tells you this is a Microsoft product because it has these wonky pricing tiers. I hope in the future they'll change it, but that's just what it is. And so let's go learn it. So basically what you do is you have like this big wizard that tells you all the stuff that you can have. It tells you what's included and stuff like that. But let's work our way through it. So the first thing is the shared tier. And there's 2 types here. We got free and shared. And so there's the free tier, that red one there. It's called F1. It gives you 1 gigabyte of disk space, up to 10 apps on a single shared instance, no SLA for availability, and each app has a compute quota of 60 minutes per day. So there you go. You get some free tier there. Then there's the shared tier. This provides up to 100 apps on a single shared instance, no SLA availability. Each app has a compute quota of 240 minutes per day. And the thing is that I didn't know where the button is for that. So like the next thing right beside it is the dedicated tier. And I thought that's what it would be because it says 100 total ACUs. So is it? I'm not sure. But anyway, the point is there is a shared tier. Where it is, I don't know. And you can't use the shared tier on Linux-based systems. So you're using Windows. When you're using Windows, you got to use bigger instances anyway, which I don't know. I don't like that too much. But that's what it is. Moving on over, we're now into the dedicated tiers. And look, it's right beside the free tier. That's the green one. It says B1. And if you expand it, it actually has a couple other tiers there. So I just wanted to show you that there was 3 there. And so for dedicated tiers, we got basic, standard, premium, premium version 2, premium version 3, and we're looking at basic there. That's what that is. More disk space, unlimited apps, 3 levels in this tier that offer varying amount of compute power, memory, and disk usage. It must be B1, B2, B3. And then the next thing over is the standard, and we had to switch tabs there onto the production tab. Notice the terminologies don't really match the tiers. And so with standard, you can scale out to 3 dedicated instances, has an SLA of 99.95% availability, and 3 levels in this tier that are offering varying amounts of compute power, memory, and storage disk. And so then that's that tier there. And we're on to our last tier, which is the premium tier. And this scales to 10 dedicated instances. It has availability SLA of 99.95% and multiple levels of hardware. So that's the dedicated tiers. Then we're on to the last thing, which is isolated. And this is really only going to be used, I think, for ASC. So the isolated tier has dedicated Azure virtual networks, full network compute isolation, scales out to 100 instances, availability SLA of 99.95%. And again, I think it's just for those ASCs. But there you go. That is all the tiers, and hopefully it makes sense to you. But it is a little bit tricky to figure out what to choose, but you don't really get to like pick at a granular level. That's what I don't like. But it is a really great service, Azure App Service. It does figure everything out for you, so maybe it's okay for you. Hey, this is Andrew Brown from Exam Pro, and we are going to be learning about Azure App Services in this follow along. And it's a service that's supposed to make it easy for you to deploy web applications. I say supposed to because it really depends on your stack. Azure has more synergies with other stacks than others. So like if you're like me and you like Ruby on Rails, you're going to find a lot of friction with Rails and Linux. But if you're using something like Windows servers or Python or .NET, you're going to have a much easier time. Still a really great service, just wish they'd make it a bit more broad there, but let's hop into it. So before we can go use that service, let's make sure that it's activated. And so we'll go over here and we'll go to Azure subscription. And then down below, we're going to go to resource provider. Now you'd think what you could do is just type in app services and you'd be wrong because the service is under a particular provider. So if you want to figure out what provider it is, we can go Azure Resource Providers. And they have a page on documentation here that lists them all. So if I search for Azure App Services, it's under web and domain registration. So we're going to make sure this is registered. If we're using a custom domain, which we are not today, we need this one activated. So going back here, I will type in web and you can see it's registered. So if yours is not registered, go ahead and hit that. I believe this by default is generally registered with new Azure accounts. So I don't think that is an issue for you. But we'll go back up here, close these additional tabs, and we will type in Azure App Services. And we will look for that service. So there it is. And we'll go ahead and hit add. And so I'm going to give it a new name. I just made it a moment ago, but I'm going to try again and try to use the same name. So we're going to call this Voyager. Great. And then I'm going to go ahead and name this Voyager. And I already know that that is taken. So I'm going to type in Delta Flyer. And these are fully qualified domains, so they are unique. With Azure App Services, you can run a Docker container. We're doing code this time around. And what I like to use is Ruby. But again, you know, if I want to use the CI/CD, I'm not going to be able to use the deployment center with Ruby, so that is not possible. And so we're going to go with Python and run either a Flask or a Django app. I haven't decided yet. I am in Canada, so let's go to Canada East. And down below here, we have the plans. Generally, the plans will tell you the cost underneath. You'll notice that it's loading, but I just want to show you that there are some discrepancies in terms of pricing. So if I was to go to Azure App Services pricing, and we were to pull this up here, we can kind of see the pricing here. Okay, and if we scroll on down, right now we're looking at a premium V2, and oh no, I don't need help. I'm okay. You'll notice that it's 20 cents per hour. So if I go here and do that times 730, because there's 730 hours in the year, that's $146. I believe this is showing me in USD dollars. Yeah. And in here, it's showing me 103 Canadian, which is lower. So it could be that because I'm running in a Canada East region, the price is different. But you could imagine that if I had this at this cost at, what did we say here? At 146 USD, to CAD, I'd actually be paying $182. So you got to watch out for that kind of stuff. But I'm pretty sure this is what the cost is. So just be aware that if you look stuff up in here, it's not necessarily reflective. So you got to do a little bit more work to figure that out. If we wanted to go here, we cannot choose the free tier when we're using Linux. If we're using Windows, I believe we can use it. We're working with Linux today, so that's just how it's going to be. For the B1, this is totally fine, but we want to utilize deployment slots. Deployment slots is an advanced feature of the production version, and that's the only way we're going to be able to use it here. This is 20 cents per hour again, so I don't want to be doing this for too long. But I think what we'll do is before we do that, we can just do an upgrade to dev to prod so we can experience that. I'm going to go and just choose B1, okay? So we'll go next. We do not need any application insights for the time being, and it will not let us, so it's okay. We'll go next, review and create. And we'll go ahead and create this resource here. And I will see you back when this is done. So our resource is now set up. We'll go to resource. And now that we're in here, you'll notice if we hit browse, we're not going to see anything because we do not have anything deployed, which makes sense, right? So we're going to actually have to go ahead and deploy something. So we are going to make our way over to the deployment center. And it's just going to tell us that we have yet to configure anything, and that's totally fine. We're going to go to settings. It'll give it a moment. And so the thing is that we're going to need something to deploy. I did not create an app, but the great thing is in the Azure documentation, they have a bunch of quick starts here. All right, and apparently they have one for Ruby as well, but today we are looking at Python. And so they actually have an example repository for us here, which is github.com, Azure samples, Python docs, hello world. And I mean, I could go make a repo for you, but we might as well just use the one that is already provided to us. So I'm just going to pull this up to show you what's in it. It's a very, very simple application. Even if you don't know anything about building web apps, I'm going to walk you through it really easily here, okay? So we're going to open up app.py. So we are using Flask. If you've never heard of Flask, it is a very minimal Python framework for creating web apps. Very uninspiring homepage here, but it gets the job done. It's going to create a default route for us, which we have there. We're going to call hello here, and we're going to have hello world. So that's all that's going on here. Very, very simple. And we have our requirements. This is our package manager. I don't know why Python uses txt files. It's very outdated to me, but that's what they use. And here we have Flask. All right. So we're going to use that repo. And it's a public repo, so it should be very easy for us to connect. So we'll drop down, go to GitHub. And the next thing we need to do is authorize GitHub. All right, so I ran into a bit of trouble there because I could not authenticate my GitHub account, but you know what? I just made another GitHub account, so that made it a lot easier. I'm going to go ahead here, hit GitHub, and we're going to try to authorize it. And so now I'm logged into this new one called Exam Pro Dev, and we'll go ahead and authorize this application, and we're now in good shape. This repository doesn't have anything in it, so if I want to clone something, I guess I'll probably have to fork that repo. So we'll give it a moment to authorize, and while that's going, I think that's what I'm going to do. I'm going to go and fork the example repo, if I can find the link again here myself. I believe it is. That's still authorizing over there. I'm still looking for it. So it was like examples or something, samples or examples. All right, so I found a way around the problem. I just made a new GitHub account. So that's all I had to do. And I just won't be using my primary account until I get my phone back. But so what we'll do is go hit connect. I'll hit authorize. And it didn't prompt me because it already connected to this new one called Exam Pro Dev. You might have to put your credentials in here. And it's going to ask me to select some things. It's a new account, so there are no organizations, there are no repositories, there are no branches, totally brand new. So what I'm going to need to do is get a repo in there. So we'll just go ahead and fork the Azure Samples one. So that is Azure Samples, Python, docs, hello world. And if I type that right, we're in good shape. I'm going to go ahead and fork this repository. I'll say got it. And then I'll move this off screen here. This is now cloned. You should see it cloned here. And we'll go back here. And this probably isn't live, so there's no refresh button here. So we'll have to hit discard. And we will give this another go here. And we will select our organization, which is our name. There's the repository. Should be main branch. It's kind of outdated. I'm sorry, but it's called master. That's what it is. Not my fault. That's Azure's fault, okay? And I think that's it. I don't know if we need a workflow configuration file. I don't think so. Just going to double check here. No, I don't think so. And what we'll do is we'll just go ahead and save that. And so now we are set up for deployment. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Container Instances, also known as ACI, and this allows you to package, deploy, and manage cloud applications using containers, or the way I like to think of it as fully managed Docker as a service. Azure Container Instances allow you to launch containers without the need to worry about configuring or managing the underlying virtual machines. And you're going to be able to design isolate containers for simple applications, task automations, and build jobs. Let's talk about some of the reasons why you'd want to use containers over VMs. So containers can be provisioned within seconds, where VMs will take several minutes. Containers are built per second, where VMs are built per hour, so you'll save a lot more money. Containers have granular and custom sizing of vPCUs, memory, and GPUs, where VM sizes are predetermined. So those are the benefits between containers and VMs. ACIs can be utilized for both Windows and Linux containers. You can persist storage with Azure files using ACI containers. And honestly, if you have containers or functions, you have to have an external storage mounted to persist. It's just the way you do it. ACIs are accessed via fully qualified domain names, which is one of the things I really appreciate about Azure services, because most of the services are like that. Azure provides quick start images to help you start launching example apps, but you can also source containers from Azure Container Registry, Docker Hub, and privately hosted container registries. It looks like that, the choice option there. Let's just talk about container groups, because this is pretty much the only major component you have to worry about. These are a collection of containers that get scheduled on the same host, and the containers in a container group share lifecycle, resources, local network, storage volumes. So the idea is that you have these tightly coupled containers, so all of them act as a service within that container group. So here you can see an example of a couple containers that are mounting Azure files on different directories there. And underneath all of that is running on an Azure virtual machine. Container groups are similar to Kubernetes pods. Yeah, and it says similar to, but not really the same thing. Multi-container groups can currently support only Linux containers, which is kind of a bummer, but that's just what it is. And there are two ways to deploy a multi-container group. You can use ARM templates when you need to deploy additional Azure service resources, or just a YAML file when you want to deploy, when your deployment only includes container instances. Let's take a look at container restart policies, and what these do is allow you to change how the policies restart. And there's three different ways. We have always, never, and on failure. So the first one here, always, means always restart the container. And the idea is to keep your container running as long as possible. And the reason why you'd want that is if you're running a web server. Some other providers would call that a service. Then we have never, so run only one time. This is great for background jobs, and so other providers would just call this a task. Then you have on failure, so containers that encounter an error, that's when it should restart. And so it's as simple as just choosing that option when you are creating that container. Let's take a look at container environment variables, or also known as envars, that allow you to pass configuration details to your containers. And you can do this through the portal, the CLI, PowerShell, which that's always the case with Azure. And so it's as simple as just putting in your key and your value. And one other thing I want to point out is that you can also pass in secured environment variables. So the idea is that sometimes you don't want them plain text. So if you have see how I have that Stripe secret key? You don't want anyone ever seeing that in production. So the idea is that and I don't think you can do this through the portal, but you can do this through the CLI or PowerShell, is provide the secure environment variables over the regular one, which is environment variables. And that way you can pass it securely so it's never exposed to human eyes. Let's talk about persisting storage, and we talked about that a little while there when we were looking at Azure files, but containers are stateless by default. So when a container crashes or stops, all state is lost. To persist a state, you need to mount an external volume, and there's quite a few different things we can mount: Azure files, secret volumes, empty directory, cloud git repo. So you got a few options there. And to mount a file volume, you need to do this via PowerShell or CLI, and you're going to give the following details. So when you launch the container, there's going to be nothing in the portal, so you got to do it this way. All right. Hey, this is Andrew Brown from Exam Pro, and we're going to take a look at Azure Container Instances. So here it is. So all we got to do is go to Container Instances. We'll hit Add. And the nice thing is that Azure provides us with a Hello World one, so it's very easy for us to get started. It's a Linux machine, and it looks like it's pretty inexpensive there, so we'll stick with that. I'm going to create a new group here. We're going to call it Banana, and we'll name the container instance Banana. And East US 2 seems fine to me. You'll notice we're on a quick start image. If we wanted, we could use something from the Docker Hub and provide our own link, but we'll just stick with the quick start image for today. We're going to go ahead and hit next to networking just to see what we have as options. You can make it public or private. We'll go to advanced. Hold on here. Yep, those are just the ports you can expose. We'll go to advanced, and for the restart policy, we can set on failure, always, or never. We can pass in environment variables, and I've covered this a lot more in detail in the lecture content, so we don't need to really dive deep into this. And we'll go ahead and create this instance. And so we'll have to wait a little while here, and I'll see you back in a moment. Okay, and so after a short wait, our container instance is ready. We'll go to that resource there and take a look around. So on the left-hand side, we can go to our containers, and there we can see it running. We can see the events down below of what's going on. So you can see that it's pulled the image, it successfully pulled it, and then it started the container. Some properties, nothing interesting there. The logs if we wanted to see stuff. And if we wanted to connect to the instance, we could also go here and hit connect, which is kind of nice. I don't have any purpose to do that right now. So, and it's also not going to work the way we're doing it, but I just wanted to show you, you had those opportunities. You can do identity, so that means manage it with role-based access controls. But what I want to see is actually this hello world working. I'm assuming that must be a hello page. I've never looked at it before. So we're going to go here, grab the public IP address and paste it on in the top. And there we go. So we have deployed a instance onto Azure container instances, or a container, I should say. So nothing super exciting to talk about here, but we do need to know the basics there. If we wanted to deploy other containers, it's just the one there, so that's all you really need to do. But yeah, so yeah, hopefully that gives you an idea there. I'll just go back to the list here so we can see it, and we'll go ahead and just delete that. Probably do it via the resources on the left-hand side, like I always like to do. And we will go into Banana here, and we will delete Banana, and there you go. Let's talk about networking for Azure. And so everything kind of revolves around the virtual network, also known as the VNet. And this is a logically isolated section of your Azure network where you launch your Azure resources. And here's a very simple diagram of using VNet, but there's a lot of networking components that you're going to be utilizing. And we're not going to go through the exhaustive list here, but let's just go through some of them just to give you an idea of like all the things you can do within Azure networking. So you have Azure DNS. This manages your DNS domain. Then you have the VNet itself. And so underneath that, it'll have like address spaces, route tables, subnets. Then you have network security groups. This acts as a virtual firewall at the subnet or NIC level. You have ExpressRoute. This helps you create a very fast connection between your on-prem to your VNet. Then you have virtual WAN. This is a centralized network to route different network connections. Then you have virtual network gateway. This is a site-to-site VPN connection between VNets and local networks. Then you have your NICs, or your network interfaces, and these are virtual network devices to allow VMs to communicate using IP protocols. And then you have like all your load balancers and other things like that. So again, not an exhaustive list, but just shows you that there's a lot you can do within networking on Azure. One interesting concept is VNet peering, and this is where you can connect multiple VNets so they act as one network. And there are two types of peering. We have regional peering. This is when you peer two VNets from the same region. And then you have global VNet peering. This is when you peer two VNets from two different regions. Let's take a look at network interfaces, which are software or hardware interfaces between two pieces of equipment or protocol layers in a computer network. And so network interface controllers, also known as NICs, that is the actual piece of hardware that connects computer to computer network. And they go by a bunch of different names, such as network interface card, network adapter, LAN adapter, physical network interface, or even Ethernet interface controller card. So if it was back in the 1990s, you definitely would have had one of these in the back of your computer. And if you're a gamer today, then you have one because you want that wired connection, so you have a super fast connection. And so these cards or NICs communicate using the Internet Protocol, also known IP. That's going to allow them to communicate on layer 2, the data link layer, and the physical layer of the OSI model. And so the way these work in Azure is they're called the Azure Network Interfaces, and they have the same initialism, NIC. And so the idea is that you're going to attach a network interface to an Azure VM instance. And without one of these, your Azure VM just can't communicate, because it's just, imagine not having that card in your computer. It would have no way of communicating. And the difference here is that they're just virtual network interfaces, right? So I'm sure at the data center, Azure has a bunch of these actual cards, but they are abstracted away. So, you just treat them as virtual. And an Azure VM instance has to have at least one NIC, but it can also have multiple NICs if you want. And so here's just a nice little graphical representation of a VM that has a NIC attached to it. So there you go. Let's take a look at subnets. And a subnet is a logical division of an address space. So we just looked at address spaces. So we're cutting it up one step further. And subnets help you define different kinds of workloads and allows you to apply virtual isolation within your network. So when you launch an Azure resource, you choose the subnet you want to launch within, and an IP from that subnet is assigned to your resource. So the thing is that when you create route tables, that's how you are associating the subnet so it can access the internet or access anything. And then there's public and private subnets. But this thing is interesting because, like, again, if you're using AWS, those are very clearly defined things. But in Azure, they don't have this concept of public and private. You have to define it yourself. So really, a public or private subnet is just a subnet that doesn't have access to the internet. And so we saw that when we had the route table and we overrode the access to the internet to none, that essentially made it a private subnet. Another thing you can do with subnets is you can associate a network security group, and this is going to help protect your traffic entering and leaving the subnet. So you're making rules based on the IP address, port, and protocol. And then there's this special thing called a gateway subnet. So it's a specialized type of subnet, and it's just for Azure Virtual Network Gateways. And so it's interesting. You'll go in, and there'll be a separate section just for it, and so you'll create it. It's just for that service. To understand Azure DNS, let's first define what is a domain name, and that is a service that is responsible for translating and resolving a service name to its IP address. And so Azure DNS is a hosting service for DNS domains that provides name resolution by Microsoft Azure infrastructure. So imagine you have a domain, you want it to be managed by Azure DNS, and then you can make records like www to point to a specific Azure resource. That's the idea behind there. And there's two types of DNSs you can make. You got a public DNS, an internet-facing one. This is the one you're likely going to be using. So this allows you to manage your domain for internet-accessible domains, point your domains to your website, or creating records that you own the domain, or that you are pointing emails to your email server, so things like that. Then you have your private DNS, which is internal facing. This allows you to use your own custom domain instead of the Azure provided domains. So Azure has its own provided domains, which are fully qualified domains for a lot of services. A great example of this is Azure Storage Accounts. And so that link there is its fully qualified domain. One thing I want to point out is that you cannot use Azure DNS to purchase domains. If you want to purchase a domain, you can actually do that through app services, or you use like a third-party provider such as Namecheap or GoDaddy, and then have Azure manage that DNS stuff. So virtual private networks, also known as VPNs, what they do is they extend a private network across a public network and enables your users to send and receive data across shared or public networks as if their computing devices were directly connected to the private network. All right. And so now we have to talk about what is a virtual network gateway. And so a virtual network gateway is the software, a VPN device for your Azure virtual network. So that's how these devices are going to connect to your network. So when you deploy a virtual network gateway, it will deploy two or more specialized VMs in specific subnets. You need to create a gateway subnet. And these deployed VMs contain routing tables and run specific gateway services. You can choose the type of gateway you want it to be, and this is going to determine whether you'd use something like VPN gateway or express route gateway. So it's as simple as an option like that. But to really understand these virtual network gateways, we should just look at some VPN gateway design so you understand why you're creating these things. So Azure Express Routes creates private connections between Azure data centers and infrastructure on your premises or in co-location environments. And so connections don't go over the public internet, and as a result offer more reliability, faster speeds, consistent latencies, and higher security. So here's a big old graphic here kind of representing what's going on here. And the idea is that you're going to have connectivity from different things, like from any to any, so that's IP VPN network, a point-to-point Ethernet network, a virtual cross connection, and this is all going to be going through a connectivity provider at a co-location facility. So this example would be an edge partner. And so you would be the customer network. That'd be your on-premise or whatever you want to connect so that you can make it all the way to your Azure services. And the way you would establish a connection is you create these express route circuits. It's pretty common to have more than one because you want to have high availability just in case the other one goes out. The idea is that you can route this traffic to a couple different places. So the first one would be things like peering to Office 365, Dynamics 365, or even your Azure public services. So when we say public services, imagine you just launch a virtual machine that is in a public subnet that has an IP that's reachable from the internet. That could just be to that. Or maybe you're using like CosmoDB, or like you have fully qualified domains for other services. So it's just a way that you can get there. And then let's talk about the other side, which is doing private peering for VNet. So the idea is that you have a private VNet, so the subnets are private, and so the only way is going to be access it. You want a direct way to access it that way. So that's the two ways there. And just to note, there is Express Route Direct. And so this is like Express Route with an additional benefit that has greater bandwidth connections from 50 megabytes per second up to 10 gigabytes per second. And this is really ideal if you have hybrid solutions where you're moving massive amounts of data, or where latency matters, because you want to feel like these cloud services are right there with your on-premise environment. You're going to need a lot of speed for that. So Azure Private Links allows you to establish secure connections between Azure resources so traffic remains within your Azure network. And so I got this big old graphic here. And so let's just define a few things. I'm going to pull out my pen here. And so imagine you have workloads on your on-prem, or you have your own virtual network on Azure. And so you have some VMs doing some stuff. And the idea is that you want to connect them to some other services over here. But the thing is that if you wanted to connect them, they might try to transverse the internet. So if you're on-prem, it's going out here, and it's going over here. And so the issue with this is that it's not necessarily secure. Another issue could be, it's just faster if it would just stay within the actual network, because if you're already connected, your stuff over here, then why wouldn't it just go through the actual network? Another thing is like data transfer costs. So it's always going out the internet and coming back in, and that's not a great scenario. So I'm just going to erase all that stuff there. The idea with Private Link is that it's just keeping everything within the Azure network. And so that's what it's doing. So if you want to, connect your workloads in your VNet or your on-prem that connects to a specific VNet, the idea is that you can launch a private link endpoint, which is a network interface, and this is what's establishing that connection. And you're going to have to give that private endpoint a private IP address from your VNet. And so then the idea is that on the right-hand side, that's what you want to connect to. There's a lot of Azure services by default works with private link. So there's no additional configuration. You'll just be able to say use private link, and they will. Same thing with some third-party providers in the marketplace. They might be powered by private link. And then there's a third case where, let's say you have like a private subnet and you have some VMs there. So what you could do is if you have a load balancer and you need to have an internal load balancer there, you can launch the private link service. And this is going to basically make your workload in that VNet become compatible or powered by private link. So there you go.
Hey, this is Andrew Brown from Exam Pro, and we're going to look at making our own virtual network. So we made a resource group, but we also need a virtual network or VNet, so we actually have some network to launch our resources within. So what I want you to do is make your way all the way to the top here, and we're going to go ahead and type in VNet, which will get virtual networks, and go ahead and click that. And if you notice, you don't have any networks, so we're going to have to go ahead and create our own. So go ahead and hit the Add button. And we're going to have a bunch of options here. I'm just going to name this, we're going to choose that resource group, so Exam Pro. And we're just going to name this Exam Pro VNet. And there are some additional steps here. We'll just take a peek here. We don't really need to change anything, but we'll just take a look. So for IP address, you can set the IP address space. It's going to default to 10.0.0/16, which is very good for us. You can see that it supports IPv6, which is great. It's going to create us a default subnet, which is going to be 10.0.0/24. That's going to be a subnet with like 256 IP addresses, which is great. If we go to the security tab, we have DDoS protection basic, and you definitely want to stay on that because that is free. Same thing with the firewall. We don't want it on because that's going to cost extra money. I'm going to go back to basics. We're going to hit review plus create. And we're just going to wait for validation to complete. This could be instantaneous for you, or you could wait a few seconds. It's different for everybody. And now the validation has completed. We'll go ahead and hit create. And so we'll just wait for that to finish creating. Great, so it's created, so it's just saying deployment is underway. So we're just gonna have to wait a little bit here until it says deployment is complete, and it's already done super fast. And we'll go ahead and hit go to resource. And so now we are in our virtual network, and we have a bunch of settings on the left-hand side, so address space, subnets, et cetera, et cetera. Nothing we need to know at this level. We just need that virtual network so we can launch resources in. So now that we have resource groups and virtual networks, we can start launching resources. So there you go. I'll see you in the next follow along. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Storage Services, starting with Azure Blob Storage. So I would describe this as object serverless storage. So if you ever heard of object storage or serverless storage, this is going to make sense to you. So you're able to store very large files and large amounts of unstructured files. And the idea here is that you pay for only what you store. It's basically unlimited storage. You don't have to resize the volumes. You don't have to worry about file system protocols. You just upload files. And that's why it's considered serverless storage. Then we're going to move on to Azure Disk Storage. This is the most common type of storage you'll encounter. We can describe it as a virtual volume. So you're just choosing either an SSD or an HDD. So it's basically a hard drive in the cloud. It has encryption by default, and it's attached to virtual machines. So anytime you're spinning up a virtual machine, it's probably spinning up also Azure Disk Storage attached to it. Then you have Azure File Storage. So this is a shared volume that you can access and manage like a file server. So it's going to use protocols such as SMB. The reason you'd want this is that, let's say you had multiple virtual machines, multiple servers, and you wanted them to all share the same hard drive. That's what you'd use it for. Or if you need to have users access it using those protocols, that's another way of doing that. Then you have Azure Queue Storage. Now I put an asterisk in front of it because this is just a weirdly named service because this is really for a messaging queue. This is actually for application integration, but I list it here because they put the word storage on it. So I just think it's poorly named. And even the way they describe it is just makes you think it's storage, but it's a data store for queuing and reliably delivering messages between applications. So it's just integrating two applications together, passing messages along. Another one that's confusing is Azure Table Storage. I would put this in the database categories, and it's a NoSQL database, and specifically it's a wide column NoSQL database. And as they describe, it's a NoSQL store that hosts unstructured data independent from any schema. So just be aware of those two. They're just very poorly worded. Then you have Azure Data Box, and also its upgraded version, the Azure Data Box Heavy. This is a rugged briefcase computer and storage designed to move terabytes or petabytes of data. So imagine somebody shows up at your door with this tower that's a computer, and you plug in your USB or whatever you want, and you transfer all your files locally on your on-premise data center, and then they ship it because it's faster to ship the data on a physical piece of device than it is to send it over the internet. That's what Azure Data Box is. And then we have Azure Archive Storage. So this is long-term cold storage for when you need to hold onto files for years, but you want the cheapest storage options. If you have lots of data and it's not doing anything, you definitely want to be putting it on the cheapest possible storage devices. Cheap meaning doesn't mean that they're not reliable. It just means that they're not active. The disks are not actively spinning. Nobody's accessing the data on those hard drives. The last one is Azure Data Lake Storage. And so this is a centralized repository that allows you to store all structured and unstructured data at any scale. When you're working with big data, from multiple different sources and you need it to be in one place, that is the service for you. And so that is the Azure Storage Services.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Storage Accounts, which is used for containing all your Azure Storage data objects such as blobs, files, queues, tables, and disks. So Storage Accounts is one of those services where it has a bunch of different storage types within it. So it's quite the multi-purpose service, and with each different type of storage, it's going to have different features and their own pricing models. Let's just quickly break down the type of storage we have. So we have general purpose, version 1, version 2, blob storage, blob storage, and file storage. And so I just want you to know that when you are using storage accounts, I'm saying storage type, but for whatever reason, the UI calls it account kind. Just to be aware of that small little discrepancy there. But storage accounts are going to vary based on features. And so the common features we'll see across storage will be supported services. So where can I put this storage account? And so on the right-hand side, you can see, like if you make a general purpose version 2, what you have access to, such as containers, queues, tables, or file shares, those options are going to change based on what you're using. All right. For performance tiers, this is how fast you'll be able to do reads and writes. You have standard and premium. You have different kinds of access tiers. So how often do I need to quick access these files? And then there's replication. How many redundant copies should be made and where? And the last thing is deployment models. So who should deploy the supported service, Resource Manager Classic? And in generally most cases, it's going to be Resource Manager. So here I have all the storage types on the left-hand side, and we have the feature set and how it's going to vary based on the certain types. So let's just quickly look through this to see where there are some standouts. And you might want to actually review this at the end of this section just so you're a bit more familiar with all these types of features. So it clicks a bit better, but let's just quickly go through this. So you're going to notice for version 1, this is the only case where you're going to have a deployment model of Classic. Everything else is going to be the Resource Manager. From a practical standpoint, you're not going to really notice because you're just going to be pressing buttons, but underneath, that's the only case where it varies. For replication, you're going to notice that version 2 has the most options with replication. And if these don't make sense, don't worry. We're going to cover all the replication in an upcoming slide. For block storage, you can see it's very limited. Same with file storage. So that's there. When we're talking about access tiers, how quickly you can access files, you're going to notice that it's only available for general version 2 and blob storage, where we're choosing these different tiers. For these ones, it doesn't really matter because, well, especially with like a file storage, because the drive is as fast as it's going to be, right? For performance tiers, you're going to notice that with version 1 and version 2, we have standard and premium. When you're using file storage and blob storage, you're always using premium. And with blob storage, which is, again, a legacy format there, that's going to be using standard. Blob storage comes in 3 different types, and you're going to notice that based on what you want to use, there'll be some variation there. I don't know where page is. I think that they both support page, but there are 3 types in there. I wouldn't really worry about it too much. You're going to notice that file storage only supports file types, and then you have version 2, and this pretty much supports everything. So you can see general purpose version 2 is a really great storage to choose. So we were just talking about storage types. Now let's talk about the actual storage services that we can actually launch or utilize within these storage types under storage accounts. And there are 5 core storages available to us. The first is Azure Blob. This is a massively scalable object store for text and binary data. And it also includes big data analytics through Data Lake Storage Gen 2. And so Azure Blob is really great because you just don't have to think about the file system. You just upload files and they're treated like objects. So that's really nice. Then you have Azure Files, and this is a file share. And so the great thing about Azure Files is that if you want to have a bunch of virtual machines and have it so like they have the same file system, sharing all the same files, that's what you're going to use that for. Then you have Azure Queues. To me, this really is a database, but for whatever reason, it's under storage accounts, and it's a NoSQL store for schemaless storage of structured data. This is another unusual one. I don't know why Azure puts it under here, but It's a messaging store for reliable messaging between application components. To me, that's like an application integration service, but Azure categorizes it as storage. And the last one is Azure Disks, and this is block level storage volumes for Azure VMs. And so the idea is that when you want to do the top 4 or the above, you're going to be launching storage accounts. And for disks, you're going to be launching disks. It's a bit unusual because one of the storage accounts say that you can use or store disks in, I think, version or general purpose version 2. I'm not really sure I understand that. Maybe it's talking about like backing them up or something like that. But anyway, from practical standpoint and for what we need to know is that this is the breakdown here. And we do have a full section on Azure disks. So we will get into that. So now let's take a look at some of the features that are available on account storage. The first being performance tiers, and generally this is going to be for blob storage. And we have 2 types of performance tiers. We have standard and premium. So it's as simple as just choosing between the 2. And when we're talking about performance, especially when we're talking about storage, we want to be thinking about IOPS, and that stands for input-output operations per second. So the higher the IOPS, the faster a drive can read and write. So you can definitely assume that premium is going to have a higher amount of IOPS. And so when we're looking at the premium performance, these are going to be stored on solid state drives, SSDs, which we have in the picture there. It's optimized for low latency, higher throughput, and the use cases here is going to be interactive workloads, analytics, AI or ML, and data transformation. On the other side, for standard performance, these are running on hard disk drives, and you're going to have varied performance based on your access tier, and we're going to talk about access tiers very shortly. But the tiers would be hot, cool, and archive. And this is great for backup and disaster recovery, media content, bulk data processing, and things like that. And so the reason why SSDs are generally really, really good for premium performance is because they have no moving parts within them, and the data is distributed randomly. So if you have to do a read and write, the distance between the read and writes are going to be a lot faster. And that's generally why you're going to see solid state drives with premium performance or things with higher IOPS. And then for hard disk drives, it does have moving parts. So you see that it has an ARM, and that ARM needs to read and write data sequentially to the disk. And so it's very good at writing or reading large amounts of data that is close together, that is sequential. But, you know, the idea is that neither format is good or bad. It's just the use case that you need. So you don't always need to go with SSDs. Sometimes you want to save money, and HHDs or HDDs are really good for that. So let's take a look at access tiers. And there are 3 types of tiers for standard storage. We have cool, hot, and archive. And so you're going to have this option between cool and hot and archive. Archive might not show up depending on how you configure your storage account. So for example, if you use a particular type of replication, that might not be available to use with archive. So just be aware if that option doesn't show up, you might have to change some of your settings. Let's quickly walk through the 3 options. So hot is for data that's accessed frequently and has the highest storage costs and lowest access costs. So again, it's for data that's frequently accessed or in active use, or data that's staged for processing and eventual migration to the cool access tier. Then you have the cool tier. This is data that's infrequently accessed and stored for at least 30 days. Lower storage costs, higher access cost. And the use case here is for short-term backup and disaster recovery datasets or older media content not viewed frequently anymore, but is expected to be available immediately when accessed. And I think there's actually a third use case, which is large data sets that need to be stored cost-effectively while more data is being gathered for future processing. Then we have the archive tier. This is for data that's rarely accessed and stored for at least 180 days. It's the lowest storage cost, but it also has the highest access cost. And so its use case would be long-term backup, secondary backup, archival data sets, original raw data that must be preserved even after it's been processed into its usable form, and compliance and archival data that needs to be stored for a long time and is hardly ever accessed. So just make use or note of the cool is at the least 30 days and the archive is at least 180 days. I should have highlighted those for you. I don't know why I didn't. And so just some other things you need to know. So for account level tiering, any blob that doesn't have an explicitly assigned tier infers the tier from the storage account access tier settings. So you can set blobs at different storage levels. Blob level tiering, you can upload a blob to the tier of your choice and change the tiers happen instantly with exception from moving out of archive. The concept of rehydrating, this is when you're moving a blob out of archive into another tier and can take several hours. You have the blob lifecycle management, so you can create rule-based policies for transitioning your data to different tiers. So after 30 days, we can move it to cool storage, and here is just the option here. You see where it says 30. I think 30 is the minimum days you have to choose, but I could be wrong. And so you have the options down below. So move to cool storage, move to archive storage, delete the blob. And just a few other things here. When a blob is uploaded or moved to another tier, it's charged at the new tier's rate immediately upon the tier change. So when you're moving to a cooler tier, the operation is billed as a write operation to the destination tier. And when the write operation per 10,000 and data write per gigabyte charges for the destination tier applies. When moving to a hotter tier, the operation is billed as a read from the source tier, and where the read operation, again, in the 10K, and the data retrieval, again, in gigabytes, charges for the source tier applies, and early detection charges for any blob moved out of the cool or archive tier may apply as well. And just lastly here, when we're talking about cool and archive early detection, any blob that is moved into the cool tier, so this is only for general purpose version 2 accounts, is subject to a cool early detection period of 30 days. And any blob that is moved into the archive tier is subject to an archive early detection of 180 days. And this charge is prorated. So, access tiers aren't the funnest thing to talk about, but there is all the information you need to know. So let's take a look at replication and data redundancy. And so when you create a storage account, you're going to have to choose a replication type. And the reason why is that you're going to want to have multiple copies of your data so you're protected from a bunch of things. So maybe your data center has a planned outage, so you have to make sure you have a backup of your data if you need to access it. Maybe there is a hardware failure or network or power outage or natural disaster. And so that is the whole point of replication. And the greater level redundancy, the more expensive the cost of replication will be. And talking about cost, we can break it down into 3 categories. Each of these categories have 2 types of replication. So let's just quickly go through the list, and then we'll deep dive into all of them in the upcoming slides. So for the first part, we have primary region redundancy. So we have local redundant storage, LRS, and zone redundant storage, ZRS. And locally redundant storage is the most cost-effective tier. So that's the one I'm usually going for a lot, especially when I'm running using development accounts. That's what I'm always setting. And so the use for this tier is generally disaster recovery and failovers. The secondary region redundancy, we have geo-redundant storage, GRS, and geo-zone redundant storage, GZRS. And the reason you'd want to use this tier is for also disaster recovery and failovers, but it has a higher level redundancy. Then the last one here is secondary region redundancy with read access. For this case, what we're going to have is read access geo-redundant storage, so that's RAGRS, and read access geo-redundant storage, RAGZRS, and that's going to generally be for read replicas. And if you can't remember all the initialisms, don't worry, I don't either, but there you go. So what we're going to do is take a closer look at the replication type, starting with the primary region redundancy. And so for this tier, all the data is going to be replicated at least 3 times in the primary region. And we got 2 options. We have LRS and ZRS. And by the graphic, you can tell that they're slightly different. And so for LRS, it's using synchronous replication for those other pieces of data. So you notice in that region there are there's 3 versions running. And so when we say synchronous, we mean that if I want to read from any of those copies, they're all going to be 100% up to date. So that's what synchronous means. And so here we have a durability of 11 nines. And this is the absolute most cheapest option when choosing storage accounts. So if you're running this for developer accounts and you do not care about replication, choose LRS. For ZRS, we have copies of data synchronously to 3 different availability zones in the primary region. And this has a durability of 12 nines, so it's clearly more durable. And so why would you want to choose the primary region over the LRS? Well, the idea is that if an availability zone goes out, you still have your data in two other regions, where in the case of LRS, if the availability zone goes out, your data is gone, okay? So that is the first tier. So now we're taking a look at secondary region redundancy, and the purpose of this is if you have your primary region suffers a regional disaster, so all the data centers are out in your primary region, you can rely on that secondary region. And your secondary region is going to be determined based on your primary's pair region. So regions are paired with another region, and so you don't get to pick your twin. It is what you get, okay? And so secondary regions aren't available for read and write access, except in the event of failover. So basically, the redundant copy in the secondary region is just there on standby, but it's not in use. And so let's just talk about GRS and GZRS. And you'll notice again by the graphic, they look a bit slightly different, but you can kind of get the idea based on our previous version or previous primary storage tier. And so data is copied synchronously within the main primary region, and then data is asynchronously copied to another region. So asynchronous means that if you try to read from the second region, all the data might not be there, okay? Again, synchronous means if you read from something, there's a guarantee that it's going to be the same, and asynchronous means that there's not a guarantee that the data is one-to-one to the original. And the durability here is 16 nines. Going over to GZRS, we have data is copied synchronously across 3 availability zones in a physical region, and then the data is copied asynchronously to another region. And I believe that the data in the secondary region is not necessarily in 3 other AZs. At least that's the graphic I made there, so hopefully that is true. But yeah, there you go. So now we're going to take a look at redundancy in the secondary region with read access. And the whole purpose of this region is so that you can actually have a read replica in another region. And so the concept of that is having your data in sync, okay? And so down below we have RAGRS and RAGZRS, and it's going to look very similar to the last setup. But the key difference is that now data is synchronous in both the primary and the secondary region, because if you're going to be reading from it, you want to make sure that your data is one-to-one with your primary region's data. So there you go. So we keep on mentioning about Azure Blob Storage. Let's actually talk about it now. So Blob Storage is an object store that is optimized for storing massive amounts of unstructured data. And unstructured data is data that doesn't adhere to a particular data model or definition, such as text or binary data. And Azure Blobs are composed of the following components. So I have this graphic here. So the first thing is your storage account. And I didn't mention this prior, but when you create a storage account, you actually get a fully qualified domain. A lot of Azure services are like this, where you get a fully qualified domain so that you can access it from everywhere. And this is a really nice feature, but that means that when you're naming your storage account or other Azure services, you have to treat it like a domain name and you have to choose a unique name. The next thing are containers. And this is a little bit confusing because when we think of containers, we think of computing, but Azure account storage has the concept of containers for blobs, and it's just what they call folders. So just be aware of that. And then you actually have the actual data being stored, and these are the blobs. So there are 3 types of blob storage. We have blob blocks, and this is what you're going to primarily be using. And so this is when you store text and binary data. It's made up of blocks of data that can be managed individually, and it can store up to 4.7 terabytes of data. Then you have append blocks, and these are optimized for append operations. So imagine that you have logs from a virtual machine and you want to write them to blob storage. This is going to be a lot more efficient if you're using append blobs because they just append to the end of the file. And the last is page blobs. And these store random access files up to 8 terabytes in size. And these are just for storing virtual hard drives, so VHD files, and serves as disks for Azure virtual machines. So there's the 3 types. Let's take a closer look at AZ copy, and this is a command line utility that you can use to copy blobber files to or from a storage account. So the first thing you're going to need is the executable file, and there you can see they have it for Windows, Linux, and Mac. And then once you download that file, what you're going to have to do is also make sure that you have the right level of authorization for the user account that you're using with it. So you might need to, for download, you'll need storage blob data reader. For upload, storage blob data contributor, and storage blob data owner. So just be aware that you need to have those roles available to you, to your user account. I think that I have access to everything, so I don't think I set this. It just works. But if you're in a larger company and you have more least permissive roles, you just need to know about that. And so you can gain access via either the Azure Active Directory or a shared access signature. So let's just take a look at that right now. So the idea here is that we'll type in AZ copy login, and this is going to ask us whether we want to sign into the web browser. So that should be Azure Active Directory option 1. And so what you'll do is you'll enter your username and password, and you'll then have to enter the code displayed there. And so now you're ready to use the CLI. And so all you have to do is type in AZ copy, and then you have the file, and then you give it the endpoint to the storage account and the container and the location you want it to go in. If you want to download files, it's the same command. You just reverse the order. You say, this is the location of the file. I want to download it locally. All right. Let's talk about Azure Storage Explorer. So this is a standalone app that makes it easy to work with Azure storage data on Windows, Mac OS, and Linux. And you can create a variety of things. So I just want to show you, and here I am running on a Mac, but on the left-hand side, you can see I have my subscriptions, my storage accounts, my disks, and we have some options where we can like upload files, download files, open stuff, clone stuff, create some things. And so this is just an easy and convenient way to access your file or your account storage and work with them. So let's take a look at Azure Files, and this is a fully managed file share in the cloud. And the idea behind this is that it's like a centralized server for storage that allows multiple connections. Or the way I like to think about it, it's like having one big shared drive that everyone can use or work on at the same time. And when I say everyone, I mean your virtual machines. So here is a visual representation, but let's just talk quickly about it. So the idea is that you're going to be using a network protocol in order to facilitate communication. And so the two most common ones is server message block, which I believe was created by Microsoft, and network file system, NFS, which is very commonly used on Linux files or Unix-based file systems. And what you're going to be doing is you'll have to establish a connection with your file shares file system. And what you'll be doing is making it accessible within a specific directory, so a folder within your drive. Okay, and this is called mounting. So you notice there it says Z, X, and Y. So on Windows, you'd actually have the option when you mount it to say, I want to mount it to Z. And so anytime you access Z on your Windows server, it's actually going to be using Azure Files. Okay. So let's talk about all the use cases for Azure Files. Normally to have a spiffy graphic here, but because Azure Files has so much utility, all I have room for is a bunch of text, but we do need to learn it all because it is such an important service. So the first use case is that it can serve as a replacement or supplement for your on-premise file servers, network attached storage, your NAS devices. If you're performing a lift and shift is when you're moving data in the cloud. We'll describe it in a second here. You can use Azure Files for that. And so we actually have two different kinds of lifts we can do that Azure defines. We have a classic lift and a hybrid lift. So in a lift and shift, this means when you move workloads without re-architecting. So the idea is like you used to use on-premise, you want to use Azure, but you're trying to keep things as similar as you can. Very commonly, lift and shifts from on-premise to the cloud will just be taking your virtual machines and then just copying and then bringing them onto the cloud with nothing else, right? But anyway, in the case here for storage, we have the classic lift. This is where both the application and its data are moved to Azure. And then in a hybrid lift, this is where the application data is moved to Azure Files, and the application continues to run on-premise. So clearly, the classic lift is bring everything over. Hybrid lift is like leave the application behind. Another reason you'd want to be using Azure Files is that it's going to simplify your cloud deployment. So imagine you have shared application settings, so you have multiple virtual machines and workstations, and they all rely on the same configuration files. You can just go ahead and mount that drive and share that information. If you're doing diagnostic tests, so let's say you have a bunch of virtual machines and they're logging to those machines, and you want a developer to go in and quickly debug them. Maybe there's a reason why you don't want to use a third-party provider because of compliance or security reasons. But the idea is that all these VMs can just log to the file share, and so now you have centralized logs across many machines. Another use case is that you need to quickly share development tools, so you could put all your tools onto the drive, and so the developer would mount it, and now they can set up a local environment a lot faster. When we're talking about containerization, we have a few options here. So if you are using containers, generally by default, containers are stateless, and so you need to persist volume somehow, and so that's what you're going to do. You're going to be using Azure Files to do that. And also another question is, why would you use Azure Files instead of setting up your own file share server? Because that's definitely an option that you can do. And the reason why is that shared access. So it already has the standard protocols, so you don't have to configure them. It's already baked into the service. It's fully managed. And this is something that I don't think should be underlooked, because it's very difficult to scale a file server. So they will apply patches for it, and it will just automatically scale. Another thing is that it already has a lot of scripting and tooling built in. So if you want to use the Azure API or PowerShell, you can automate the management and creation of files and things like that. And it's also extremely resilient. So you can be sure that it's going to remain running. So there's a lot of use cases there, but definitely worth our time. So there you go. All right, so we heard of Azure Files, but there's also another service called Azure File Sync. And so the idea behind this service is that it allows you to cache Azure file shares on an on-premise Windows Server or cloud virtual machine. And so here is the visual graphic here, where you can see on-prem, Azure VMs, and your Azure backups. And so the idea here is that you can use any protocol that's available on the Windows Server to access your data locally, including SMB, NFS, and even FTP. And you can have as many caches as you need across the world. So, I mean, like, this is kind of like having a OneDrive, right, for your file share, because it's keeping, or like any kind of cloud storage, it's just keeping your files in sync. And the nice part is, like, you can have files in the cloud, and they're referenced on your computer, but you only need to access them when you need them, so you don't have to have all these files locally. Okay.
Hey, this is Andrew Brown, and in this video, I'm going to show you how to set up blob storage. And so if you remember through the actual course, blob storage is like serverless storage, so you don't have to worry about running out of space or resizing your disks. So let's go to it. At the top here, I want you to type in blob storage, and you're going to go to storage accounts. And this is where you end up creating all of your storage accounts. You can see that we have a couple of storage devices from the virtual machine, and when we created the serverless function there. So go ahead and hit add. And what we're going to do is choose Exam Pro, or whatever you called yours when we were at the resource group step. Then we're going to have a storage device. I'm going to say my blob storage. Oh, it has to be all lowercase. My blob storage. And that's already taken. So we'll say Exam Pro blob storage. And it can't have hyphens. There we go. And so we're going to launch it in US East. We have the difference between standard and premium. I think we'll stick with standard. We have storage type V2 or V1 or blob storage. We want blob storage. We have some replication options here. I'm just going to leave it alone. We have access here, hot or cool. We're just going to leave it hot. And we can just look at networking here for a moment. We're going to leave this alone. We're just going to look advanced in a moment. So nothing exciting there. We'll go back to basic, hit review plus create. We'll have to wait for validation. We'll go ahead and now hit create. And then it should say deployment underway. We're waiting to see this say deployment complete. You might be getting into the rhythm of how creating services now. It's almost always the same process. And we'll just wait here till this is complete. Okay, great. So I just waited a minute there, and now that's all set up. So let's go ahead and hit go to resource. And then we have a lot of stuff around here. So what we want to do is we want to start uploading files, but I think we have to create a container first. So go all the way down here, left-hand side, and go to containers. Then we're going to create a new container. I'm going to call this Star Trek. It's going to be a private container, so it's only just for me. We'll hit create. And now we should be able to click into that container. All right, so now now that we have that container, what we can do is go ahead and upload our first file. I just happen to have a file on my desktop here. So I'm just gonna go select that there and upload. All the options by default are great here. We'll just hit upload. And there we go. So we just uploaded a file into our blob storage. Yeah, so that's all there really is to it. So now that we're all done there, we can just go ahead and delete this container. So I think we'll just go back to storage accounts. Not sure if we have to delete the containers first. I guess we'll find out. And we'll just go here to blob storage. We'll go ahead and hit delete. And we'll hit yes. And we'll go to delete. And there you go. So we'll just go back to Microsoft Azure there, back on our desktop, and I'll see you in the next follow along.
Hey, this is Andrew Brown from Exam Pro, and in this section, we'll be covering the Azure Cloud Adoption Framework. Cloud Adoption Framework is a white paper that is a step-by-step process to help organizations plan and migrate their workloads to Azure. The image outlines the Microsoft Cloud Adoption Framework for Azure, a systematic approach to transitioning to the Azure cloud. The process is categorized into stages. Define strategy. Here, the focus is on understanding motivations, grasping the reasons for cloud adoption. Business outcomes, identifying the desired results. Business justification, validating the move's reasons. First adoption project, kickstarting the cloud journey. Plan, this stage includes rationalizing digital estate, evaluating current digital assets. Initial organization alignment, ensuring everyone is aligned with the migration's goals. Skills readiness plan, equipping teams with necessary cloud skills. Cloud adoption plan, laying out a roadmap for the cloud transition. Ready, this phase ensures preparedness. Azure Readiness Guide, preparing the environment for Azure. First landing zone, setting up an initial secure Azure environment. Expanding the blueprint, broadening the Azure setup as per requirements. Best practice validation, ensuring adherence to Azure best practices. Adopt, the actionable phase where migrate, existing workloads are moved to Azure. This entails the first workload migration, understanding expanded scenarios, validating best practices, and making process improvements. Innovate, transform services in the Azure environment using innovation guides, exploring new scenarios, validating best practices, and furthering process improvements. Govern, this is about oversight and management. Establish a methodology and benchmark for governance. Implement initial best practices, standards for Azure use. Measure governance maturity, how well governance rules are followed. Manage, this deals with ongoing operations. Ensure business commitments are met during the transition. Set and assess the operations baseline. Determine operations maturity, gauge the efficiency of cloud operations. Now, let's take a look at the security roles and responsibilities of the Azure Cloud Adoption Framework. Business and technology outcomes. Goals and results expected from security functions. Security outcomes. Results an organization aims for, including governance, prevention, and response. Role types. Security leadership provides security direction and strategy. Security architect designs and implements security blueprints. Platform, app security engineers ensures security of platforms and applications. Security operations manages real-time security threats. Responsibilities. Security leadership sets security strategy. Security architecture designs secure systems. Security compliance ensures adherence to regulations. Policy and standards set security policies. Posture management manages overall security stance. Phases of security implementation. Plan identifies security needs. Build implements strategies, including access control and asset protection. Run manages ongoing operations, including prevention and response. feedback loop, continuous improvement cycle, and security operations. In summary, the framework offers a structured way to transition to Azure, ensuring strategy alignment, preparation, adoption, governance, and effective management. The next topic we'll be covering is Azure Migrate. Azure Migrate offers a streamlined service for migration, modernization, and optimization on Azure. It simplifies the pre-migration processes like discovering, assessing, and appropriately sizing on-premises resources for infrastructure, data, and applications. With an extensible framework, Azure Migrate easily integrates with third-party tools, broadening its range of supported scenarios. Here's what it offers. Unified migration platform, a centralized portal to initiate, execute, and monitor your Azure migration journey. Diverse toolset, Azure Migrate provides a suite of tools for both assessment and migration. It features tools such as Azure Migrate, discovery and assessment and migration and modernization. Furthermore, it seamlessly integrates with other Azure services, tools, and third-party offerings from independent software vendors. Comprehensive migration and modernization capabilities. In the Azure Migrate Hub, you can assess, migrate, and modernize servers, databases, and web apps. Assess and migrate on-premises servers, web apps, and SQL Server instances to Azure. Databases. Analyze on-premises SQL Server instances and databases and migrate them to Azure SQL on a VM, Azure SQL Managed Instance, or Azure SQL Database. Web applications. Evaluate on-premises web applications and transition them to the Azure App Service or Azure Kubernetes Service. Virtual desktops. Review your on-site virtual desktop infrastructure and move it to Azure Virtual Desktop. Data transfer. Efficiently and affordably transfer vast data volumes to Azure using Azure Data Box products. By using Azure Migrate, organizations can streamline and simplify their migration process, reduce downtime, and improve the overall efficiency and cost-effectiveness of their cloud migration. The next thing we'll be covering are the integrated tools in Azure Migrate. The Azure Migrate Hub includes these tools. Azure Migrate Discovery and Assessment. Discover and assess servers including SQL and web apps. Discover and assess on-premises servers running on VMware, Hyper-V, and physical servers in preparation for migration to Azure. Migration and modernization. Migrate servers. Migrate VMware VMs, Hyper-V VMs, physical servers, other virtualized servers, and public cloud VMs to Azure. Data Migration Assistant. Assess SQL Server databases for migration to Azure SQL Database, Azure SQL Managed Instance, or Azure VMs running SQL Server. Data Migration Assistant assesses SQL servers, identifies potential migration problems, unsupported features, and suggests the best path for database migration. Azure Database Migration Service. Migrate on-premises databases to Azure VMs running SQL Server, Azure SQL Database, or SQL Managed Instances. Azure Database Migration Service is a managed service for seamless migrations to Azure data platforms with minimal downtime. Mover. Assess servers. Mover is a SaaS platform that enhances business intelligence by accurately depicting environments within a day. Web App Migration Assistant. Assess on-premises web apps and migrate them to Azure. Azure App Service Migration Assistant is a standalone tool to assess on-premises websites for migration to Azure App Service. Azure Data Box. Migrate offline data. Use Azure Data Box products to move large amounts of offline data to Azure. So that's an overview of the integrated tools in Azure Migrate. The next migration solution we'll be covering is Azure Data Box. The Microsoft Azure Data Box Cloud solution lets you send terabytes of data into and out of Azure in a quick, inexpensive, and reliable way. Each storage device has a maximum usable storage capacity of 80 terabytes and is transported to your data center through a regional carrier. It is designed to help customers with slow or limited internet connectivity to move large volumes of data to the cloud. Let's take a look at some of Azure Data Box's use cases. Data Box is used to import data to Azure for one-time migrations, moving large on-premises data, transitioning offline tapes, relocating VMs, SQL servers, applications, and transferring historical data for Azure-based analysis. Initial bulk transfers, large-scale transfers using Data Box, followed by incremental network transfers. For example, moving vast backups with partners like Commvault. Periodic uploads, transferring large volumes of data generated periodically, like video content from oil rigs or windmill farms. For exporting from Azure, Data Box is used for disaster recovery, restoring Azure data on premises quickly. Security requirements, meeting mandates that require data extraction from Azure storage tiers like US Secret. Migration, moving data back to on-premises or to a different cloud provider. Here's how Azure Data Box works. Customers order a data box from the Azure portal. When the data box arrives, customers connect it to their network and configure it using the Azure portal. Customers copy data to the data box using standard file transfer protocols, such as SMB or NFS. Once the data transfer is complete, customers ship the data box back to Azure. Azure copies the data from the data box to the customer's Azure storage account. So that's an overview of Azure Data Box, its use cases, and workflow. Hey, this is Andrew Brown, and before we get into Azure AD, I need to point something out. It's not called Azure AD anymore, it's called Microsoft Entra ID. Microsoft decided to change the name of Azure AD. Why? Nobody knows, but I can tell you no customer likes this particular change. Somebody who just had a lot of time on their hands over at Microsoft. But we do need to address this. And I need to point out that I'm not refilming all of the content that I made just to change the name, because that's crazy. I will at some point when the content is stale, but the content's not stale. They just changed the name on us. But I want to just go over that quickly here. So the names here, we have Azure AD is now Microsoft Entra ID. Then the Azure AD tiers is from P1, P2, still P1, P2. The Azure AD external identities is now called Microsoft Entra External Identities. If we scroll on down, we have a logo change. So instead of this, which by the way, I really like the old logo. They didn't need to muck with it. But anyway, we have the older ones here. And so this is the new one here. And so there are some name changes here. Azure AD single sign-on is now Microsoft Entra single sign-on. We'll go down below here and you can see, well, more name changes. Okay, so anyway, yeah, they renamed it, and customers are just going to take a while to get used to it. I still like calling Azure AD. I know a lot of other people that like still calling it Azure AD, but it's at some point we'll get moved over to it, and we're just going to use both names. Okay, now coming over to the portal, I need to show you that if you type in Azure AD, it's still going to pull up Microsoft Entra ID, okay? Now, you don't want Azure AD B2C, which is interesting. They didn't rename that, which is it is part of Azure AD, kind of in a sense, but it's more for if you're building applications and you want to have authentication into it. So just understand that there's not consistency all over the place, especially even their documentation. The marketplace still says Azure AD all over the place. Even down below, Azure AD notifications. So, there's just going to be that legacy of Azure AD. But anyway, yeah, what you want to do is go over to Microsoft Entra ID. It all looks the same. It's just some name changes, okay? But yeah, there you go. See you in the next one. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Active Directory, and this is a cloud-based identity and access management service to manage users, sign-ins, and access to AD-related resources. So Azure Active Directory is Microsoft's cloud-based identity and access management service, which helps your employees sign in and access resources. So that could be external resources like Microsoft Office 365, Azure Portal, SaaS applications, or internal resources. So applications within your internal networking or access to workstations on-premise. And you can use Azure AD to implement single sign-on. So you can see that Azure AD is basically like the one solution to log into everything. And we actually use it at Exam Pro. We use it with Microsoft Teams, or for the Exam Pro platform, our mid panel is tied to it. So when we want to log into the mid panel with credentials, we have it there. We use it with AWS to log into there, and we use it to log into Azure. So it has a lot of flexibility. And if you're building out applications for enterprises, they're likely using AD. And so this is the reason why everybody adopts it or needs to understand it. So it's a service I really, really do want you to understand and know. Azure Active Directory comes in 4 editions. We have the free tier, and by the way, each tier that goes up has the features before it, but free has MFA, SSO, basic security, usage reports, and user management. Then you have the Office 365 apps, which is revolves around if you're using that suite. So you have company branding, SLA, to sync between on-premise and cloud, and then the premium tiers, which really comes into enterprise or on-premise hybrid architecture. So hybrid architectures, advanced group access, conditional access, premium 2, identity protection, and identity governance. Only thing I don't like about Azure AD is that you can't really create your custom access controls unless you have Premium 1 or Premium 2, but that's just how they do it. So there you go. So let's take a look at the use case for Azure AD, and we basically covered it in the introduction, but I just want to reiterate it in a different way with a bit of a visual so that it really helps it sink into your brain there. So Azure AD can authorize and authenticate to multiple sources. So it can authenticate to your on-premise AD, to your web application, allow users to log in with IPDs. So identity providers could be like use Facebook or Google login. You can use it with Office 365 or Azure Microsoft. And so just a visual here, notice that we have Azure AD, and using Azure AD Connect, we can connect to on-premise. Through app registrations, we're able to connect our web application to Azure AD. With external identities, we can use Facebook or Google login. And then for cloud applications, we can connect to Office 365 or Microsoft Azure. So Active Directory existed way before Azure, and so let's just do a quick rundown of the history so we have an idea what we're looking at. So Microsoft introduced Active Directory domain services in Windows 2000 to give organizations the ability to manage multiple on-premise infrastructure components and systems using a single identity per user. So it's been around for 20 years, and Azure AD takes this approach to the next level by providing organizations with an identity as a service, so IDaaS, solution for their apps across cloud and on-premise, and both versions are still used today because they just have different utility. And so we have Active Directory, which is for on-premise, and then you have Azure AD, which is just the cloud-hosted version. And in many regards, these can also be connected together, but there you go. So I want to cover some Active Directory terminology, and the honest truth is that for Azure, you're not going to be too worried about these things, but they're going to come up in the documentation. You're going to kind of wonder what they are. And so I just wanted to tell you about these up front, even though they're not core to study, so that it just really rounds out your Active Directory knowledge. Because Active Directory is such a core service to Azure and Microsoft products, you should know these things. So the first thing is all about domain. So a domain is an area of network organized by a single authentication database. An Active Directory domain is a logical grouping of AD objects on a network. So just think of it a way as, you know how you have resource groups to logically group your Azure resources. Domains are a logical grouping for your AD objects. Then you have a domain controller. A domain controller is a server that authenticates user identities and authorizes their access to resources. Very common to have multiples of these because you want to have redundant domain controllers so you can log in, or availability, or launching domain controller nearby so people can log in different places. So definitely very core to Active Directory. Then you have the domain computer. This is a computer that is registered with a central authentication database. And a domain computer would be an AD object. So then you have AD objects. So this is the basic element of Active Directory. So you have users, groups, printers, computers, shared folders, etc. Then you have a group policy object, a GPO. This is a virtual collection of policy settings. It controls what an AD object has access to. You have your organizational units. This is a subdivision within Active Directory into which you can place users, groups, computers, and other organizational units. So it's just another way of doing logical grouping. Then you have a directory service, and this provides a method for storing directory data and making this data available to network users and administrators. A directory service runs on a domain controller. So there you go. That is the rundown of Active Directory terminology. And again, hopefully when you see it in the documentation, you can refer back to this, or you'll have a better understanding of all the components. I would have loved to have made a diagram, but I just couldn't find an example of one. And so, I mean, I feel like there could be a really good picture for all this stuff. So remember that the domain controller is the server that users are going to be using to authenticate to the directory service. And so when you create an Active Directory, Azure sets one up for you, but there's some cases where you might want to set one up yourself. And the reason why is that you could be like an enterprise where you already have your own Active Directory on premise, but you've decided that you want to move it over to Azure AD because you just want a fully managed Active Directory and you want to tap into the cloud. But the thing is that some domain services, those are features on your domain controller, just might not be available. And that's where you're going to need to set up your own domain controller. And that's where Azure Active Directory domain services come into play, because these provide managed domain services. And so they have managed domain services such as domain joins, group policies, LDAPs, BROS, never can say that properly, NTLM authentication. And so the great thing is here is you can have these domain services, but you're not going to have to deploy them, manage them, patch them. They're just going to work. So there you go. The next topic we'll be covering is single sign-on and Entra ID. Single sign-on and Entra ID is a feature that allows users to authenticate once with Entra ID and then access multiple applications and services without having to authenticate again. When a user signs into Entra ID with their credentials, Entra ID creates a security token that can be used to access other resources within the same organization. This token can be used to authenticate the user to other cloud-based or on-premises applications that have been integrated with Entra ID. SSO supports a wide range of applications, including cloud-based applications such as Microsoft 365, Salesforce, and Dropbox, as well as on-premises applications such as SharePoint and SAP. SSO can also be used with custom-built applications using industry-standard protocols such as SAML, OpenID Connect, and OAuth. There are several ways you can configure an application for SSO. Choosing an SSO method depends on how the application is configured for authentication. Cloud applications can use OpenID Connect, OAuth, SAML, password-based, or linked for SSO. Single sign-on can also be disabled. On-premises applications can use password-based, integrated Windows authentication, header-based, or linked for SSO. The on-premises choices work when applications are configured for application proxy. This flowchart can help you decide which SSO method is best for your situation. The main SSO protocols supported in Azure include OpenID Connect and OAuth. OpenID Connect is an identity layer built on top of OAuth 2.0. It allows for authentication and authorization of users in a secure and standardized manner. It is SAML. SAML is an XML-based protocol used for exchanging authentication and authorization data between an identity provider and a service provider. It is commonly used for federated authentication scenarios. Password-based authentication. This refers to the traditional username password authentication method where users provide their credentials directly to authenticate. Linked authentication. Azure provides the ability to link multiple accounts from different identity providers to a single user identity. This allows users to authenticate using any of their linked accounts. Integrated Windows authentication. It will let users access applications using their Windows domain credentials, utilizing their current Windows session for authentication. Header-based authentication. In this method, the application accepts an authentication token in the form of a header in each request. The token is validated by the application to authenticate the user. You'll need to be familiar with these SSO protocols as there will be questions asking you which SSO protocol is best suited for a specific application. What is multi-factor authentication? A security control where after you fill in your username, email, and password, you have to use a second device such as a phone to confirm that it's you logging in. MFA protects against people who have stolen your password. MFA is an option in most cloud providers and even social media websites such as Facebook. So that's an overview of single sign-on and Entra ID. Let's talk about external identities. So external identities in Azure AD allows people outside your organization to access your apps and resources while letting them sign in and use whatever identity they prefer. So your partners, distributors, suppliers, vendors, or other guests can bring their own identities, such as Google or Facebook. You can share apps with external users. So that's for B2B stuff. If you develop apps intended for Azure AD tenants, for single tenant or multi-tenant, you can do that as well. You can develop white label apps for consumers and customers. So this would be like Azure AD B2C. So there you go. The next topic we'll be going over is conditional access. Conditional access provides an extra layer of security before allowing authenticated users to access data or other assets. Conditional access is implemented via conditional access policies, which are a set of rules that specify the conditions under which sign-ins are evaluated and allowed. For example, you can create a conditional access policy that states, if the user account name is a member of a group for users that are assigned the Exchange, user, password, security, SharePoint, or global administrator roles require MFA before allowing access. This policy enables MFA enforcement based on group membership, simplifying the process compared to configuring MFA for individual users when roles change. Conditional access policy analyzes signals, including user and location, device, application, and real-time risk, and verifies every access attempt via access controls. This requires MFA, block access, and allow access. Signals are metadata associated with an identity attempting to gain access. User or group membership policies target specific users and groups, giving admins fine-grained control over access. Named location information, IP location information, IP address ranges are used to permit or deny access based on geographical locations. Device policies can be applied based on the platform or status of a user's device. Application, users attempting to access specific applications can trigger different conditional access policies. Real-time sign-in risk detection, signals in Azure Ad Identity Protection detect risky sign-ins. If risks emerge, policies can prompt actions such as password resets, multi-factor authentication, or block access pending admin intervention. Cloud apps or actions can include or exclude cloud applications or user actions that will be subject to the policy. User risk. For customers with identity protection, user risk can be evaluated as part of a conditional access policy. User risk represents the probability that a given identity or account is compromised. Common decisions define the access controls that decide what level of access based on signal information. Block access, most restrictive decision. Grant access, least restrictive decision, still require one or more of the following options. Require multi-factor authentication, require device to be marked as compliant, require hybrid Entra ID join device, require approved client app, and require app protection policy. Conditional access policies are available and can be utilized with the following licensing plans: Microsoft 365 Business Premium, Microsoft 365 E3 and E5, Entra ID Premium P1 and Entra ID Premium P2 licenses. Overall, conditional access acts as a robust security measure in Azure, ensuring that authenticated users can only access data under specific conditions. Hey, this is Andrew Brown from Exam Pro, and we are starting our journey for the AZ-900 talking about zero trust methodologies, or the zero trust model in particular. And this is super important because it really lays the foundation of the way we should be thinking about all of the security that we're going to be doing within Azure, and actually in any cloud service providers, because the zero trust model is really what is being adopted today, and we'll talk about why that is. So the zero trust model operates on the principles of trust no one and verify everything. So if you have malicious actors and they're being able to bypass conventional access controls and demonstrate traditional security measures, that's no longer sufficient. We need to come up with a new way to protect ourselves. And so that's where Azure, or Microsoft in particular, has come up with their version of a zero trust model called the Microsoft's zero trust model. And this is based on 3 principles and 6 pillars. So in the 3 principles, we have verify explicitly, least privileged access, assume breach. For our 6 pillars, we have identities, endpoints. An easier way of thinking about endpoints is just think of them as devices, apps, data, infrastructure, and networks. And I would say that if you wanted to put an emphasis on anything, it's going to be identities, which comes down to Azure AD. That seems to be the largest focus here in this entire course, and to really ensuring the zero trust methodology works. The zero trust model is not unique to Microsoft. GCP has its own zero trust model. AWS has its own zero trust model, but the one here is just going to really work for Azure. Okay? Okay, so let's review the 3 principles we said that are in the Microsoft Zero Trust model. The first is verify explicitity. And so this always authenticates and authorizes based on all the available data points. The next one is least privileged access, so limit user access with just in time and just enough access. for risk-based adaptive policies and data protection, assume breach, so minimize blast radius and segment access, verify end-to-end encryption, and use analytics to gain visibility, drive threat detection, and improve defenses. Now, you see me highlighting things in red, and I'm not telling you what they are because we have a whole section on these things. So don't worry if you see a bunch of terms and you're just getting overwhelmed. We're going to cover them multiple times, and so you just understand that we're going to front load you with a lot of terms you don't know, but you will know them by the end of this course, okay? Let's take a look here at defense in depth. And so there are 7 layers of security that Azure wants you to know. It kind of maps up to the shared responsibility model. A lot of times we see these things when organizations or cloud providers are talking about their security centers, like the actual data centers and how they're secured. But this is more general. It doesn't necessarily have to apply to a data center. But let's go and work our way through inside out. Okay, so at the core, we have data. So access to business and customer data encryption to protect our data. Then we have applications. So applications secure and free of security vulnerabilities. Then you have compute, so access to VMs, ports on-premise and cloud. The network, limit communications between resources using segmentation and access controls. The perimeter, so distributed denials of service protection to filter large-scale attacks before they can cause the denial of service for users. Identity and access, so controlling access to infrastructure and change controls. And then you have physical security, so limiting access to a data center to only authorized personnel. So the idea is that if you really want to, if you want to get to data, you got to go through all these steps here. These are all the layers of defense. And so I just want to give extra emphasis to this one here, identity and access, because this one's like besides the physical security, this one's the outermost one. So they will say like your perimeter, like the modern perimeter is defined based on your identity. Okay, and we'll see that more here in this course. Hey, this is Andrew Brown from Exam Pro, and we are taking a look here at Azure Defender. So Azure Defender provides advanced protection for your Azure and on-premise workloads, and Azure Defender can be found in the Azure Security Center. So within the Security Center, there'll be a tab called Azure Defender, and that's the way you find it. So Azure Defender is composed of coverage, security alerts, insights, and advanced protection. So talking about coverage, it allows you to see the resource types that are in your subscription and eligible for protection by Azure Defender. So here, take note that we can see things like virtual machines, Kubernetes services, container registry, app services, SQL VMs, key vaults, SQL servers, and storage accounts. For security alerts, they describe details of the affected resources, such as remediation steps, and in some cases, an option to trigger a logic app in response. So here you can kind of see security alerts over time. Then there are insights. This is a rolling pane of news, suggested reading, and high priority alerts that give security centers insights into pressing security matters that are relevant to you and your subscription. For advanced protection, within Defender are additional security features that is driven by analytics. So VM vulnerability assessments, just-in-time VM access, adaptive application control, container image scanning, adaptive network hardening, SQL vulnerability assessment, file integrity monitoring, network map, IoT security. And so down below, you can see all these options here, whether they're turned on or not. We'll take a look at network map here in a moment. So scope of Azure Defender. So it has a lot of different plans for specific Azure resources. So we have Azure Defender for servers, app service, storage, SQL, Kubernetes, container registry, Key Vault, resource manager, DNS, open source relational databases. And when you turn on Azure Defender, all plans are activated. We saw that under the advanced protection tabs. Then just to kind of highlight network map, because this one's really cool. It's a network map that provides a graphical view with security overlays, giving you recommendations and insights for hardening your network resources. So using the map, you can see the network topology of your Azure workloads, connections between your virtual machines and subnets, and the capabilities to drill down from the map into a specific resources and the recommendations of those resources. Then just the last thing I want to touch on here is hybrid cloud protection. So Azure Defender can protect VMs residing in other cloud service providers such as AWS and GCP via Azure Arc. So Azure Arc, if you've never heard of it, is a control plane that can manage compute resources across cloud service providers on-premise and at the stage or at the edge. And so for infrastructure, you'll notice that it can handle VMs, Kubernetes clusters, SQL servers, and Azure Stack HCIs.
Hey, this is Andrew Brown from Exam Pro, and we are looking at multi-factor authentication. So what is MFA? So MFA is a security control where after you fill in your username, or maybe it's your email, and password into a login portal, so this login portal could be the Azure portal, this could be you logging into Facebook. The idea is that you have to use a second device, such as a phone, to confirm that it's you logging in. And so why do we use MFA? Well, MFA protects against people who have stolen your password, because they might have your password, but they don't have your phone or whatever device that you're using for MFA. So MFA is an option most cloud providers have. And just as I said before, most social media websites have it. So Facebook, Twitter, they all have it. So just to give you a visual example, we have a form where I'm entering my email and password. Then we have a phone, which is our MFA in this case, and then we get authorization. So in the first case, that is one factor, right? So if we didn't have to use a phone or another device, that'd be considered one factor. And then multi-factor or two-factor authentication would be the addition of another device to confirm that it's you. And pretty much what's common is to use your phone and to install an app on your phone. And then what that phone will do is it will give you a random number that expires like every, 10 seconds. You have to enter that in with your username and password, or as the second step. And then you gain access to Azure portal. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Security Center. So Azure Security Center is a unified infrastructure security management system. It strengthens the security posture of your data centers and provides advanced threat protection across your hybrid workloads in the cloud. That sounds really fancy, but let's take a look at what that is. So that's what it is down below. It's a bunch of graphs, and it's going to tell you if you are compliant with particular policies. It'll tell you about your security hygiene, all sorts of security stuff, so you have a good visual about your security within Azure. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at Key Vault. So Azure Key Vault helps you safeguard cryptographic keys and other secrets used by cloud apps and services. And so within Key Vault, it has a bunch of functionality in it. So one thing it can do is manage your secrets. So store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. It also has key management. So it can create and control encryption keys used to encrypt your data. Then we have certificate management, so easily provision, manage, and deploy public and private SSL certificates for use with Azure and internal connected resources. And then it also is a hardware security module, so secrets and keys can be protected either by software or FIPS 142 or 140-2 level 2 validated HSM. And I told you that we would be talking about FIPS again, and we are right now. So to understand HSM, the last thing we're talking about, which stands for a hardware security module, it's a piece of hardware designed to store your encryption keys. And it literally looks like something like that. So Azure would have bought one of these or tons of these, and that is what is storing your cryptographic keys. And this piece of hardware is special because when you store keys on it, they're stored in memory, meaning that they're not written to disk. If that thing shuts down, the keys are gone and nobody can steal your data. It's just a security measure. And that security measure has to do with FIPS. Okay, so FIPS 140-2 is a US and Canadian government standard that specifies the security requirements for cryptographic modules to protect sensitive information. So for HSMs that are multi-tenant, they're generally going to be 140-2 compliant. Multi-tenant meaning that there's more than one customer that is using that piece of hardware, but they're virtually isolated from each other. And then if you have a single tenant HSM, they're generally going to be FIPS 140-3 compliant. So a single customer on a dedicated HSM. It's better to be FIPS 140-3 compliant, but FIPS 140-2 is pretty good for most people. So there you go.
Hey, this is Andrew Brown from Exam Pro, and we're taking a look here at DDoS. So this stands for Distributed Denial of Service Attack, and it's a malicious attempt to disrupt normal traffic by flooding a website with large amounts of fake traffic. So the idea is you have an attacker and a victim, and the attacker is utilizing remote machines and with some software that's going to generate out traffic directed towards your virtual machine over the cloud. And the problem here is that what it's going to do is it's going to make your website unresponsive or just not work at all for the regular user. But by having your compute within the Azure network, you're going to get free DDoS protection, and that's going to mitigate these attacks. So let's talk about the types of DDoS attacks that frequently happen. The first is volumetric attacks. So these are volume-based attacks that flood the network with legitimate-looking traffic. These will exhaust the available bandwidth, and legitimate users cannot access the website. These are measured in bits per second, so BPS. Then there are protocol attacks, and these are exhausting server resources with false protocol requests that exploit weakness. You're looking at UDP and TCP flooding on the layer 3 and 4, measured in packages per second, so PSP. Then you have application layer attacks. These are attacks that occur at the application layer. That's between layer 7. So you're looking at HTTP floods, SQL injection, cross-site scripting, also known as XSS, parameter tampering, Solaris attacks. Here you're going to be wanting using a WAF, a web application firewall, as a means of protection. WAFs are generally paired a lot together with DDoS services across the cloud service provider offerings, okay? So Azure offers 2 tiers of DDoS protection. The first is the basic tier. This is free. It's already turned on. It's part of the global network. And then you have the standard that starts at about 2,900, about 3,000 USD. You get metrics, alerts, reporting, DDoS expert support, application and cost protections SLA. There's probably a difference in terms of the tier protection. I cannot remember off the top of my head, but one will protect more likely against certain types of attacks at like 3 and 4, and the other one will do all the layers 3, 4, and 7. Okay. Azure Firewall is a managed cloud-based network security service that protects Azure VNet's resources, and it's a fully stateful firewall as a service, so you're going to get built-in high availability and unrestricted cloud scalability. And what you can do is essentially create, enforce, and log application network connectivity policies across subscription and virtual networks. So Azure Firewall uses a static public IP address for your VNet resources, allowing outside firewalls to identify originating from your virtual network, and the service is fully integrated with Azure Monitor for logging and analytics. So here is a representation of Azure Firewall, and so the idea is that you're going to launch an Azure Firewall into its own VNet, and then other VNets and your on-premise or other things are going to pass through that central VNet onto wherever they want to go. And the idea is that we're going to be able to do things like utilize Microsoft Threat Intelligence. This is going to block known malicious IPs and FQDNS. That stands for Fully Qualified Domain Names. And by default, the traffic is set to deny, but you can set connectivity policies to filter out traffic in a variety of ways to make sure that you are protected there. So yeah, that's all there is to it. So Azure has a few different kinds of load balancers, and one in particular is the application gateway, and this is for application level routing and load balancing service. So application gateway operates at the OSI layer 7, which is also known as the application layer. And the idea here is that when you're working about applications, you're working with HTTP requests. That's what it is. And so the idea is that it can look at the contents of the HTTP request and do some interesting things. So maybe it's looking at the path and saying, okay, if you have a path and it's payments, go to the VM that has our payment system. And then if it's /admin, go to the VM that does that. Maybe it has to do something with cookies, or maybe you want to apply a WAF policy to it. And so you can look at those HTTP requests and determine if it is malicious traffic and filter it out. Yeah, it's all about the application, which has to do with HTTP requests. To configure this thing, you need to set up a front ends, routing rules, and backend pools. And there are two configurations for the front end. You can either have it with a private IP, which makes it now an internal load balancer, or a public IP, which makes it either we would call a public or external load balancer. And there's a both. I've never used that option before, but I mean, you just really need to know the public and private. For the backends, you create backend pools, and a backend pool is just a collection of resources to which your application gateway sends traffic. And so a backend pool can contain virtual machines, virtual machine scale sets, IP addresses, domain names, app service. And I think you can also send it to like on-prem. So let's just talk about routing rules, which connects the front end and the back end together. And so here is a more complex example, gives you a better idea of the service at full. And so the idea is that you have your application gateway. It's going to send traffic, or sorry, like your DNS is going to send it to application gateway. And then you have these listeners, and they listen for incoming traffic. And then what it will do, it will pass on that to a rule. And a rule just really says, who should we pass the data to? And then if you are defining a backend pool, then you need to have an HTTP setting that says, how do we handle the HTTP requests? Okay, and so now we'll just look at more granular detail about request or routing rules. Let's take a closer look at routing rules. This is where all the magic happens. So a listener listens on a specified port and IP address for traffic that uses a specified protocol. If the listener criteria are met, the application gateway will apply the routing rule. And these come in two flavors. We got basic, which forwards all requests for any domain to backend pools, and multi-site forward requests to different backend pools based on host header and host name. So the thing is that you can have multiple listeners and you can have an order of them. And the idea is that you really want the basic to be on the be last in priority, because if it's a first, it's going to capture everything because that's its job. It's like a catch-all. So just make sure that if you're using multiple listeners, you put basic last. So that's just something you need to know. Then for those backend targets, this is where we either define a backend pool or redirection. Redirection is just an HTTP redirection like 403 or whatever you have there, temporary or permanent. Very simple. But for backend pools, you have to create HTTP settings. And this tells us a little bit more about how we want to handle HTTP. You know, cookies, connection draining, port requests, etc. Let's talk about that a little bit more. So here are the actual options that we can configure for HTTP settings. So you have your backend port. So generally, it's either port 80 or 443. It just depends on where you're doing your SSL termination. But generally, if you need end-to-end encryption, it'll be 443 or and then if you are doing if you're doing SSL termination at the load balancer, then it's 80. Then you have cookie-based affinity. This allows you to keep a user session on the same server. So if you need to persist cookies and use them for authentication, you'll want to enable that. You got connection draining. This gracefully removes backend pool members during planned service updates. So the idea is that, you know, when there is an update, it's not just going to abruptly cut over. It's going to wait until a connection disconnects from a server before no longer sending more requests there, because you don't want a connection dropping in the middle of an update. It's not great for a user. Then you have request timeouts. This is the number of seconds the application gateway will wait to receive a response from the backend pool before it returns a connection timeout error message. And last are, we still have override backend path. These allow you to override the path in the URL, so the request for a specific path can be routed to another path. The idea is, imagine you want to send it to bananas, and you want bananas to actually internally route to oranges. I don't know why you'd want to do that. Or maybe to plantains. That'd make a lot more sense. So that's something you can do. And the last one is the override the host name. So application gateway normally leaves the host name alone. But you know, if you're using multi-tenant services like apps, like App Service or API management, it needs very specific host header set. So this is where you can override them and change them for those services. So hopefully that really gives you a good picture of application gateway, but I feel that that's all you really need to know. So let's take a closer look here at Azure role-based access controls, because this is something we're definitely going to be using a lot. And so role-based access control helps you manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. And the idea is that you have a user and you want to assign them a role, so you're going to use a role assignment. And a role assignment is made up of three elements. You have the security principal, the role definition, and the scope. And we're going to look at those three things in a little bit more detail here in a second. And there are 4 fundamental Azure roles, which we are going to learn. And then Azure RBAC also includes over 70 built-in roles, which we definitely do not need to go into great detail. So let's take a look at one of those 3 elements first, which is the security principal. And this represents the identity requesting access to an Azure resource. And when we say identity, that's just like a loose term for something. And that something could be a user in your Azure Active Directory, a group, which defines a set of users in your Azure Active Directory, a service principal, so a security identity used by applications or services to access specified Azure resources, or a managed identity, an identity in your Azure Active Directory that is automatically managed by Azure. So service principal is basically an Azure service, and then managed identity is something in your Azure Active Directory. Then we'll move on to scope, and a scope is just a set of resources that assess the role assignment applies to. And so scope access controls at the management, subscription, or resource group level. So what does that mean? And we have another slide on this. I can't remember what section it's in, but you have this breakdown of scope where you have management groups, subscriptions, resource groups, or resources. So when you're saying I'm setting a scope, you're saying what is a scope? Is it on a management group? Is it on a particular resource? Is it a resource group? And that's what we're trying to say there. And then the last element there is a role definition, and this is a collection of permissions. So a role definition lists operations that can be performed, such as read, write, and delete. And roles can be high level, like owner specific, or like a virtual machine reader. And so Azure has built-in roles, and we said there were 4 fundamental built-in roles, and here they are. It's owner, contributor, reader, and user administrator. So you want to know those 4. And then across the board, you have those 3 operations: read, grant, and then create, update, delete. So you can see the owner can do everything. The contributor can both read and create stuff, but they just can't grant access to other people. The reader just has read-only access. And then a user access administrator is granting other users privileges, but themselves are not creating anything. All right?
Hey, this is Andrew Brown from Exam Pro, and let's look at Azure Management Groups. So Azure Management Groups is a way of managing multiple subscriptions. And when you hear the word subscriptions in Azure, just think accounts, because that's an easier way to think about it, into a hierarchical structure. So each directory is given a single top-level management group called the root management group. All subscriptions within a management group automatically inherit the conditions applied to the management group. And so this is a graphical representation. So at the top, you have your root management group, and then you can create management groups underneath. So human resources, IT, marketing, production, developers, whatever you want. And underneath, you have those individual subscriptions. Again, just think of them like an account. So that is Azure Management Groups. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Service Health. So this is about information about current and upcoming issues such as service impacting events, planned maintenance, and other changes that may affect your availability. So going down the list, we have Azure Status, which informs you of service outages in Azure. Azure Service Health is a personalized view of the health of the Azure service and regions you're using. And then Azure Resource Health is information about the health of the individual cloud resources, such as your VM. So if you're ever wondering the state of your health, you can use Azure Service Health. And if you noticed, it was an option under Azure Monitor. So if you're looking for it, that's where you go to find it. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Advisor. So Azure Advisor is a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. The Advisor dashboard displays personalized recommendations for all your subscriptions for the following 5 categories: high availability, security, performance, cost, and operational excellence. And since we are in the security category, that's what we mostly care about is security, but it would also be important for the pricing section there as well. So the first one we're going to look at is actually the Azure Advisor recommendation for costs. So here you can see that it's telling you where the most impact can occur, and it'll even tell you how much money you can save if you follow its recommendations. Then you have security, and so here it has 21 recommendations. If we were to click into it, it would tell you what kind of things that you could improve in your system to improve your security. So there you go. That's Azure Advisor. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Database Services. Starting at the top of our list is Azure Cosmos DB. This is a fully managed NoSQL database. It's designed for scale with guarantee of 99.999% availability. Azure loves talking about this database. It's their flagship database because it works at incredible scale and an incredible performance. So whenever you're thinking about like super large databases, think of Azure Cosmos DB. Next on our list is Azure SQL Database, and even though it doesn't have it in its name, this is for the MS SQL engine. So if you're running Microsoft SQL, you're going to want to use this. It's fully managed with autoscale, integral intelligence, robust security. So there's a lot of great features built around this for MS SQL databases. Now, if you're not using MS SQL and you're using something like MySQL, Postgres, or MariaDB, they have Azure Database. So it's fully managed and scalable with high availability and security. Then you have SQL Server on VMs. Again, it doesn't have it in its name, but it's Microsoft SQL Engine. Okay, anytime it says SQL Servers, just assume that it's the Microsoft flavor of SQL. And the idea for this one is that if you already have SQL servers running on premise within your data center and you want to move them onto Azure, this is where you'd use a lift and shift. So it takes those virtual machines and directly moves them onto the cloud. You don't get all the functionality that you would with Azure SQL database, but it's the easiest way to get onto the cloud. Then you have Azure Synapse Analytics, previously known as Azure SQL Data Warehouse. It's because they added an analytics component to it, but it's a fully managed data warehouse with integral security at every level of scale at no extra cost. Then you have Azure Database Migration Service, so migrate your databases to the cloud with no application code changes. So there's that service. Then you have Azure Cache for Redis. So if you need an in-memory cache that is using the open source Redis, you can use that. And last on our list is Azure Table Storage. We mentioned this in the storage services, but to me, this is a database. It's not a storage service, even though it's named as such. So wide column NoSQL database, a NoSQL store that hosts unstructured data independent of any schema. So there you go. That's the Azure Database Services. Hey, this is Andrew Brown from Exam Pro, and we are looking at application integration services on Azure. Now, I didn't have room on the slide for this, but just to tell you what application integration is, these are services that are designed to help apps or services talk to each other. So it's basically the glue of services. The first on our list here is Azure Notifications Hub. This is using publisher subscription technology underneath, and this is for sending push notifications to any platform from any back end. Next, we have Azure API Apps. So this is essentially an API gateway, so you can quickly build and consume APIs in the cloud, and then those APIs will have API endpoints, and you can route them to Azure services or maybe functions or containers, but it's a way of building an API in the cloud. Then you have Azure Service Bus, and as the name implies, it is a service bus. So reliable cloud messaging as a service, MaaS, and simple hybrid integration. I know that's not very clear. That is the language that Microsoft uses to describe it, but just what you need to know is that it is a service bus. Then you have Azure Stream Analytics. So this is serverless real-time analytics. Remember that word real-time and think of this service from the cloud to the edge. Then you have Azure Logic Apps. So you can schedule, automate, orchestrate tasks, business processes, and workflows, and it integrates with enterprise SaaS and enterprise applications. Then you have Azure API Management. This can be confusing because we have another service called Azure API Apps. I don't know what we would generally call this service. They say it's a hybrid multi-cloud management platform for APIs across all environments, whatever that means. But when I looked at it, what it does is you can put this in front of an existing API to add additional functionality. So if you have an API, you put it in front of it, and it's basically a proxy to your API, and then you get all this additional stuff. Then last on our list is Azure Queue Storage. We saw this in our storage service sections, and I had said that I don't really consider this a storage service. I consider it an application integration service. And this is a messaging queue. So it's a data store for queuing and reliably delivering messages between applications. So there you go. That is the application integration services on Azure. Hey, this is Andrew Brown from Exam Pro, and we are looking at developer and mobile tools that are commonly used with Azure. So the first on the list is Azure Signal R service, and this is a real-time messaging service, not to be confused with Azure's notification service. This is for easily adding real-time web functionality to applications. So if you ever heard of Pusher, it's just like Pusher. So that is the equivalent there. The next we have is Azure App Service. So easy to use service for deploying and scaling web applications with .NET, Node.js, Java, Python, and PHP. I'm a bit sad I don't see Ruby in there, but what are you going to do? So it's for developers who want to focus on building their web apps and not worry about the underlying infrastructure. So if you've ever used Heroku, think of it like that, but for Azure. Next, you have Visual Studio, and Visual Studio is a code editor. It's basically an IDE, an integrated development environment designed for creating powerful, scalable applications for Azure. You might have heard of Visual Studio Code, which is similar but different. But I just wanted to make mention of Visual Studio here. Then you have Xamarin, I think I'm pronouncing it right, and it's a mobile app framework. It's for creating powerful and scalable native mobile apps in .NET and Azure. And yeah, so that is the developer and mobile tools for Azure. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure DevOps services. So Azure DevOps is really just an umbrella service for a bunch of modern dev services, and we'll jump into them right away. First being Azure Boards. If you've ever used a Kanban board, that is what Azure Boards is. And if you've ever used GitHub Projects, it literally is that, because Azure and GitHub are owned by the same company, Microsoft, and so they brought over that technology to Azure. So deliver value to your users faster using proven agile tools to plan, track, and discuss work across your teams. Then you have Azure Pipelines, so build, test, and deploy CI/CD that works with any language, platform, and cloud. Connect to GitHub or any other Git provider and deploy continuously. So if you need automatic deployments, that's what Azure Pipelines is for. Then you have Azure Repos, and this is exactly like GitHub Repos. So get unlimited cloud-hosted private Git repos and collaborate to build better code with pull requests and advanced file management. And I really mean it's just like GitHub Repos, because it's just that technology moved over to Azure. Then you have Azure Test Plans, so test and ship with confidence using manual and exploratory testing tools. So this is just a way of setting up tests. So if you ever use what's it called, Cypress or any other testing tools, it's just built into Azure. It'll open up a browser and it'll literally test your application and make sure it works as expected. Then you have Azure Artifacts, so create, host, and share packages with your team. So this is just package management, but specifically for CI/CD pipelines. So CI/CD pipelines, they have to set up these servers, and you have to have pre-installed packages. That's just going to make it a lot easier for you. Last is Azure Dev Test Labs. So this is just an easy way to create dev test environments for your developers, and that is the Azure DevOps services. Hey, this is Andrew Brown from Exam Pro, and we're looking at the cloud native networking services. Now, these networking services aren't super important for the exam, but I like to go through them. Generally, I would make an architectural diagram for this, but it's just a bit too complicated, so I thought we'll just go through and list them. So first is Azure DNS, and we do describe this service later in the course here, but this provides an ultra-fast DNS responses and ultra-high domain availability. So if you have a domain name and you just want it to be managed by Azure, you can associate it with Azure DNS. Then you have Azure Virtual Network. We talked about this prior, but we'll talk about it again. Short for VNet, a logical isolated section of your Azure network for customers to launch Azure resources within. Then you have Azure Load Balancer, and as the name implies, it is a load balancer, but this one is at level 4 transport. So it doesn't really understand requests like what a web application would send. It's more lower level. And so that's what that is. Then you have Azure Application Gateway, and this is an HTTP load balancer, so it does understand like requests coming from a web server. And what you can do with it is you can actually route based on HTTP requests to specific services, but it also, you can apply a web application firewall because it is an application Load balancer, that's why you can apply that web application firewall, which is a separate service. Then you have network security groups. So this is a way of protecting your subnets. So it's a virtual firewall around your subnets where you can say, allow these ports to be open, and from who and such. So there you go. That's the cloud native networking services. And the reason why they're cloud native networking is because you wouldn't use these with enterprise or or in hybrid models. It's just what you normally use. And most startups would be using all these these networking services. So next we have enterprise or hybrid networking services. So this is when you're using networking that is going to bridge on-prem to the cloud. So the first is Azure Front Door. So this is a scalable and secure entry point for fast delivery of your global applications. So it's just making sure you have a secure entry point into Azure from outside. Then you have Azure Express Route. You want to remember this one definitely for the exam. It probably will show up as a question. This is a connection between your on-premise to Azure cloud, and it can be between 50 megabytes per second to 10 gigabytes per second. I'm pretty sure it's also secure. But the point is that if you need a super fast connection from your on-prem data center to Azure, you'd use this service, Express Route. Remember it. It's going to be on your exam. Then you have virtual WAN, so a network service that brings many networking security routing functionality together to provide a single operational interface. I know that sounds complicated, but a WAN is just a way of making networking easier by creating like a hub-spoke model. Then you have Azure Connection. So a VPN connection securely connects to Azure local networks via IPsec. So that's just a way of creating a secure connection with Azure. Then you have Virtual Network Gateway, a site-to-site VPN connection between Azure Virtual Network and your local network. So this is just a way of connecting with Azure. So there you go. That is the networking services. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Traffic Manager. So this service operates at the DNS layer to quickly and efficiently direct incoming DNS requests based on the routing method of your choice. So what you do is you'd choose a routing method. So we got performance weighted priority, geographic, multi-value subnet, and you'd be able to reroute your traffic. So you could route traffic to servers geographically nearby to reduce latency, fail over to redundant systems in case primary systems become unhealthy, or route to random virtual machines to simulate A/B testings. I think like the best use case is failovers at the DNS level. I think that's a great one. And just a visual example here, imagine we had exampro.co and we had a production server and a beta server, and we only wanted 20% of our users to see the beta server. So we could use, I guess we'd use weighted there, and we'd say 80% on prod, 20% there, and that's how that would work. So there you go. That's Azure Traffic Manager. Hey, this is Andrew Brown from Exam Pro, and we are looking at IoT services on Azure. And so before we get into it, what is IoT? So IoT stands for Internet of Things. So a network of internet-connected objects, usually hardware, able to connect and exchange data. So here is a graphical representation of IoT devices. Maybe you recognize some, but let's just go through a quick list of things that could be IoT devices. So you have smart bulbs. So maybe there's light bulbs in your house that are controlled by the internet. Smart fridges, who doesn't want one of those? Smart light switches, narrowband or wideband hardware. This is just a way of connecting to the internet. It's just like, it's kind of like Wi-Fi. Then you have security cameras. Then you have voice command speakers. So think of like Alexa. Then you might have temperature, pressure, or humidity sensors. If you're in the farming industry, you can leverage IoT devices for that. Maybe you have drones. Maybe you have phones, that could be an IoT device, and even buttons. So AWS had these things called AWS or dash buttons. They weren't popular, but the idea was you could like press a button and like purchase something. So like if you always had to get like soap for your washer, you could have that button right on your washer. But let's actually talk about the IoT services here. So the first one here is IoT Central. So this allows you to connect your IoT devices to the cloud. Then you have IoT Hub. So this enables highly secure and reliable communications between your IoT applications and devices it manages. Then you have IoT Edge. This is a fully managed service built on the Azure IoT Hub. It allows data processing and analysts near the IoT devices. So this is really edge computing. I really should have highlighted that for you, but this is where you are able to offload your compute from the cloud to local computing hardware such as IoT devices, phones, or home computers. So it's just a way of saving money or utilizing your local network for compute. Then you have Windows 10 IoT Core Services. So this is a cloud services subscription that provides the essential services needed to commercialize a device on Windows IoT or 10 IoT Core. So basically it's long-term OS support and services to manage device updates and assess device health. All right, so there you go. That's your IoT services. Hey, this is Andrew Brown from Exam Pro, and we are looking at big data and analytics services on Azure. So before we jump into it, let's talk about what is big data. So it is a term used to describe massive volumes of structured and unstructured data that is so large it is difficult to move and process using traditional database and software techniques. So we need special services just to handle them. The first on our list here is Azure Synapse Analytics, formerly known as SQL Data Warehouse. So it is enterprise data warehousing and big data analytics. So it's intended to run SQL queries against large databases to generate things such as reporting. Then you have HD Insight. HD is short for Hadoop. But anyway, it runs open source analytics software such as Hadoop, Kafka, and Spark. I imagine it was called HD Insight because it only supported Hadoop and then they added additional services, but that's just what it's called. Then you have Azure Databricks. So we have an Apache Spark-based analytics platform optimized for Microsoft Azure cloud service platforms. So third-party Databricks cloud services supported with Azure. So Databricks was made by the creators of Spark. And yes, of course, you can run Spark on HD Insight, but Databricks is its own cloud service provider, and Azure partnered up with them so that you can use it within the Azure platform. Then you have Data Lake Analytics, so an on-demand analytics job service that simplifies big data. And we saw what data lakes were when we looked at storage services, but we'll describe them here just in a little bit different way. A data lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So there you go. That is the big data and analytics services we need to know. Hey, this is Andrew Brown from Exam Pro, and we are looking at artificial intelligence and machine learning services on Azure. So a great way of describing that is to always have this graphic here where we have this kind of like onion thing where each is dependent on the other. And we'll start with artificial intelligence. So what is artificial intelligence or AI? This is where machines that perform jobs that mimic human behavior. Now, that doesn't mean that the technology behind it has to be complex. It could be if-else statements, but it could be utilizing machine learning. It could be utilizing deep learning. But the point is that it mimics human behavior. Then you have machine learning, and this is where machines that get better at a task without explicit programming. So they are smart enough to learn on their own. Then you have deep learning, and so deep learning is where machines that have an artificial neural network inspired by the human brain to solve complex problems. So literally, it's like the power of the human brain. Maybe not as great as the human brain, but quite close there. And AI could be leveraging ML and deep learning, and so that's why it is like that. So when we want to do machine learning on Azure, they have a service called Azure Machine Learning Service. So this is a service that simplifies running AI, ML-related workloads, allowing you to build flexible pipelines to automate workflows. So you can use Python and R. You can run your deep learning workloads using technologies such as TensorFlow. And so that's what you'd use. Now, there was a service called Azure Machine Learning Studio. I think it's still around if you're still using it. And that's the classic version of the service. And it does basically what Azure Machine Learning Service does, but there's some limitations. So it does not have pipeline and other functionalities. And if you're wondering if you could easily migrate from Classic to the other one, it's not easy to migrate. So basically, you definitely always want to start with Azure Machine Learning Service. There's no reason you'd want to use Azure Machine Learning Studio unless you're using it for legacy reasons. Hey, this is Andrew Brown from Exam Pro, and we're still looking at AI and ML services, specifically just AI services because Azure has a lot of them, and I'm just going to quickly go through them, and they're pretty self-explanatory. So the first one is Personalizer. It delivers rich, personalized experiences for every user using AI. Then you have Translator. It adds real-time multi-language text translation to your apps, websites, and tools. You have Anomaly Detector, detects anomalies in data to quickly identify and troubleshoot issues. Azure Bot Service, intelligent serverless bot service that scales on demand. Form Recognizer, automate the extraction of text, key value pairs, and tables from your documents. You have Computer Vision, easily customize computer vision models for unique use cases. Language Understanding, so build a natural language understanding into apps, bots, and IoT devices. We have Q&A Maker, so create a conversational question and answer bot from your existing content. Text Analytics, extract information such as sentiment, key phrases, named entities, and languages from your text. Content Moderator, so moderate text and images to provide a safer, more positive user experience. Face, so detect and identify people and emotions in images. Ink Recognizer, recognize digital ink content and such as handwriting, shapes, and document layouts. So there you go. They have a lot of services, and they haven't even made time to make all icons for them. That's how many they have. Hey, this is Andrew Brown from Exam Pro, and we are looking at serverless services on Azure. So what is serverless? This is when the underlying server's infrastructure and OS is taken care of by the cloud service provider. It will generally be highly available, scalable, and cost-effective. So serverless is event-driven at scale. So a serverless function can be triggered or trigger other events, allowing you to compose complex application and just scale. So with serverless technology, it's like playing with Lego blocks. Then you have abstraction of servers. So servers are abstracted away. Your code is described as functions. These functions can be running on different compute instances. So if some people like to use Python or some people like to use JavaScript, you can mix and match there. Then you have micro billing. So when you have traditional servers, you'd probably be billed by at least a second. Some bill by the hour. But the thing is, if you're not using the server for the whole second or hour, you are paying for compute that you are not using. So serverless functions will bill you in the microseconds, so you're saving money because you're not paying for unused computation. Now we'll just quickly walk through some of the serverless services. I'm sure there's more than this, but this is what I think are worth highlighting. So the first is Azure Functions. So run small amounts of code known as serverless functions in your favorite languages. So you got C#, Java, JavaScript, Python, and PowerShell. And if Azure is listening, please can you support Ruby, because I love using Ruby. Then you have blob storage. So this is serverless object storage. Just upload your files. Don't think about the underlying file systems resizing, basically unlimited space, and you can upload pretty darn large files. Then you have Logic Apps. It allows you to build serverless workflows composed of Azure functions, building I would say this is you building a state machine for serverless compute. Then you have Event Bridge, which seems a bit similar, but it's not. It uses pub/sub messaging systems to allow you to react to events and trigger other Azure cloud services such as Azure Functions. So there you go. That is serverless services. Hey, this is Andrew Brown from Exam Pro, and I'm going to show you how to create resource groups. And the reason why we're going to make one is because without one, we're not going to be able to launch pretty much any resource until we do so, because you always have to choose a resource group when launching Azure resources. So even though it shows up here on our dashboard, if it doesn't, I want you to go up here at the top and type in resource group. And we'll go ahead and click resource group here. And then all the way on the left-hand side, I want you to click on add. And we're just going to have to use our free trial, which is our type of subscription. I'm just going to type in Exam Pro as the resource group. We're going to stay in US East because that is where the most of the services are available in Azure, and that's what I'm going to be using throughout this course, is always using US East. So we'll go down here and hit Create plus Review plus Create, because there's really nothing else to check. And once validation passed, this might happen instantaneously for you. You might have to wait a few seconds. Go ahead and hit Create. And so now we have created our resource group. And there is no cost to resource groups, so there's no worry about having this or whether you keep it around and don't delete it. You're going to notice that the group hasn't showed up just yet. You're going to have to hit refresh. And sometimes Azure is a bit slow about showing resources when you create them initially and when you delete them. So I'm just going to wait a little bit here, and I'm just going to keep on refreshing, and I'll see you back in a few minutes. All right, so I waited a couple of minutes, and if you just go ahead up here and hit refresh, now we can see that we have our resource group. So that's all there really is to it. Nothing super exciting there. I'm just going to click Microsoft Azure at the top here to get back to my dashboard, and I'll see you in the next follow along. Okay, great. So now that we've done that, let's actually go learn how to do a different kind of compute, which is serverless functions. So if we want to launch our own serverless function, by the way, if you're not at the screen, just click on Microsoft Azure here at the top, and we're going to go to our search, and we're going to type in functions. And so on the left-hand side, I want you to click on Add. And then what we're doing is we need to create a function app. So we're going to be on our free trial. We're going to choose our resource group we created earlier. We're going to name this. I'm going to just call this, this is the function app name. So I'm going to just say my app. My app is not available. These are all unique names. I'm just call it Exam Pro app. You might have to change this a few times before you get what you want. And then for publish, we're going to use code. We don't want to use a Docker container. That's too much work. And we're going to just choose Node.js, which is just JavaScript. Version 12 sounds great to me. We're going to change this to make it sure that it's US East to make our lives a little bit easier. There's nothing wrong with Central. It's just I want everything to be consistent, so everything's very predictable in these follow-alongs here. We'll go all the way to the top and look at hosting just quickly here. We're going to see that we have a storage account. Okay, nothing exciting here. It's going to either be Linux or Windows. This doesn't really matter to us. We can let it be Windows. We're going to go back to basic. I'm going to go ahead and hit review plus create. So we're going to wait for this validation step to complete here. So again, it could take a second or it could take a minute. It just depends on the day with Azure. So we'll just wait here a little bit. There we go. It's just finished validating. I'm going to go ahead and hit create. And now we're waiting for that initial deployment. So we're going to see that deployment is on its way. And then we're going to have to wait for deployment to be complete. So it's in progress, it's underway. This shouldn't take too long. It should say that it's complete here in a moment. Great, so after waiting a few minutes here, our deployment is complete. We'll go ahead and hit go to resources. So now what we need to do is we need to go create ourselves a function. So on the left-hand side, make your way to functions. And then in here, we're going to add ourselves a new function. And so we have a lot of presets here for us. It's not going to matter what we choose. Well, it does. And I'm going to say, let's choose HTTP trigger. We're going to leave it with the default name. That's fine. We'll have it stay as function for authorization level. We'll go ahead and create that function. So once that function has been created here and it's already done, let's start adding our code, because again, the whole point of serverless is that you don't have to worry about servers. You just add your code and it works. And so here's some code it already has for us. What I'm going to do is I'm just going to add myself a console log. Console log is just like saying hello world. So we're going to say hello world. And then I'm going to hit save. And now it's just connecting to application insights. I don't know if it's actually running it. Yeah, it's connected. Great. And now let's go ahead and hit test. And so we have a bunch of options here. I'm not going to fill in anything. I'm just going to hit run. And we're going to see what the output is. Okay, great. So, I'm just looking at how this actually works. And I think what we need to do is we need to actually pass a name into the query string here. So what we'll do is we're just going to go ahead and type in query here, and we'll put a name, and we'll say Andrew. And so that should do it. So let's just hit run. Okay, great. And so it's saying, hello, Andrew. So there you go. That's all you have to do to create a serverless function. And it doesn't cost us anything to keep this around, so we don't necessarily have to delete it. If you did want to go delete it, I guess we could go back here. We'd have to go back to functions here. And I would just click delete. And we'll type in yes. And we'll hit delete. And there you go. So that's all there is there to it for serverless compute. I can go back to Microsoft Azure here, back to the dashboard, and we'll see you in the next follow along. Hey, this is Andrew Brown from Exam Pro, and we are looking at SLAs for Azure. So SLA stands for Service Level Agreement, and this describes Azure's commitment for uptime and connectivity. That means, like, if you have a web server, Azure's going to say, we guarantee 99.9% of the time it's going to remain running throughout the year. It's not going to go down. So that's kind of the idea behind an SLA. For Azure, SLAs are individualized per Azure service, so they don't have broad SLAs. You're going to have to investigate each service to figure out what the commitment of Azure is for that service. And the way we describe these SLAs in terms of uptime and connectivity is through performance targets. Now, a performance target is just a representation in the form of a percentage. So if somebody were to say to you, this service is 99% likely of not failing, that's called 2 nines. And then you have the 3 nines, and then you have 5 nines, and then you have 9 nines. And the higher this number goes up, the more reliable, the better coverage this SLA is going to give you. So you want something that has a higher number of nines. And it's not always just nines. It could be 99.95%. But just understand that when someone says 9 nines, they're talking about that last value there, and it is like one of the highest guarantees an SLA can give. I can't remember if there's like 11 nines. There might be 11 nines, but generally 9 nines is the upper limit. And just to mention is that for Azure, if you are using the free tier or shared tiers, you do not get SLA because they just do not provide support for those because you're consuming everything for free. So you have to be paying to get the advantage of that SLA guarantee. So I did say that the SLAs are service specific. And so if you want to actually go investigate, all you got to do is type in Azure SLA into Google, and you should be able to make your way to this page. And what we can do is we can click into any of these here. So if I go to database and we choose Cosmos DB, and we just expand our information here, we get tons of information about their SLAs. And then our performance targets are down here. So we have this for availability. This is for read availability. So they have a lot of information. As I said, it's for basically any service, anything you want, just click into it. And they have all that SLA information. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at service credits for Azure. So a service credit is when a customer would get a discount on their Azure bill as compensation for an underperforming Azure product or service based on the SLA. So those guarantees that Azure gives, if they don't meet those guarantees, then they owe you money. And the way they do it is through credits, right? So credits is just like virtual money. I actually don't know what a service credit is worth, but I just know that if they do not meet those SLAs, they're going to back it and give you your money back in some sense. So just an example here: if we have Azure Virtual Machine, remember a virtual machine is a server. If you had a monthly uptime percentage of 99.9, so if it was under that, then you'd get a service credit of 10%. If it was under 99, then you get a service credit of 25%. And if it was under 95, you get a service credit of 100%. So I guess what that means is maybe it's the cost of what you spent. But anyway, I'm not exactly sure. But I would take a guess that if let's say the uptime was under 95% and they're going to give you a service credit of 100%, maybe it's 100% of your resources given back to you. So if you spend $100, you get that $100 back. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at composite SLAs. So we had said earlier that different services have different SLAs. And the problem with that is that when you have different services, different SLAs, it's kind of hard to understand what the actual guarantee is when you use them in combination. So composite SLAs is just a way of understanding what the actual SLA guarantee underneath is for the performance target. So imagine you have a web application, and that web application uses an SQL database. So the web app has a guarantee of 99.95% because maybe that's the performance target for the virtual machine, and then the SQL database is 99.99%. So what is it? Is it 99.95% or is it 4 nines? We don't know. So if we had to calculate calculate that for the SLA with the web app and SQL database, that would come out to 99.94%. Don't ask me on the math. That is the example that we are given, but just understand that that's what it would come out to. It would come out to 99.94%. And so you'd have an overall reduction of the SLA, whereas the SQL database would have 99.9%. So how could we improve our SLA and consider that in our design so we get the SLA that we want? And so what you can do is you can add in fallback systems that will improve the overall SLA. And if you logically think about it, it makes sense why that would work. So imagine you have that SQL database and it goes down, but if you had a queue, and that queue was saving all the transaction attempts that the web app was trying to write to the database and saved in the queue, it wouldn't matter if the database went down, because once the database went back up, all those transactions would be there, and then those transactions would then complete. And so by using the queue, which has a 99.9% uptime, based on the math down below, again, don't ask me how the math works, but the outcome would be an SLA of 99.95%. And so that's an improvement over 99.94%. So that is composite SLAs, and there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the TCO calculator for Azure. So if you remember earlier in the course, we talked about the total cost of ownership. That's what TCO stands for. It's about showing an enterprise that operates on-premise how much money they would save if they moved onto cloud, onto Azure. So that's what the TCO calculator does. It estimates the cost savings you can realize by migrating your workloads to Azure. So what it can do is it can generate out a detailed report and export as a PDF to send to your decision makers. Now you have to input all the information in, but it's going to help you convince your boss, convince the executive level that it's time to move over to the cloud, because they'll be saving tons and tons of money. And so if you want to use that calculator, you just got to go to azure.microsoft.com/pricing/calculator, and it's going to give you an idea of how much you'll save. And now this is only a little bit of what it generates out, because it's a very detailed report. But in this example, it would compare on-premise to the cost savings of Azure. And in this case, this person would be saving $130,000 over 5 years. And it's going to vary on use case. But yeah, that is the TCO calculator. So I just wanted to quickly show you the TCO calculator in action. If you want to find it yourself, just type in Azure TCO calculator into Google, and you should be able to find your way here. So what I've done here is I've defined my workload. So in my workflow, I've defined some servers. So we have some Linux servers. We have 10 of them, 4 processes, 4 cores, 8 gigabytes of RAM. And then here I've added 4 servers that are databases running Postgres. Then I added some HDD drives. So I said 3 terabytes, 2 terabytes backup, etc. And then I defined some network bandwidth. So going on to the next step, we're going to adjust our assumptions. This helps us to make it even more accurate, the estimate. So we can choose our currency, some other additional features we might want to consider where we might save money, like using Azure Hybrid Benefit. And then down below, we can tweak some of our costs that we do know about for our on-prem. So there's a lot here to tweak it to make it more accurate. And then if we go to next, we're going to get our savings here. So just wait a moment. And so over a 5-year period, we should save $666.158. And you can drop it down if you want to do 1 year. We'll go to 1 year. So here it says $381. And we have a lot of graphics here, as you can see. And then down below, you should be able to download it. So you can just go ahead and download the results there. And that is the TCO calculator. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Marketplace. So the Azure Marketplace is a place where there are apps and services made available to you by third-party publishers to quickly get started on Azure. And so the apps available, the apps and services that can be available could be free, they could be free trial, they could be pay-as-you-go, or they could be bring your own license. So just an example of what that looks like, if you were logged into the Azure portal and you searched for Marketplace, what you could do here is you could type in a variety of things. So like here I'm typing in WordPress, and here I have a bunch of WordPresses that are provided by third-party publishers that have been vetted by Azure. And again, they could cost money, they could have a free trial, they could be 100% free, but whatever you need, it's generally in the marketplace, and it's a great place to go check out. So just be aware of that. So I just wanted to quickly show you the Azure Marketplace. So you'd have to have an account to actually see it, but we do show you that in this course. But anyway, I'm just going to go up here to the top and type in Marketplace. And this will pull up the Marketplace. And here you can see we have a huge amount of categories of things that we can launch. So whatever we need, and I think I showed before WordPress, but we'll type that in there. So we'll enter in WordPress. And there's all these servers, so you can click into there. It might have plans associated with it if there's any price, but you just go ahead and hit create, and then that would start the process of creating a virtual machine, and you'd go through that and you'd subscribe to whatever the underlying cost would be. But you can see there's just tons of stuff in here. So, and you can sort by price, you can sort by operating system. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Hybrid Benefit. So many customers have invested already in Windows Server's licenses, and they want to repurpose their investment on Azure. This happens because enterprises have been working with Microsoft servers even before Azure existed, or they were on-premise originally, and so they wanted to use the software, so they purchased the licenses, but now they're ready to move on to Azure. And so since they've already got a special deal with Microsoft because they purchased those licenses, they want to keep those deals and bring them to the cloud. So that's where the Azure Hybrid Benefit comes into play, also abbreviated as HUB. Sometimes it's called Azure Hybrid Use Benefit in Microsoft documentation, but for some reason Azure, they just dropped the word use, but the abbreviation is HUB. So this gives customers the right to use these licenses for virtual machines on Azure. And so such types of virtual machines would be Windows servers or SQL servers. And I would imagine this would probably happen with a lift and shift, which I think we described somewhere in this course. So HUB can be turned on and off at any time for existing virtual machines, and HUB can be applied at deployment time for new VMs. And I just wrote bring your own license down here just because we are talking about licensing, and I just want to get you more exposure to that term, bring your own license, BYOL. And so that just means that someone's purchased a license and they want to apply it, they want to bring it onto Azure. So there you go, that is Azure Hybrid Benefit. So I just wanted to quickly show you this page here, which is the Azure Hybrid Benefit page. If you were to type into Google Azure Hybrid Benefit, you definitely make your way here. What I wanted to show you is that they actually have this nice little calculator down below. So if you do have licenses and you're bringing them over and you want to run workloads on Azure, you can fill this stuff out and it'll give you an idea of what you might save. So I just wanted to make you aware of that. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure subscription. So an Azure subscription, I would describe as the equivalent of saying my Azure account. I don't know why they use the term subscription because to me it's just confusing, but I always just try to reinforce that it's just your account. And there are 4 tiers of Azure subscriptions. The first is the free subscription. So when you first sign up, this is the account that or subscription you're going to have. You have to provide a credit card to complete the process. You're going to get 200 USD credits free for 30 days, and certain Azure products will be free for 12 months. Now, the whole point of this free subscription is to help you avoid charges, and there are some limitations. I remember when I was trying to add another user, I couldn't grant them access, so there was definitely some limitations here to prevent you from being charged. But it's not a complete sandbox, so it is possible to get charged in this account if you start using things outside the free tier, or if you burn through your credits. So just be careful there. And then once you are ready to switch or to upgrade and unlock everything, then you can switch to pay-as-you-go subscription, also abbreviated to PAYG. Some people might call that on demand. And so for this, you still need a credit card required, but since you've already entered it in the free subscription stage, no problem here. And you're going to be charged at the end of the month based on consumed cloud resources. Then you have an enterprise agreement. So if you are an enterprise, you can make a deal with Azure and agree to receive a discounted price for licenses and cloud service, but I bet you're paying a lot of money. Like compared to a normal person, but the deal is worth it for you. So just be aware, if you're an enterprise, go talk to Azure. They want to make a deal. And the last is the student subscription. So with the student subscription, you do not require a credit card. You get $100 USD credits for 12 months, but it requires a valid student email. So there is a little bit of a vetting process there. So you definitely have to be in school to get that, but it is a very nice option to have. So there you go. That is the Azure subscription models.
All right, so what I want to do in this video is show you how to keep track of your spend within your Azure account. So I just created a fresh new account. This one's Exam Pro at Andrew Brown at Outlook.com. This is not my primary one, so you'll see some videos where I'm doing labs in this one and other ones in my primary account. So just be aware that there might be some discrepancies between the videos. But anyway, where we're going to keep track of our spend is within subscriptions. So up here in the top, if we type in subscriptions, okay, we can see subscriptions that are attached to this tenant. So understand that there is a relationship between tenants and subscriptions and your directory. And subscriptions is how you pay Azure. And you can create multiple subscriptions, and there's good reason for that. But the point is that you start with a default subscription. So here I have the Azure subscription 1. Notice there is no current cost because I've yet to launch any services in here. But we'll go ahead and click into here, and eventually something should appear here. Yep. So it says your remaining $200 of free credits expire in 30 days. So the idea is that we have $200, or we have 30 days to utilize this free account here. So I'm going to go ahead and just click into this upgrade. I'm not upgrading right now. I just want to show you what it looks like. So in here, we have some options. You can rename your subscription if you want. I think for even my primary account, I just left it as Azure Subscription 1. The name doesn't really matter. It's just for your reference. But we do have some options. And this is for additional support if you want to have technical support from Azure. When you upgrade, you can just stick with basic because, of course, we don't need to pay an additional fee on top of what we're doing here because we have these instructional videos to learn. But that's how you're going to go ahead and upgrade later. When we do have some spend, we'll come back and revisit it here. But we do have a lot of options to track our spend and usage. So there's spend and usage, which are two different things. But hopefully that makes things very clear. When you want to figure out what your spend is, go over to your subscription. I'll just go back to the dashboard here, and I'll see you in the next one. Ciao.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Pricing Calculator. So configure and estimate the cost of Azure products. You don't have to sign in to use this tool, and what you can do is download an Excel spreadsheet and share that those costs with your boss. So to get there, you go to azure.microsoft.com/pricing/calculator, and from there you can go in here and you can fill out different things. So there's a bunch of different categories. The most common one would probably be a virtual machine. So you go in there and you say what region it's going to launch in, what OS. And all the types of configuration. It's going to give you an estimated cost. So this one down below is an upfront cost of $0 with a monthly cost of $152.62. So if you're not sure how to make sense of all the pricing, go here and play around and you will get a clear picture of what you're going to spend on Azure. So I just wanted to show you the pricing calculator. So if you just went to Google and typed in Azure Pricing Calculator, you should be able to make your way to this page. And so down below, we have a bunch of products. We also have example scenarios, which is very nice to see here. So let's say we wanted a CI/CD pipeline here, and we said add to estimate. We could get that information for all these components. I'm just going to go to single products because it's a bit easier to view. So let's say we want to determine our costs for storage. So let's just go to storage here, and we will try storage accounts. And then down below, we've now added storage. And so we can enter some information to try to determine our costs. So we could do blob, file storage, table storage. I'm going to go with file storage. Actually, no, I'm going to go with blob. It's just easier to calculate. And so we're going to have the performance tier to premium, redundancy LRS, and we're going to be East West. And so if we had 1,000 gigabytes, I guess it's a terabyte, that's $150. If we had X amount of write operations, X amount of list and create container operations, read operations, and here we'd have $150 as a monthly cost. So here you just have to tweak it based on your consumptions. And then generally they'll show you like purchase options, but really this just means like go sign up for an Azure account. But I just wanted to show you what that looks like, and just so that you know that you can go explore any cost and try to calculate something before you use it. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Cost Management. And so this service allows you to perform cost analysis so you can visualize the spending of your Azure cloud resources, but you can also create a budget under the service. So when you set a budget, you're going to define a threshold, and you're going to be alerted when you're approaching or you've exceeded that threshold. And so just to give you a visual representation there, that is for the cost analysis. So you can see you get beautiful graphs, and you can drill down and filter that stuff out to really understand how you are spending stuff on Azure. So definitely check it out, and there you go.
Let's take a look at the concept of resource tags, or just sometimes known as a tag. And this is a key and value pair that you can assign to Azure resources. So generally, when you are launching a new resource, you're going to have a tags page, and this is where you can apply that key and value name. And just to give you some examples of tags you might want to apply, you might want to have a department and then the type of department, status approved, a team, an environment, or the project or the location. And so you have a lot of tags that you can apply, and tags allow you to organize your resources in the following ways. You can organize them in your via resource management. So that's where you are specifying workloads, environments like developer environments. There's cost management and optimization. So cost tracking, budgets and alerts, operation management. So that could be business commitments to SLA operations. So you might want to tag services that are considered mission critical services. There's security, so that's classification of data and security impact. So if there's certain databases that have very specific compliance rules, you might want to do that as well, which I think is the next example here. Or maybe you're defining services that are used for automation, or services that are for workload optimization. So there's a lot to do with tags, and even though I don't use them frequently in my follow-alongs, it's definitely something is a good habit to do, and you should do in your production workloads. Hey, this is Andrew Brown from Exam Pro, and we're talking about Microsoft Purview Information Protection, also known as Microsoft Information Protection. And this is a collection of features within Microsoft Purview, formerly Microsoft 365 compliance, to help you discover, classify, and protect sensitive information wherever it lives or travels. So the idea here is that we have this diagram, and we have 4 specific domains that are information protection capabilities around our data. And so the first is know your data. The second is protect your data. The third is prevent data loss. And the fourth is govern your data. So we'll be going over all these sections in the next few slides. Taking a look at the 4 domains here for the Microsoft Purview Information Protection, these are features found within Microsoft Purview. So the first is know your data. Understand your data landscape and identify important data across your hybrid environment. So one feature would be sensitive information types. This identifies sensitive data by using built-in or custom regular expressions or a function. It provides corroborative evidence, includes keywords, confidence levels, and proximity. We have built-in sensitive labels, and you have custom ones as well. So then there's trainable classifiers. This identifies sensitive data by using examples of the data you're interested in rather than identifying elements in the item. So pattern matching, and you can use built-in classifiers or train a classifier with your own content. So you have trainable classifiers here. For data classification, this is a graphical identification of items in your organization that have a sensitive label, a retention label, or have been classified. You can also use this information to gain insights into the actions that your users are taking on these items. So that's the Context Explorer and the Activity Explorer. The second part is protect your data. So apply flexible protection actions that include encryption, access restrictions, and visual markings. So you have sensitivity labels. Azure Information Protection Unified Labeling Client, Double Key Encryption, Office 365 Message Encryption, Service Encryption with Customer Key, SharePoint Information Rights Management, Rights Management Connector, Azure Information Protection Unified Labeling Scanner, Microsoft Defender for Cloud Apps, and Microsoft Information Protection SDK. Most of these you won't need to know, but we'll definitely cover sensitivity labels. Then we have Prevent Data Loss. So this prevents accidental oversharing of sensitive information. Here you have Microsoft Purview purview data loss prevention, endpoint data loss prevention, Microsoft Compliance Extension. There's a Chrome extension that does compliance for you, so it's built in your browser. There's the Microsoft Purview Data Loss Prevention on-premises scanner, and protect sensitive information in Microsoft Teams chat and channel messages. We'll definitely take a closer look at Microsoft Purview Data Loss Prevention later. Next, we have Microsoft Purview Data Lifecycle Management, formerly Microsoft Information Governance, which is a collection of features to govern your data for compliance or regulatory. So for Microsoft Purview Data Lifecycle Management, it keeps what you need and deletes what you don't. We have retention policies and retention labels, inactive mailboxes, archive mailboxes, import service for PSD files. And for Microsoft Purview Records Management, it manages high-value items for business, legal, or regulatory record-keeping requirements. You have file plan, retention labels for individual items, retention policies if needed for baseline retention, and disposition review and proof of disposition. So those are the 4 domains in Microsoft Purview Information Protection. Govern your data is not technically part of it as it's in the data lifecycle and records section, but I included it anyways. So Azure policies are used to enforce organizational standards to assess compliance at scale, and policies do not restrict access, they only observe for compliance. So here on the right-hand side in the Azure policy portal, you're going to see a big list of policies, and Azure has a bunch of policies built in for you right away that you can use. So if you need to meet NIST or FedRAMP or HIPAA, what you can do is just turn those on, and it's going to check based on the categories to see if you're using Cosmo DB. It's going to check for that compliance and tell you whether you're being compliant or not. And there's a bunch of components that are involved when you're making Azure policies. So you have the policy definition file. And this is just a JSON file that describes business rules to control access to resources. You have policy assignment. This is the scope of a policy that it can affect, assigned to a user, a resource group, or management group. You have policy parameters. These are values you can pass into your policy definition so your policies are more flexible for use. And you have initiative definitions, and these are an initiative definition is a collection of policy definitions that you can assign. So it's a group of policies to enforce some kind of compliance like PCI DSS compliance. And I want you to carefully look at the screenshot on the right-hand side where it says definition type, and you see policy initiative. So the ones at the top there is talking about policy definitions, and then you have initiative definitions, which are just a group of policy definitions. All right. Let's take a look at resource lock. So as an admin, you might have a case where you want to lock a subscription, resource group, or resource to prevent other users from accidentally deleting or modifying critical resources. So within the Azure portal, you can set the following lock levels. You have the cannot delete, which is basically prevents deletion. So authorized users can still read and modify a resource, but they can't delete the resource. And the other mode is read only. So authorized users can read a resource, but they can't delete or update the resource. So those are the 2 modes, and that's something you might be interested in doing. Let's take a look at Azure Blueprints, and this is a way to enable quick creation of governed subscriptions. The keyword there is governed. So the idea is like you can go in your account and just create a subscription, but when it's a governed subscription, that means there's a process and certain expectations on how the subscription should be set up. So the idea is you're going to compose artifacts based on common or organization-based patterns into reusable blueprints, and the service is designed to help with environment setup. So blueprints are a declarative way to orchestrate the deployment of various resource templates and artifacts. And I just want to emphasize that word declarative. Declarative means that everything is spelled out. So we exactly know what's going to be created. And so artifacts could be role assignments, policy assignments, Azure Resource Manager templates, also known as ARM templates, resource groups. And the Azure Blueprint service is backed by the globally distributed Azure Cosmo DB. Blueprint objects are replicated to multiple regions, so they're definitely well backed up. And so the main question people are going to ask, well, what's the difference between an ARM template and an Azure Blueprint? Because an ARM template can automate the setup of stuff. Well, basically, Nearly everything you want to include for deployment in an Azure Blueprint can technically be accomplished in an ARM template. But the thing is that an ARM template, you are storing that either locally or in source control, and there is no active connection or relationship to the ARM template. Whereas Azure Blueprints, the relationship between the blueprint definition, what should be deployed, and the blueprint assignment, what was deployed, and it can also be it can also upgrade several subscriptions at once that are governed by the same blueprint. So blueprints support improved tracking and auditing of deployments. That is the thing. So they're very similar to ARM templates, but generally, if you have the options, you should always use Azure Blueprints. So there you go.
Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Portal. So the Azure Portal is a web-based unified console that provides an alternative to command line tools. You can manage your Azure subscription with the Azure Portal, build, manage, monitor everything from simple web apps to complex cloud deployments. So what does that mean? It just means the browser that you use to access Azure. So anytime you're logged into Azure, that is the portal. That's all you need to know. There's another thing about Azure Portal, and that's Azure Preview Portal. So the thing is that sometimes there are new features or new products that Azure has made that are not necessarily generally available, but you can get a sneak peek of them sooner if you use the Azure Preview Portal. So that could be previews, betas, or other pre-releases. So the way you would do that is very similar how you'd access the regular portal. But if you want a test preview of new features, you go to the preview.portal.azure.com. Or if you're looking for stable release and production ready features, you just use portal.azure.com. So that's all you need to know about the Azure portal. So I just wanted to quickly show you what the portal looks like. We are going to show you in this course how to create your own account and work within the portal. But I already have one set up here, and I'm already logged in. And if I go to the top here, I actually have this portal link now. And when I go here, we can see what the portal looks like. So this is the portal. You can see that it's telling me about my spend, but I'm on the dashboard right now. On the left-hand side, we have this hamburger menu where we can explore the services. We can go up here and search them as well. So whatever I'm looking for, if it's monitor, we can go there. And that's pretty much it. This is the portal. So it's just the browser when you're logged in, and you can interact with any cloud resources.
So in this video, I want to go take a look at the preview portal so that you are aware where that is. I know it exists. I never, ever go to it unless there is some kind of service that I think is going to get released and I want to teach you it. And so I believe that we just add something in front of it. So I was just looking up on the like the Azure's or the Microsoft tech community, and they're suggesting that it's this address here. I'm not really reading it. I was just looking for the address. And so if we log into here, we're now in the preview portal. And so we have access to all the preview things that Azure has. So one thing that is in preview right now, I believe, is Fabric, Microsoft Fabric. And this was just announced, I believe, or was talked about a lot at the recent Microsoft Ignite. And so this is a preview feature. If we want to use it, we have to be in the preview account. If we're in Azure here, I'm not sure if it will let us use it. So we'll go over here and just see what happens. I have no idea what the costs are here, so you can take a look and just not touch it. But here it says, Microsoft Fabric delivers an end-to-end experience, create a Fabric capacity. And then we'll go over here, and it's also here as well. So what I'm going to do is go ahead and see what happens if I try to create this. So it says, you cannot create a Microsoft capacity using a personal account. Use an organization account instead. So right now, I'm still in a free tier account, and it has to be within an organization. So they're not going to let me use this, which is totally fine. But I just wanted to see what would happen if I clicked it. And I don't know if that applies for any other preview features as well. I wonder if we typed in preview, if we could see what's in preview. Maybe. There is a preview features service. I've actually never tried to look this up, so I don't know. I'm just curious myself. So exploring pre-release features. So yeah, it looks like we can see all the preview stuff here. And there's nothing really popping out at me that we could go take a look and take for a spin. But it is nice to know that if you want to see where all the preview features are, we can go ahead and look at that. So yeah, that is all good here. And that's all I really wanted to point out. Now, if I could find a preview service to launch, we'd definitely test it. One thing I'm not 100% sure is how we would go ahead and use preview features in the CLI. So just give me a second to find out. All right, so I wasn't looking for this in particular, but it's worth taking a look here. So here it's suggesting that if we want to access preview features in our account, we can go under subscriptions and documentation. Let's go check and find out if that is the case. So we'll go over to subscriptions. And we'll click into our subscription here. And on the left-hand side, I'm scrolling down. I'm looking for document. Is that what they said? I think that's what they said, right? No, preview features. And here it is. And we'll go into here. And we'll give it a moment. It might be the same listing that we actually looked up just a moment ago. Okay. And it looks like we can just register them. So this is very similar to the resource providers. It looks like if we want to use them, we just register them. Yeah, I guess that's all there really is to it. I was always told that the preview portal was so that you can only use preview features. So if we can register them in the main one, what's the point? Anyway, in practicality, this is not something you really have to worry about, but you should know that there are things that are preview that you have to do some extra work to be able to access them, and just make sure you're not using them in your production workloads because Azure might roll back on them. And I've heard this from customers before where it's like they've worked with Microsoft and they worked for like 6 months and implemented stuff, and it really seemed like it was going to go through, investing a lot of money. And it really seemed like Azure was going to stick with it. And then last minute they said, oh, we're not doing this anymore. So really just be very wary of preview features. You can get excited about them, but do not put them in your production workloads. But there you go.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Cloud Shell. So Azure Cloud Shell is an interactive, authenticated, browser-accessible shell for managing Azure resources. And so it provides the flexibility of choosing the shell experience that best suits the way you work. So you can either use Bash or PowerShell. We just talked about PowerShell, and this is the place where you could use it in Azure. So just to give you a visual, if you ever want to access the Cloud Shell, it's all the way up in the header there in the portal. And so you click that button, it opens up PowerShell, or it will depend on what you choose, but it will open it up down below. And then you'll be able to use PowerShell right away, and also the CLI right away, which we'll talk about next.
All right, so what I want to do in this video is to introduce you to Cloud Shell. So Microsoft Azure has a portal, which is what we're looking at, and it basically has different services where we're going to have user interfaces. So if we want to, say, launch a virtual machine, they have this really nice, I don't know why it's asking me to log in again, but that's okay. But it has this really nice UI so that if I want to launch a virtual machine, I can just do some click ops. Click ops is when we perform operations through clicking of the mouse. But in practice, a lot of the times, especially if you're working in DevOps or other roles, is you're going to be programmatically creating resources because it's more efficient. Or there are cases in Azure where there is no UI and you have to do it programmatically. This happens especially with newer services or cloud native services. So just be aware that you cannot avoid doing some basic scripting, programming, or terminal usage. So the nice thing about Azure, and most providers have this now, but they have a way of launching a Cloud Shell, a terminal, so that you can programmatically enter in commands. And so that's what I want to show you in this video. So in the top right corner, you're going to see a bunch of little icons here. And the first one, and hover over to make sure that it is what we think it is, but it's called Cloud Shell. And if we go ahead and click that, what we're going to get is this dark box that's appearing below, and it's going to say, welcome to Azure Cloud Shell. Select either Bash or PowerShell. So there are two very popular scripting languages. One is called Bash. And it's also the terminal itself. It's not just the scripting language, but Bash is what is used on Linux. PowerShell is what is used on Windows machines. And so this is a way to programmatically interact with machines and programs. And so we should take a look at both of them, but I'm going to first take a look at Bash. Of course, we are in the Windows Microsoft ecosystem, so PowerShell is going to be what is probably preferred when we're using Azure. But anyway, the first thing it's going to tell you, if this is the first time you ever launch it, is going to say you do not have a storage account. So the idea is that this bash terminal needs to store some data, and so it's going to spin up a storage account, and we'll talk about that later in the course, in order to store some of the information here. And so this should be pretty low cost to no cost, so just go ahead and create that resource. And we'll just give it a moment here. And I just want you to know that it's still taking time for me to create, so if it's taking quite a few minutes, do not stress out. Just keep waiting, and we'll see what happens. Okay, I'm just going to pause and speed this up. Oh, and actually, there it is. It's done. So it took about, I don't know, 3 minutes for this to create that storage account. So while this is spinning up, a lot of times in Azure, they will show up in the notifications, recent actions, and it's not showing it up here. It might be this tab. Nope. But normally when resources are ready or being created, they will show up in the notifications. Not exactly sure why I'm not seeing it here, but I'm going to go ahead and right click and just take a look at notifications. And it really keeps asking me to log in. Not sure why today. Yeah, if we go here, we can see things that are happening. So it created a subscription. That was the start of our account. So I just recently created this account. And then it performed a generate. Not exactly sure what that was for. That's for a subscription, so totally not important, but I thought we would see and hear things like created a storage count, but we don't, and that's totally fine. So we'll come back over here and going to carefully read here. So it says, storage file share subscription is not registered to Microsoft Cloud Shell namespace. Please follow these instructions to register. In future, unregistered subscriptions will have restricted access to Cloud Shell service. So what I'll do is I'll go ahead and copy this link. Okay. And we'll just enter this in here. And it's giving us instructions about getting started with Cloud Shell. So what it's probably asking us to do is enable Cloud Shell. So this is, again, another thing that we have to understand about Azure is that we need to register particular services. So this is normally done under your subscription. So what we're going to do is we're going to go over back to our subscription. So let's just type in subscription here. And we'll click into our subscription. And I want to show you on the left-hand side, there's a tab called Resource Providers. This is something you're going to be going to a lot. And you'll see me go here a lot. But the idea is that Azure is made up of a bunch of different services. And you have to register or permit the access of these services. So in this tutorial, it's saying make sure that Microsoft Cloud Shell is registered. And if I go over here, it is registered. So I'm thinking what it did is it did it for us. So it said, hey, it wasn't registered, but we did it for you. Okay, and so now we're able to use it. But you'll, again, see me in many videos at the start of it, making sure that we have those resources. So anyway, we have this open. And this is running Linux, as far as I'm aware of. And so we can run some Linux commands for fun. So the first I'm going to type is pwd, which is print working directory, and then ls to list out the directory. And you can see that we are getting some input. What I want to do is just make this a bit larger. It's a bit hard on the eyes. And let's see if this cog here will allow us to change the font. So yes, we can. So that's the largest I can make it. I apologize if it is not better. But anyway, the great thing about these Cloud Shells is that they're normally loaded up with CLIs for the particular provider. So Azure has a CLI called Azure CLI, and in order to use it, you can type the command AZ. So if we type in AZ and hit enter, it should tell us a bunch of stuff on how to use this. And I'm just going to go ahead and hit this maximize button so we have our full screen here. And so the idea here is that in order to use the Azure CLI, we can go ahead and start typing things in. So maybe we want to find something about our Azure subscription. So I can go down here below and type in AZ subscription, or sorry, account. And we'll go ahead and hit enter. And right away, it's going to complain because most commands are going to have a command and then a subcommand. So here I'm going to go ahead and type in AZ account list as it's suggesting things that we can do. And so what it's doing here is it's returning back to us some information on our account. So in this video, all I wanted to do was show you how to open up Cloud Shell. In another video, we'll talk a little bit more about the Azure CLI and PowerShell and this other stuff. But yeah, that's about it here. When we're done with Cloud Shell, we can go ahead and hit the X and close that off. and we can just forget about it. So it's as easy as that, and we'll see you in the next one.
Hey, this is Andrew Brown from Exam Pro, and we are looking at PowerShell for Azure. So first of all, what is PowerShell? So PowerShell is a task automation and configuration management tool, but an easier way to think of it is just it's a command line shell, and it's also a scripting language. And so when I say a command line shell, I mean this thing, this blue thing. And so if you have a Windows machine, you can actually, you'd have to, I think, have Windows Professional, but you can go ahead and install this, and it allows you to automate things using its scripting language as well as in this program. Now, PowerShell is available on Azure as well, and we'll get to that in a moment. But let's just talk about the benefits of PowerShell over traditional shells. So a shell could be something like Bash or ZSH, which would accept and return text. But PowerShell is built on top of the .NET Common Language Runtime, so CLR. And it accepts and returns .NET objects. So those objects make it a lot easier to automate scripting. And so PowerShell is available on Azure, and it's known as Azure PowerShell. And so we have a set of commandlets for managing Azure resources directly from the PowerShell command line. And if you're wondering how you'd access PowerShell, you could use Cloud Shell, which we'll talk about here in a moment. Okay, so I just wanted to quickly show you PowerShell. I'm on my Windows computer right now, and this is natively installed on my Windows 10 computer. And I can type in commands here, and so this is just giving me a list of all my the directories in this current folder. But I just also want to show you that we have PowerShell here in the Azure portal. So I'm using the Cloud Shell up here, and I've chosen to use PowerShell, and you can see it's pretty much the same experience. With some extra things that make it easier to work on cloud. So that's it.
All right, so in this video, what I want to do is show you PowerShell. So PowerShell is kind of like Bash, except it's for Windows, and it looks different. So that's the easiest way to describe it, but let's go ahead and get some experience with it. So in the top right corner, we're going to go ahead and open Cloud Shell. I'm going to expand this open so it's nice and big. I'm going to make sure my font is nice and big. And notice right away that it launched in Bash. It's whatever you had open up last. You can restart Cloud Shell by clicking this button. I'm just going to drop down and click on PowerShell and just confirm, and it will go ahead and open it up. So notice that PowerShell is nice and blue. Most Windows computers should have PowerShell installed. I can't remember if you have to have Windows Professional or not. So I could technically open up PowerShell on my computer here. Not going to do that, but notice that this is spun up, and so now we can go ahead and use PowerShell. And PowerShell has its own syntax and its own way of working. It's a really powerful tool and very efficient when you are working as a systems administrator. But what we'll do is go ahead and ask ChatGPT the same thing we did before, but we'll say, let's use PowerShell, Azure PowerShell. And one thing I want to say about Azure or PowerShell is that PowerShell, the Azure package or plugin, takes forever to install. So I really am not looking forward to the time I'll have to show you in a future course installing that, because it just takes forever. I don't know why it's always it's like that, but it's always taken a very, very long time. I just want to point that out. So here it's very similar. It's saying, okay, the first time you use PowerShell, you're going to use connect -AZ account. The thing is that we don't need to do this because we're already logged in, because Cloud Shell will do that for us automatically if we're installing this locally. The process would be a little bit different. And so the thing is that PowerShell is going to follow this very interesting convention in terms of how they name their stuff. So here it's new -AZ resource group. And so there is a way of learning that syntax. So I don't use PowerShell a lot. I'm comfortable using it, but I just don't use PowerShell because I prefer Bash. But let's go see if there is a PowerShell Azure reference documentation, because that's what we would expect to look for. So we'll go over here, and I would imagine it's very similar. So yeah, commandlet reference. Maybe it's under here. And I said plugin, but yeah, they're called commandlets. And commandlets contain modules. So in here, we're looking for the module for, let's say, the resource group. So we'll go here and look for resource group. If it's not called that, let's go take a look. Oh, AZ resource group. Maybe it's AZ resources. And we'll go ahead and type in resource group. There it is. So the modules aren't always named exactly the same, but anyway, if you remember our bash video, very similar. We're going to go look up that documentation, and you know, it looks kind of similar. So we can go down here, and I'm not noticing shorter flags, but I'm pretty sure that PowerShell autocompletes. So we'll find out here, but I'm going to type in new. Yes, it does. And so that's one of the nice things about PowerShell, at least working on Azure, is that they really want to make everything really easy for you. So as soon as I started typing new, it already started auto-completing. And so I can go ahead and hit tab here. And I don't know why I didn't take the whole thing, but maybe, oops. And it's not taking the whole thing, but we'll keep typing here. Group, and so I can do -name, and so we'll call this probably singles. I'll stick with singles. I can't remember if it takes doubles, but we'll say my PowerShell RG, and then we'll do location, and here it's saying Central US. So even notice, like, remember, like we typed in US East lowercase and the syntax was different, so understand that things can be different. It's still suggesting more stuff. That is good enough, so I'll go ahead and hit enter. And so we get that back there. We'll go ahead and go to the next command. So it's going to be new AZ storage account. So we'll go back here. We could also search it here. We'll go ahead and just look it up. And we'll click on that one there. And so we have a bunch of commands. But you know, we just did this, so we're already familiar with the inputs that we're going to go into this. So I'll type in new. And we're going to say AZ storage account. And so we need our resource group name. And this one is going to be my PowerShell, whoops, my tab. Nope, it's not letting me tab that. Sometimes it lets you tab it, and other times it doesn't. My PowerShell RG. And we're going to name this... Again, these names have to be very unique. It's showing that the name is title case, so maybe we can name it whatever we want. I thought it had to be lowercase because Azure's really picky again about naming. It's very hard to remember because it's so different. So I'm going to just double check here. We'll go over to storage accounts and take a look. If I click onto this and I click on here, the name must be unique across all storage account names. It must be 3 to 24 characters long and can contain only lowercase letters and numbers. And I go over here and look, it's showing me title case. So I feel like it's lying to me. So I'm going to ignore it. I don't believe it unless it's going to normalize it for me, which I don't know. But you know what? Let's try to put it with title cases because it's not supposed to work, but we'll see what happens. So I'm going to just say my resource group, or sorry, storage account. I'm going to put a bunch of random numbers here and then my initials. Okay, we'll choose the same location as our resource group. So we'll just say Central US. And we should specify the kind of storage. It might default to something, so we might not even have to set one here. And what did we have to do for that? It was kind. So we'll go here and look up kind. Yeah, here it says blob storage. So it's not saying the flag here directly. Well, we'll just do storage version 2. It's totally fine. So we'll go here and just say kind storage version 2. It's interesting that this doesn't require, notice here it's not indicating single quotations. I would assume that it would want it everywhere, but we'll go ahead and hit enter and see what happens. And so it says commandlet new AZ storage account at pipeline position 1 failed. And so it's saying that the SQU name was not supplied. I'm going to do Control-C on my keyboard to just ignore that. But it's trying to prompt me to say, hey, you got to fill that one in. So I thought we could get away without it. So I'll go back and hit up on my keyboard. And I'm going to type in hyphen. I'm going to say SKU name. And we'll go with standard LRS, because that sounds like the default, to be honest. And we'll go ahead and hit enter. And right away, we're getting a problem. And it's saying, my storage account, etc., is not a valid storage account name. That's because it lied to us. It was auto-completing with title case, and I knew for sure that wasn't right. So I'm going to hit up on my keyboard and scroll on back. And I'm going to just take out those capitals here, okay? Oh, and there's still a mistake. We got to get rid of that capital S there. And it still doesn't like it. It might be suggesting the name is too long. Storage count must be 3 letters in length, lowercase only. I'll just take some letters out here like that. What does it not like? Oh, you know what? A, B is in caps. That's why. So we'll go ahead and do that. I notice it's talking about upcoming breaking changes. So it's even suggesting things that might change. And so, Bako, who's the other Andrew that is at Exam Pro, my co-founder, he loves PowerShell, and he always tells me like how awesome it is that it gives consistent output. It's very good at chaining programs together. His background was managing Windows machines for years. I'm more on the Linux side, so I'm going to be more biased for that. But PowerShell is a very, very powerful tool. We're definitely not even coming close to tapping all the power of it right here. But notice that it created that storage account. We're going to go back over to our portal, and we're going to go into storage accounts. If you don't see it there, you can just search it. And well, actually, I don't want to go here. I actually want to go to resource groups. And what we'll do is we'll go ahead and just clean this up because we're totally done with it. Make sure it's my PowerShell RG, not this one. That's your Cloud Shell that we're using right now. We're going to go ahead and delete that resource group. And I'm going to go ahead and copy it and paste it down below. We'll go ahead and delete it. We can go back over here, close that out. And yeah, just make sure that that does delete. But there you go. So now you got some exposure to Bash and PowerShell. So you're on your way of getting some good programming skills there, okay? Ciao.
Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure CLI. So what is a CLI? Well, CLI stands for Command Line Interface, and it processes commands to a computer program in the form of lines of text. And the operating system implements a command line interface in a shell or terminal. So we saw a shell earlier, which was PowerShell, but we'll look at what CLI commands look like here in a moment. So the Azure CLI can be installed on Windows, Mac, and Linux. Once it's installed, you would type AZ followed by other commands to create, update, delete, view, and manage your Azure resources. And so to really show you what that code looks like, down below we have a bash script, but this could easily be PowerShell. And you have the commands AZ, and then you would have what it is that you want to do. So if you wanted to create a group, you type AZ group, create, and you provide the name and the location. Or let's say you wanted to launch a virtual machine, which is a server, you do AZVM, create, and then provide those other parameters. So that is how you would programmatically create Azure resources. And there's tons and tons of CLI commands for Azure. So you basically, anything you're looking at pretty much can be created with the CLI programmatically.
All right, so in this video, what I want to do is get you more familiar with Azure CLI. It's very, 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 very important that you get some scripting, programming, any kind of exposure to that, because most technical roles in cloud require you to touch some kind of code-like thing. And again, Azure doesn't always let you do ClickOps with all their services, and sometimes you'll be copying and pasting commands. So it's important we get comfortable with that as soon as possible. So what I'm going to do is go in the top right corner and open up Cloud Shell. We learned how to do this previously. So watch the Cloud Shell video if this is the first time you're launching it. I'm going to go ahead and increase my font size to large. We're going to wait for this terminal to start. I just recently had Cloud Shell open, so it opened up very quickly. For you, it might take longer. And I want to remind people that the Azure CLI is pre-installed on here. So if we type in AZ, we should get back some output. Just understand that sometimes there are network latencies, so you have to be patient, but we're getting stuff back. So what would be really interesting is to go ahead and launch something anything here via the CLI. And so before we do that, I just want to show you how would you find out CLI commands. Of course, we can type in AZ and see them here. Another way that we can look at Azure commands is by looking it up. So we can say Azure CLI reference documentation, because that's often what CLI interfaces will have, is they'll have a reference documentation. And carefully looking here, this is at the Learn website, which is fine. We'll try the first one here. And what I'm looking for here is the reference. So here it says Azure CLI reference, and I'll click reference A to Z. I personally don't like the way that Azure lays out their docs for the CLIs. I definitely prefer the way Google or AWS does it, but we got what we got. And so here we have a bunch of different commands, and they are going to correspond to different things. So let's say we want to launch a storage account, which is something that is very common for us to do. I'm going to type in storage, which is one option. And we're going to go here and just expand it, and we'll look at summary. And so we have some options here. One thing I want to point out with the documentation is the status. So the status indicates whether these CLI commands are going to be supported, or whether they might be gone in the future. So GA stands for general availability, meaning that Azure has decided that they like this feature and they're going to keep it. Preview means that they're very likely to, they might bring this feature to all customers. And Azure likes to have a preview and a general available, I think it's a subscription or something. Somewhere there's a way to access it, or the portal's different. I always forget. But my point is that if you want to utilize preview features in Azure, you have to go somewhere else to do that. And so if you try to use a preview feature and it doesn't work, it's probably because you're not in the whatever preview setting. I'll do another video on that, so that's very clear. But my point is that always stick to the GA. Do not touch preview. Do not touch experimental, because if they do get rid of those things and you rely on them, you're going to run into trouble. But anyway, I'm interested in AZ storage, so I'm going to go ahead and click into here. And notice that when I click into storage, we have a big drop down of a bunch of stuff. And again, notice where it says type core, so it's a core command, or some are extensions. Stick to core, stick to GA, and they just have a lot of CLI commands. Other providers like AWS and GCP do not have this many commands. For whatever reason, Azure likes to take their services and put them under umbrellas. And they also like to just keep adding stuff. And so you might have CLI commands that do exactly the same thing. And so there are a lot here, and it can be really hard to figure out what to do. So I'm going to go over to ChatGPT, and we're going to get its help to kind of narrow down what it is that we want to do. So I'm going to say I want to create a blob storage account via the Azure CLI. And we'll go ahead and narrow down the commands it's going to provide us. Now, ChatGPT can go out to the internet and it can bring us back stuff, but we have to double, triple check it because it's not intelligent, despite it being called AI, but it can give us an idea of where to get started. So the first thing it's telling us to do is to do AZ login. And that's great, but we don't have to do AZ login because when we use Cloud Shell, we're already logged in. If we were to install the CLI on our local computer, we would have to utilize AZ login in order to first gain access, so we can skip that step. The next thing it's saying is to create an Azure resource group, which that makes sense. We always need to create a resource group, so let's go ahead and see what we can do, and I want you to follow along and do this in your own account, okay? So the first thing we want to create is an Azure resource group, and so we'll just quickly talk about that here. I'm going to open a new tab, and every time I do that, it wants me to log in, totally fine. And if we type in the top here, a resource group is a way of grouping together resources. And it's different. Like if you come from AWS, everything is within an account. If you're in GCP, everything's within a project. And in Azure, everything is within a resource group. And so before you create any resources, you need to put them in a resource group. And often you need to create a resource group. So that's what we're going to do. We're going to go back here. And this command is AZ group create. So let's go take a look for that command over here and find it. So I'm going to type in resource. Not very useful. So what I'll do is just search for it manually. And we have resource manager. That's probably what it is. And here we have AZ group. I think that's the command it's asking us to do. We'll go ahead here. And we have create. So we'll go ahead and look at this. And we can see it requires some parameters. It wants the location. So that is something it might want. It says that's a required parameter. There is the name. That's a required parameter. Then we have some optional parameters, and we can do some tags. So here it's saying resource group and location. And so the location is going to be a Azure region, and then the resource group is going to be the name. So let's go ahead and start typing that in here. So I'm going to say AZ group create, and then we'll do, sorry for the little pop-up there. It gets in the way. I'm going to expand this to make our lives a bit easier. I'm going to put in here, we had a short flag. So we have the long flag or the short flag. I'm going to use the shorter one because it's a bit easier to look at. And we'll do L. And we probably can do US East 1 or East US. That's what it is. I'm thinking about AWS right now. That's my problem. And the other thing is the name. So that's a -N. Apparently it can be -G as well, which is fine. So we'll do that. And I'm just going to say Azure CLI, and this will be blob, because we're going to create a blob storage account. And so what that's going to do is it's going to go ahead and create it. And so notice we got JSON back. That's usually a good indicator that it is working correctly. Notice that the provisioning state is succeeded. Sometimes this will come back and say it's creating, but resource groups create basically instantly. Let's go over to our resource group tab, and we'll give it a refresh. I want to point out that sometimes Azure is very, very slow in showing you what you've done. Azure's portal is one of the most robust portals compared to every other provider. And that is great. But the disadvantage to it is it's very hard for Azure to propagate that information to us. And so sometimes you will do something and you won't see it, and you'll think that you did it wrong or you didn't create it. But all you got to do is wait around. So just have a lot of patience when you create something, you don't see it, and double, triple check with Azure. So here we can see we've created our Azure CLI blob. So that is there. I'm going to go back over to our instructions, and we're going to look at the next one. So here it's saying AZ storage account create, and it wants the name and the resource group and the location, the SKU, and the kind. So what I'm going to do is I'm going to go over here, and we're going to look for storage. Okay, and again, I just really want to point out that if you're going to use any generative AI, don't blindly follow it. Double check the docs. Always double check it. So here, I think we're doing AZ storage account create. Yes, we are. And in here, I'm going to search for create. Here it is. Good. And notice it has a lot of flags. So there is a lot here. I'm not sure exactly what we'll need for this, but I'm pretty sure we can do these basic ones and it'll be fine. So I'm going to go back over here and type in AZ storage account create. And then let's take a look at the flags it wants. So it wants the resource group. So let's go over here and take a look at the flags. So resource group can be a -G. I think I like that, so we'll do -G. And it wants it to be the name of the resource group. We name this Azure CLI blob. So we'll go ahead and paste that on in here. Good. We'll go next, back over to here. It wants a name. We know that we can put -N for name here. And notice that the resource group allowed us to use the -G or -N flag to name the name. But in this one, -G means the resource group and -N means the storage account name. So there might not be consistency in terms of the flags between, like short flags between different commands. So again, just always double, triple check and don't just assume. We'll go here to the right. We have our location. So we'll go here and do, well, we got to give a name for this storage account. Now storage accounts, I believe, have to have all the, everything lowercase, no spaces. Azure is notorious for having crazy naming for every service. They're all different. And I think it's treated like a URL, like a domain name. So you have to make it unique. So I'm going to say here, my storage account, and I'm going to just put a number in here. So I'm going to put 1, 2, 34, and I'll say AB for my initials. You make it very unique so that you don't run into any troubles. We're still not hitting enter. We'll go back over here. Did we do the location? So do -L East US. And we'll go back over here again. And then there's the SKU, the kind. So I know the storage is going to be version 2. That sounds good to me. So I'm going to double check and look for the short flag, as I prefer those. So we'll go -kind here. And so we have a few options: blob storage, blob block storage, file storage, storage version 2. So I believe that we can do blob storage under storage version 2. So we can do either or. So I'm going to just stick with storage version 2 because it's totally fine. And this one doesn't have a short flag, so we'll have to do it in full. Also note that if we're using the CLI, we're pragmatically doing stuff. It's not going to warn us about free tier stuff. When you use ClickOps, you get a lot more information through the portal. When you're using the CLI, it's just programming, so it's not going to give us the same amount of stuff. So we'll go back over here, and we need the SKU. So let's go take a look at what it wants for the SKU. The storage account SKU. So this is going to determine the replication of resources. And so I just want to go with the standard one. Now notice it says a default value. So sometimes if there's a default value, if we don't include it, it will default to it. So I'm hoping that's what's going to happen. I'm going to purposely leave out the SKU. I'm going to go ahead and hit enter and see what happens. Okay, and so it's creating it or running it. And we'll just give a moment and see what happens, okay? All right, so we got a bunch of output back, and it looks like it was successful. So what we'll do is we'll double check. We'll go to the top here to Microsoft Azure. We'll type in storage accounts. And we can see that we have our storage account. So we've done something programmatically. There is more stuff that we can do here. We can go ahead and create our blob. We can list the containers. I don't want to do all those things right now. I just wanted to get you a little bit experience working with the CLI and being comfortable with that. Another thing I can say is that the CLI will allow you to output to different formats. It might be -O or something. I'm not sure if it'll show it here because that's kind of a global flag. So yeah, it's -O. And so let's say we wanted data in a different format. We could choose something instead of JSON. We could get table, YAML, or something else. So I'm going to go here and just say, here it says Azure Storage List. I just want to list all the accounts. So I'm going to see if that works here. I'm going to just say AZ. I'm just guessing, but I think it's AZ Storage Account List. And will that list out storage accounts for us? Notice it came back as JSON. So if we wanted to change the output, we can give it a -O flag. And the output format probably will vary per command. So don't expect the output format to be for all of them. This is default to JSON. Let's take a look at YAML and type that in here. There we go. So that looks a lot more readable, and I really do like YAML. We could also try table format. So let's do that. That's a very common one when you're in the terminal. Okay, there you go. So kind of looks like a table. It's a lot of information, so maybe not as nice as we'd like it to be. But that's the basics of working with Azure CLI. It definitely gets a lot more complex than that. But again, I just wanted to give you confidence with it. So now that we are done with that resource, I just want to go ahead and delete it. So I'm just going to go ahead and close out Cloud Shell. And we're going to make our way over to resource groups. So I'll type in resource groups at the top here. And on the left-hand side, I'm going to Azure CLI Blob. Here is that resource that we created. I'm going to go ahead and hit delete resource group. And I'm going to go and enter the name. I like how they say enter the name, but you can go ahead and copy paste it. The idea to type it in is to make sure that you know what you are deleting, but they've even expedited that. So that is deleting. And that's all I really wanted to show you with the Azure CLI, okay? So we'll see you in the next one. Ciao.
Hey, this is Andrew Brown from Exam Pro, and we're looking at Visual Studio Code. So Visual Studio Code is a free source code editor, meaning it edits code, made by Microsoft for Windows, Linux, and Mac OS, and you can even run it in the cloud. And if you're wondering what it looks like, this is the editor. And this is not to be confused with Visual Studio. So Visual Studio is an IDE, and it is also for programming, but it has a lot of functionality built in here. Is Visual Studio Code open source? Well, they say that it is, but I don't know to what degree. I don't know if it's 100% open source, but this is the most popular text editor or code editor out right now. And Azure has a service called, it's like Visual Studio Workspaces that's on Azure, and it allows you to spin up these developer environments using this editor right in the cloud. I don't think it's going to be on your exam, but I just thought it was cool to mention. And if you don't have a code editor, I strongly recommend downloading this one for your computer because it is great. So I just wanted to quickly show off Visual Studio Code here. So if you wanted to go download it yourself, you just type in Visual Studio Code into Google and you should end up here, and you can download a version. It's for Windows, Mac, and Linux, so you can download for anything, and you can run it in the cloud on Azure, or even launch your own server on other cloud providers. I just happen to have Visual Studio Code open here with an open source project, just to show you what it looks like. The thing that people really like about it is just it looks great and it has really good plugins. So if I just go to extensions here, you can anything you need, you can add it and enhance this editor here. If you don't have a code editor, I strongly recommend downloading this, and I just wanted to make you familiar with this editor here.
All right, so in this video, I want to introduce you to Visual Studio Code, and maybe we can go ahead and use a bit of Azure SDK in order to programmatically set up a resource. So this is very similar to how we use the Bash CLI or PowerShell CLI, but we're going to use a programming language to do it. And again, I really believe that you should learn this as soon as possible, because very quickly you end up having to touch code or scripting or something. So get comfortable with it right away here. So what you're going to need to do is install in Visual Studio Code. I'm not going to show you how to install that. It's not that hard to learn, but you're going to go look for Visual Studio Code and you're going to install it. This is a free and open source coder or code editor. And once it's installed, we can go ahead and start utilizing it. So you go ahead and install it. I already got it installed. In fact, I got a project open here, not the project we're going to use, but this is actually how I stitch the big video when I send it over to freeCodeCamp. So I have a bunch of scripts here. But what I want to do is, once you have it installed, we're going to go ahead and create a new folder. So on my desktop, I'm going to go do that. So let me just make some room on my desktop here, okay? All right, so I got some nice room on my desktop. I'm going to make a new folder here, and I'm just going to call it Azure, because we keep doing things with the storage bucket. So we'll just say Azure SDK example. You can name it title case, lowercase, however you want to name it, but just make sure there's no spaces in it. I know that's a bit hard to read on my background here, but we now have a folder, and that's just going to give us a place to start working with. So I'm going to go ahead and say File, Open Folder, and this is pointing to my sites directory. So I'm going to go back and I'm going to say Desktop. I think we have a desktop there, right? And I'm going to say Show Local, so it'll just open it up here, make our lives a little bit easier. I'll click on Desktop here. I'm going to choose Azure SDK example, select that folder. And so it's going to open that folder up, and it's opening up my whole desktop, which is really not what I want it to do. That is totally wrong. So give me 2 seconds, okay? All right, so what I'm thinking is what we'll have to do is try this again. So let's say Open Folder, and we'll go to Desktop, and we'll double click into that folder. Make sure we're double clicked into it and say Select Folder. There we go. So we're in that folder. It looks like we're not in there, but it's here in the top. And, again, I'm not going to go super heavy into this because this is a completely separate discipline, but do your best to follow along. So we want to create a new file. You can do that by going to File, New Text File up here. You can also click this little icon here to do that. So we'll go ahead and say New Text File. And the question is what are we going to write our code in? Because we're going to need to write this in some kind of language. And so I'm just trying to decide what we can use here. So that is another question as well. So just give me a second to think about it, okay? Instead of thinking about it, what I want to do is I'm just going to go ask go ahead and take a look quickly. So we'll say, it's probably in the slides, but I can't remember all these things off the top of my head. Azure SDK languages. And so we'll go here and we'll take a look. And we have Android, C#, Go, C, C++, iOS, Java, JavaScript, Python. No Ruby, which, I mean, I think there's Ruby somewhere, but they haven't been maintaining it very well. So we do have a few options here. The question is, which one do we want to use? I don't really like any of these languages, but we're going to have to make a choice. And so I guess we could use C#. So maybe what we'll do is go ahead and use C#. I almost feel like I'm going to regret using that. So, all right. So anyway, what I want to show you here is, yeah, we'll write some C# code. And actually, we're going to cheat. We're going to go use ChatGPT because I really don't want to spend forever figuring out how to do it. So we'll say using the Azure SDK for C#, let's deploy a new resource group or a new storage account in a new resource group for blob storage. Okay, so we'll go ahead and hit enter, and we'll see what it produces. Deploy a new Azure storage account for blob storage in a new resource group using Azure SDK. You're going to need the following. So it's going to say install the Azure SDK. Okay, and so we'll just give it a moment to spit out some stuff. All right, so it's produced some code here, and so just taking a look here, we have our code example, and it's explaining everything here, but I don't need that. And so the idea here is that we first are doing our imports. Most programming languages are going to have you require import resources. So obviously resource manager for creating the resource, and then we need storage for storage accounts, identity for probably connecting to Azure. That's most likely what it is. System is for system stuff, so maybe for doing outputs and things like that. And right away, we can see that we need to create our credentials. And then from there, it's saying initialize the ARM client. So ARM stands for Azure Resource Manager. So I imagine that has something to do with maybe resource groups. We'll see here in a moment. So we create the Azure Resource Manager client. And from there, we can get our default subscription. That makes sense. And from the subscription, we'll get our resource groups, and we'll create or update a new one here. And so here, it looks like it's going to create our resource group. Then next, we have our storage management client. So it looks like that's how we create our storage account, or at least it's the manager for it anyway. And then we're creating our storage account. Okay, that makes sense. If this looks very verbose and tricky, it is. It's just the nature of C#. C# is a great language, but I'm just going to say that the way they choose to name things here, I even find a bit confusing, and I work with every single programming language. But we do have some code here, and so the idea is that we can go ahead and copy this code, and I'm going to go ahead and paste this into Visual Studio Code. Now, I do want to point out that in order to run this program, we actually have to have C# installed. And I'm not even sure if I actually have that installed on this computer. So we're going to have to see what we can do there. So I'm going to go ahead and just save this file. And I'm just going to name it, we'll just say storage, new storage account .cs, because that is the extension for C#. And so it says, do you want to install the recommended C# extension for the language? We'll say install. So the thing is that Visual Studio Code on the left-hand side, they have extensions. And they have extensions for everything. And I just want to point out that Azure, because Microsoft created this project and Microsoft owns GitHub and all this stuff, is Visual Studio Code has tons of synergies with Azure. And in fact, you can create resources and other things via Visual Studio Code directly. So here it says the .NET Core SDK could not be located. And so we can go here and say get the SDK. It says, do you want to code to open the external website? Yes. And it's complaining because it's saying, hey, you don't have this installed, it's not going to work. And so we could go ahead and install it here. That is one way to do it. But the thing is, it really depends on what kind of machine you're on. If you're on Windows or Linux or Mac OS, it's going to be a different installation process. So we can do it this way, but there's another option. And the other option that I'm going to recommend is to not do it locally, but do it in a cloud developer environment. Now, most cloud service providers have a cloud developer environment. AWS has Cloud9, GCP has, I forget what it's called, Project IDX, and they even have one built into their platform. But for whatever reason, all we get is Cloud Shell in Azure. So I like to think of GitHub's code spaces as Azure's cloud developer environment. Why it's not directly integrated with Azure, I have no idea. So what I'm going to do is I'm going to go over to GitHub. And you are going to have to create a GitHub account. And they're free, and you should absolutely have one because every person that's working in tech should have a GitHub account. But I'm going to go ahead and log into mine. I'll be back here in just a moment. And if you don't have one, go ahead and create yourself a GitHub account. All right, so I'm in my GitHub account, and what I'm going to do is I'm going to create myself a new repository. And again, don't worry if you don't know all of this. Just do your best to follow along because there is a lot to learn here, and I'm not trying to overwhelm you. But let's go ahead. I'm going to choose the owner as myself. So you would have chosen a username when you signed up. Mine is Omen King. I also have like another account called exampro.co. I probably should use that one. And we're going to just say Azure SDK C# example. So you can name it exactly the same. These are you can have the same name for a repo that someone else has because it's going to be based on the scope of your name here. We can make it private or public. I'm going to make it public. That way everyone's going to see it. I'm going to add a README here as well. And we're going to go ahead and create this repository. So we'll go ahead and create that. And we'll just give it a moment. And so now that that's been created, you're not going to have this Get Pod button here. But what I'm going to do is drop this down. And it's, sorry, code. I want the code button here. And we have this option called Code Spaces. And so here, Code Spaces does have a free tier, or they should have a free tier anyway. Yeah, up here. And the free tier is going to let us run for a short period of time. I'm not going to get fully into that because we're not going to be doing enough coding to even worry about that. But we're going to go ahead and create ourselves a code space on main. And honestly, I actually prefer Gitpod for cloud developer environments. The reason I'm using code spaces is because Visual Studio Code has a marketplace. So if we go ahead and type in Visual Studio Code Marketplace, and these are extensions for Visual Studio Code. It's when we're over here on the left-hand side and we're installing fun plugins or extensions. They're coming from this marketplace. And even though I prefer Gitpod, this portal or this marketplace is provided by Microsoft, and it's a proprietary marketplace. So all of the official Microsoft integrations are here. And if you use a Gitpod, you're not going to be able to access the full suite of these. You could technically use them if you opened Gitpod within local Visual Studio Code. I'm not going to do that here today. We're going to just go ahead and use code spaces. And I don't use code spaces that often, but we're going to use it here. The first thing I want to do is change the theme because I do not want to look at white. So I'm going to go all the way down to the bottom to this cog here. And I'm going to go to settings or themes. Here we go. And we'll choose color theme. And I'm just going to go and say dark Visual Studio Code. And now my eyes are thanking me for putting that effort in. And so what I want to do is create a new file. So we can upload new files here by dragging them. So on our desktop here, we have this folder and this file. So I'm going to go ahead and just drag this file on over. Okay. And the thing about code spaces and Gitpod is that they should have a lot of these things pre-installed. So down below here it says, do you want to install the recommended C# dev kit? Yes, please. I would love to have the dev kit. So the dev kit helps you manage your code with a Solutions Explorer and test your code. Sounds great to me. And we're going to go ahead and let that install. Now, I want to point out that the way these cloud developer environments work is as long as you are running them, they are consuming spend. So if you are trying to walk away and go get coffee or food, please, please, please make sure you close the tab so that it's not just running and you're utilizing credits or usage. Again, you're on a free tier, but let's make sure we don't use up all that free tier. So I think that extension is now installed. And so we should start to be able to use C#. So what we'll do is go back over here, and we have our new file, and it's right here. And so we have our program. And so we should be able to run it. So there's a few values we need. We need our subscription ID, our resource group name, our storage account, and our location. Okay, so these are the few things we're going to want to fill out. So I'm going to go here and Yeah, I'll take West US. I don't care. It doesn't matter. We'll say West US. Then we have our storage account name. Remember, that has to be very unique. So I'm just going to say, hello, world. And I'm going to put a bunch of numbers here. And I'm going to say AB. Remember to keep it lowercase and not any trouble here. And here for the resource group, we're going to say my SDK. Did we already create one? No, we didn't. So we'll say my SDK RG. And then we need our subscription ID. So we'll go over here. Subscription ID is going to be, if we click into our subscriptions, it's right here. So we'll go ahead and copy that in. Okay. And we'll make our way back over to here. I'm going to go ahead and paste that in. We'll say allow. Good. We'll click, oops. Try not to add any additional characters by accident. Be very careful. But yeah, that looks fine to me. And so I filled in all the things that it's saying that I need. I also want to point out that, ChatGPT generated the code, but it doesn't always give you good code. So just understand that we could run this and it could possibly not work. And it might even give us things that we don't want. So always make sure you can understand what you're reading. So here it's saying it's using the standard LRS, which is good. It's using storage version 2. So everything that we've been doing up to this point. And so now I want to run this code. Again, I don't run C# code a lot, but sometimes it uses Mono. Sometimes it uses different engines for running. But let's go take a look at our extensions. And we'll click into this one and see if there's any options to start running it. So it does say there's like build and run options here. So it says Command Shift net build. So it's possible we can build it that way, and that's probably the way I'd like to build it. So we'll go back over here. And the thing is that we haven't logged into anything, so it's my assumption that this isn't going to work. Okay, so what I want to do is I want to open up the command palette. So I believe we go down here to the bottom left corner, click the cog. If we type in Control Shift P or click this button, it'll open the command palette. And what we're looking for is that .NET build. So I'm going to go ahead and do .NET build and see if that works. I did click it. We'll try this again. Command palette. Says we used it. .NET build. And I'm not seeing anything happening. So did it build? I'm not sure. So give me just a moment. All right, so I went over and I asked ChatGPT, how can I just run it? And it was not helpful whatsoever. It did tell us that we should probably have the Azure CLI installed, which I absolutely agree. So this is a great opportunity for us to do that here. In fact, it might already be pre-installed. So if we just type in AZ, is it here? No, it is not. So maybe that's something we can go do. So I'm going to go type in AZ CLI install, and we'll go get the instructions for that. And so I want to install this for Linux. We're probably on Ubuntu or Debian, so I'm going to go ahead and click that. I'm going to go to install Azure CLI. And so we want this one-line command. I've done this a lot of times, so I know it's this one-line command. So we'll go ahead and copy that. And we'll go back over to GitHub Codespaces, and we'll go and paste that in there. Now I realize this font might be a little bit small, so while that is installing, I'm going to go ahead and increase our font. So I'll go ahead and increase our font size. I'm going to type in here terminal. And if you're finding that I'm going really fast, the great thing is you can always go back and watch the video. I really do encourage you to try to work through the steps and try to figure out what it is that I'm doing. Of course, I could go a little bit slower, but the best learning is the part where you're going to go out and try to really figure out what it is that I'm doing here. So that's why I'm not being super detailed and slow with these steps. Just be aware of that. So I'm just typing terminal font in here because I want to increase that font. There it is. And so we'll just say 24. There we go. That might be a little bit too big. We'll go down to 20. Okay. And so the CLI is now installed. So if we type in AZ, it will now should prompt us. And so now the next thing we want to do is log in. So I can type in AZ login. And so what it did is as soon as we typed in AZ login, it popped up a new browser window, and it's allowing us to connect to Microsoft Azure. So I click this, and even though it's not going anywhere, that's totally okay. We'll go back over here. And it didn't work because we are not doing this on our local machine. We're doing this within a browser. So it says if no web browser is available, or if the web browser fails to open, use the device code below. So that's what we're going to do. We're going to actually do that instead. So I'm going to type in AZ login -- user device code and hit enter. Okay, and we're going to give it a moment here. Oh, and then it says copy this link. So we're going to go to this link here and hit enter. And it's going to say enter this code in. And so we'll go ahead and enter in this code that it wants. Okay, and we'll hit next. And then we'll pick our account. Are you trying to log in with the Azure CLI? We absolutely are. We'll go back over to here. And it now gives us output. So we are now logged into Azure CLI. So now that the CLI is installed, we are in better shape. The thing is, when you log into the Azure CLI, I don't know where it is, but it's probably dumping some kind of file locally onto this computer, onto this workspace. If I type in ls, so somewhere in here, I'm not sure where, but somewhere in this on the storage of this workspace in the cloud, it's storing the credentials to log us in. So we don't have to pass in, or we shouldn't have to pass in credentials here. And when we run the script, it's going to rely on that local file. And it should pull it from these default credentials. So the next thing I want to do is run this program. And it really did not tell us how to do that. So I should know how, because I do have my own unpublished thing. So I'm going to go take a look and find those instructions. All right, so I just want to point out that you will not have access to this. This is totally private, but I'm just trying to find notes from it. And I also wanted to prove that I actually do know all the programming languages for cloud, but knowing them, when I say I know them, I mean like I've used them all and I've made really good notes. And so when I need to go back to them, I can always look it up. And so somewhere here, we should have some notes for C#, and because there's a few different ways we can run it. There's a program called CSC, which is the turbo compiler. So it depends on what we want to utilize. And we could use NuGet. We could have also created a .NET project. That's probably what we should have done. So that's probably what we should have done, is we probably should have created ourselves a .NET project, because now that I'm remembering, that's pretty much the way that we do it. Okay, and that's going to make our life a lot easier for utilizing. So what I'm going to do is just take a look here, and let's go back to ChatGPT and say, okay, how do we use the Azure SDK C# and we create a new .NET project? Okay, and so this should be more in line in terms of what we want. So ChatGPT is only good if you know what to ask it. And it's talking about NuGet packages, and that definitely is what it looks like I was doing there before. So we'll give it a moment here to help us see what's going on. I just want those commands. And it's asking us to do this through, it's like telling us to click through. It's saying like, go up here and click, 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 like create a new project in there. But that's not how I want to do it. I want to do it via the CLI. And all I wanted to know was, whoops, I just closed that tab. We actually needed that tab. But what I wanted to know was, what framework version does it want us to use? Because that could matter, right? And that's what we're not getting an answer for. So that's kind of important. So we'll go back over to here. And it's really, really, really not helping us. This is not helpful whatsoever. So I'm just going to tell it to stop talking, because I know it's not helping us. And I'm just going to pull up that example again. Just give me a moment. All right, so I have this pulled up again. I'm going to go back to my hello world. Again, you're not going to have this. You don't need to have direct access to this. It's fine. And then down below, there is the thing here. So we need to create ourselves a new project. We're going to say .new console, because it's a console project, and we're going to want to have that package. So I'm just going to drag this off screen so I can see it and type it. And then you'll just have to follow along here with me. Okay, just give me just 2 seconds to be able to see this here. And okay, so what we're going to do is go back over to here, to our project, and I'm going to try this. I'm going to type in .new console -n, and we're going to say package.net, and we're going to try framework net 6.0. Even if there was a newer version of the framework we could use for C# or for .NET, sometimes it doesn't like the latest version. So even over here, like I made a note, I said, even though .NET is the latest, neither fake nor bogus works with .NET 7.0. So, you know what, I'm going to try to use 7, and hopefully we're not going to run into issues here. And so it did a bunch of stuff, and it created this package over here. So it actually created a folder called package.net. And if we open it up, we have a program. And so that's where our code has to go. So I'm going to go ahead, and I know this is a bit of a mess, but I'm going to go ahead and copy this over here. And I'm going to take all of this. I'm going to cut this. I'm going to go over this program, and we're going to paste it into here. Okay? And I'll delete the old file here. So now we have our package, and we're in better shape. So now we can probably use those .NET commands to build the package. That's probably what we can do here. So that's what I would like to do next. So I have to find that command. I believe it's just .NET run. So if we type in .NET run, that should probably do it. Couldn't find a project. So we probably have to cd into that folder. So I'll type in cd package -net / enter. I'm going to type in ls to see what's in there. I'm going to type in clear, clear to clear the screen. I'm going to go ahead and type in .NET run. Okay, and hopefully it's just going to run it. Now, we didn't install any packages for it, so I don't know how we would know how to run these. And it looks like it's actually complaining. It's saying the type or namespace name Azure could not be found. It's talking about this up here. So normally, you, like in programming languages, you have to install packages or libraries. And every single programming language usually has its own package manager. And I believe the one for .NET, or the one for that one, is called NuGet, N-U-G-E-T. So there's probably a way to add it. And it's actually probably part of, because I'm looking at my commands here, it's probably part of, NuGet's probably part of .NET. So I'm going to type in .NET. Add package, and we need to figure out what the package name is. So I'm going to just type in Azure because it's probably what it is. I'm going to go ahead and hit enter, and we have to actually spell .NET correctly for that to work. Again, this is just me totally guessing, but I believe that's what's going to work. And so I go up here, and it looks like it's trying to install something. It's talking about this falling back here, and then it says error. There is no version available for the package Azure. So clearly there is something more to this here. So Azure NuGet package and version. So that's what I'm looking for here. Okay. And I'm just trying to find what it is. So I don't want to search the internet for that. So I want to install the Azure SDK via .NET add package. What is the command? Okay. Once you know programming, ChatGPT is great because you can narrow it down and help you save you some time, but it's not always easy. And sometimes it just doesn't tell you what you want to hear right away. So here's saying Azure Identity. So it looks like we might have to do them individually. Okay, so let's go give that a try. So I'm going to go back over to GitHub in our code spaces. And let's try each of these individually. So I'm hitting up. I'm going to try identity. Let's see what happens. It looks like it's installing. That looks great. Okay, great. So we're on to something here. Excellent. So we have that one. The next one is Resource Manager. So I'll paste that in there. Enter. Just going to bring this over here. I don't know if we need to specify these individually underneath. So I'm just going to copy them anyway and just try them. Again, I don't know if we have to do that. Often when you have the top level one, you get them all. But Since doing the top level Azure didn't work, I don't trust it. And it did install something, so that looked like that worked. We'll do storage next. And these two we're not going to do because these are built-in packages. We don't have to go ahead and install them. Very common for most languages. So I'm going to type in clear here to clear out our screen. I'm going to hit up, up, up till we get back to that run command. And we're going to try that. It says there is no given argument that corresponds to the required parameter data here. And it's saying on line 2490. So we're going to go down below and look at line 24. And it's complaining about this, saying something about data. So there's no argument given that corresponds to the required parameter data. And so probably what might be happening here is either, well, ChatGPT gave us bad code, or it's looking at old documentation. So it's not that it purposely gave us bad code, it just doesn't know what's the latest. There's a few other errors here, like the name SKU name does not exist in the current context. The kind does not exist in the current context. And it's talking about this here. So it really looks like ChatGPT lied to us. Okay. So what we can do is we can just go ahead and paste this into ChatGPT and see if it can try to solve it for us. If not, we can go look it up ourselves. We get the following errors from the code provided earlier in this chat. Okay, so for me, I would just go out to the documentation, go fix it. I'm trying to show you how you would do this if you don't have the same kind of programming skills. So here it's saying the errors you encountered, project suggests some issues. Great, so it's just going to tell us what problems it had, and then we're going to wait just a moment and find out what it is. Make sure you have the latest packages. Well, we just installed them, so it should be correct. Okay. Well, the other thing is that we don't know what versions Azure was using, right? So that might be the issue. Check the latest SDK documentation. Of course. Yeah, so it's, okay, suggest code changes. Like, come on. You're not really helping me today, ChatGPT. All right, and we'll take a look here at what it's saying. So looking at this very carefully, here it says new resource group data, and then this one here is saying create or async. So it looks slightly different. The method seems to require additional parameter. Okay, it's guessing. It doesn't know what it's doing. So I really don't trust it anymore. And so what we'll do is we'll go back here and take a look at our code. So the first one it failed on was line 24. All right, and so that's on here. So we need to go figure this out. I'm going to close some of these tabs because we're kind of getting overwhelmed with tabs here. And I'm going to go type in Azure SDK C#. And we'll go over here. We'll say storage accounts. And we're going to try to figure out if we can find some official docs. Okay, AZ login, we've already done this. Here they're using Visual Studio. We're not using, well, this is how it did it over here, which is fine. But we just want to see the reference docs. So yeah, it's talking about blob storage, which is great. Let's go to reference. Azure, it might be, whoops, might be over here. Azure SDK C# reference documentation. We'll go over here and we're looking for these commands. So the first one it mucked up on was line 24. So I believe this one's okay. This is for creating a resource group. So we'll go here and I'm going to search resource group. It's probably under resource manager. And here's showing that we add that .NET package, so that makes sense. And so we have this line here. So if we go back to our code, do we have that line? Looks like we do, right? New ARM client. Yeah, it's down here, sorry. New ARM client, so that's right. Now we get a resource group collection. So this one's slightly different. It's trying to do it all in one go, which that's one way of coding it, but I actually kind of prefer what they're doing here in the documentation. So I'm going to go ahead and grab this so that we assign this to its own variable. Okay. In coding, you can do things multiple ways. So, one code can do the exact same thing as something else and be written differently. That can make it very confusing if you don't know what you're looking at. We'll go ahead and paste this one in next. So it looks like I cut off a bit of that code there. Okay. And so this is now the equivalent of this. So that gets that part. And then this is the equivalent of that. So that's that part. And so the next thing we need to do is this create or async thing. So we'll go to the next step. And we already have these two things set up here as strings. This one's set as an Azure location. So we probably want to do what they're doing here too. Okay, so I'm going to go up here and paste this in like this instead. Okay. And it really depends on what the thing wants. So maybe in the older SDK, it took a string, but now it looks like it takes a variable data type of Azure location. That's why I'm doing it this way. Okay. So that looks fine there. The next part is resource group data. So that looks very similar to our code here. Notice it's not doing a create or async update. I mean, that's probably one way of doing it and probably a good way of doing it. Make sure you put these semicolons on the end here. C# really likes these. Some languages don't care, but this one does. And then it does it on the next step here. So it does it here. Okay, so it's still doing that operation. So we'll paste that in. And I don't know where it went. It didn't really go where I want it to go. We'll go ahead and paste that in again here. And we'll hit enter. So we have ARM operation. I don't feel like explaining this part, but that's a feature of C# coding. That's like an interface, I believe. I think that's what they call it. So we have to create or update or async. So wait until it's done. Pass in the resource group name, which is that up here. And then pass in the resource group data, which is that here. And so that takes care of this part. Okay, so we've now replaced that part of the code. So that is fine. That will create our resource group. And the next thing we need to do is create our storage account. So to be honest, because this code is so hard to do, I'm going to make it a lot easier for us. I'm just going to wipe this part out. Because if we can just make a resource group, we've kind of done enough coding here. But the whole process we went through in terms of, starting with a single file and having to work with it, and then we moved over to the CD GitHub Codespaces, which is a cloud developer environment, and we had to do some research. This is totally normal. This is what happens every single day. So I'm really happy that we're able to show that, even if it is a bit of a mess. But let's go ahead and see if this works. The only thing I'm wondering is about this Azure location. How does it know about it? Because we didn't have any requirement up here. But we'll go ahead and we'll try to do a .NET run. And it might complain about that. So it says the variable subscription ID is assigned, but the value is never used. And that's true. We don't actually ever use it anywhere here. The variable storage name account is assigned, but the value is never used. And that's because we don't ever use these. So these are warnings. They're not errors. But I'm going to go ahead and delete this one out because we're actually not using a storage account name. Whoops, that's a bit too much. And we should probably be using a subscription ID, but for the time being, I'm going to comment that out. I'm going to assume that it can infer the subscription ID based on when we did the AZ login. So we're going to go up here a bit. It says the type or namespace Azure location could not be found. That's what I thought was going to happen. So how would we include that in here? We already have Resource Manager in here, right? We do, and we're not really using these other ones anymore. So this one I'm not 100% sure. So let's say Azure location. And we'll go back over to here because this is the thing with tutorials. They don't always tell you all of the code. They're sometimes missing something. So we need to go figure that out. And I'm going to go back over here. Okay. So it cannot be found. And we'll use ye olde Google for this, because it should be smart enough to do this. It's not telling us here. So we'll go and try ChatGPT. Azure location is not found in my C# script. What package do I need to install? You'd think it'd be the resource manager one. Okay, just tell me what I want to install. It does say Azure Resource Manager. So coming back over to here in our code, we have it right here. And we have those two there, yep. I mean, I'm pretty sure we installed that. We probably still need the resources one in, so I'm going to bring that back. Whoops. And we'll go ahead and paste that in. We'll save that. Yeah, this one's quite the pickle. So the Azure location does not exist in the current context. All right, let me go figure it out, okay? All right, so I'm not getting much luck here, but I imagine that this might be actually resolving as a string anyway. I'm not 100% sure, so I'm going to try to cheat. And I'm going to try to make this a string and see what happens. And it might work, but I'm not 100% sure, so I'm going to go ahead and just say West US here. I'm going to go ahead and comment this out. And fingers crossed that it's going to let us do this. Programming is not always easy. It's sometimes like this. It says the client does not exist in the current context. The name wait until does not exist in the current context. Wow, it's really making our lives super difficult here. It's talking about these. And it's frustrating because it's not showing us in this code example all the stuff. So I'm going to go ahead and copy this code example, go back to ChatGPT. Can you show me what using statements are missing and should be added to get this code to work? Very often, programs do not show you all those things, and it drives me crazy. Okay, and it could be because, like, if you're using Visual Studio, which is not the same thing as Visual Studio Code, it would automatically add those in there. Okay, and so here it's saying, okay, we got to use models for Azure location. Okay, but what about some of these other ones, like, well, anyway, we're going to go ahead and copy them in, and we're going to give it a go. We didn't have this Azure core here before. That probably is very important. So we'll go ahead and paste that in. And I'm going to go ahead and do .NET package. Was it new or install? Or it's add. Azure core, we'll do that. You know what, if we did Python or JavaScript, we would have done this a long time ago, but you know, I would say that getting exposure to .NET is probably the best one for working with Azure here. So I don't know if it installed all of these. We'll try resources. We probably don't need the model part. Oh, sorry, this is resource manager resources. And then we'll go here and we'll say resources models. Again, I don't know if we really need all the end ones like that. I don't think so. Yeah, there's no versions of it. So probably the upper ones is the one that works. We'll go ahead and try this again. Please work, or give me something different. The name client does not exist in the current context. It is killing me, this program. Client, where is that here? Let's search for that. Let's look for that. Client. Right here, client. Well, maybe it's because this one's named a bit differently. So we're coming back to our code. This one's called client right here. This one is called ARM client. So we'll just change this to client. Okay, we'll save that. We'll hit up. Please work. getting closer. We have this wait until. Say, what about wait until? See if he figures that one out. And it's telling me to use Azure in the top level. That seems kind of exhaustive. For the wait until, you need to include Azure namespace. Okay, I mean, that doesn't sound right to me, but we'll go ahead and do that anyway. Unless it's saying, I mean, if it's in that namespace, couldn't we just say azure.waituntil? I'm not really sure, but we'll go ahead. People that are probably like better C# programmers than me are just cringing watching me do this. But we'll go ahead and try to see if we get that working here. So say run. Please tell me you don't need me to install Azure as well, because we have it installed like 10 different ways. Please, please, please work. It's taking time, so I mean, that's probably a good indication. Oh, it worked. Okay, so I'm gonna go back over here. I cannot believe that worked. That was so hard. And we never even created a storage count within it. So this one's called my SDK RG. So what we're gonna do, why does it say store? Oh, because the comment still says that down here below. So just say resource group here. And for all our hard work, let's save that so we never have to look for that again. It's trying to include a lot of junk in here. So I don't want all this stuff. Otherwise, that'd be too much to commit. So I'm going to go here and make a new .gitignore file, .gitignore. Okay. And I want to ignore this bin directory and this probably object directory. No, just the bin directory. Make sure we spell this right. .gitignore. And in here, I'm going to say ignore. I want to ignore package.net bin and then asterisk. So it should ignore that entire directory. If we go over here and we give this a refresh, I'm just going to make sure this is all correct here. There's a lot of stuff in here. I don't think we should be seeing that much. So I'm going to go here and do package.net/obj debug. Because I have a feeling that it's trying to include all of this stuff in here. There we go. And so this looks a lot more manageable to me. I don't know if we want to include this file. This looks like it should be in there. Yeah. I'm going to go ahead and add this code. And we'll just say create an Azure resource group using the C# SDK. If you were able to get to the end here, pat yourself on the back, because that was quite the challenge. If you're just able to watch the video, that's totally fine as well. Here it should commit and push. So I've pushed my code. I'm going to go back over to the repo in GitHub. So we can go back over here. And I'm going to search for Azure. What do we call this? This is under Exam Pro. For you, it might be different. I called it this here, Azure SDK C#. I just want to make sure my code is here. It is. If you are trying to do this and you do not want to struggle, you can go find my code and copy it here. But again, I'm just trying to get you exposure to this stuff. I'm not trying to make you super programmers, so it's not a big deal. We're done with this code space, so I do want to shut it down. And I don't do this very often with code spaces, but let's see if there's like shut down, close, stop. Okay. Here it is, code spaces, stop current code space. I'm going to go ahead and click that. And notice that it is now stopping the workspace. That's going to stop the spend. All right, we're going to go over here. This resource group has nothing in it, but we'll go ahead and delete it. And there we go. We'll go ahead and delete that. And we're finally done. I really didn't think it would take this long, but anyway, we are done. And I'll see you in the next one, okay? All right, so let's take a quick introduction into Azure Resource Manager, which is short for ARM, and is a service that allows you to manage Azure resources. And one thing that really confused me about the service when I first started using Azure was that you couldn't just type in Azure Resource Manager. And the reason why is because it's actually a collection of services, and it makes up what we call this management layer. It allows you to do things like create, update, delete resources, apply management features such as access controls, locks and tags, writing infrastructure as code via JSON templates, And there are very specific features we're going to be looking at that make up the ARM layer. And it's going to be the following. So we're going to be looking at subscriptions, management groups, resource providers, resource locks, Azure blueprints, resource tags, access control, so also known as IAM, role-based access controls, Azure policies, and ARM templates. I don't know why I don't have tenant in there. I might have it in another slide, but it's not a big deal. But that is what we're going to be covering in this Azure Resource Manager section. All right. So let's take a quick look at the use case for Azure Resource Manager. And this is just to kind of give you a visualization because it is an abstract thing. So I just want you to have some kind of picture in your head of what it is. So here I have this diagram. And just to follow up with this tech, think of Azure Resource Manager as a gatekeeper. And all requests flow through ARM. And it decides whether that request can be performed on a resource. And so on the left-hand side, you have your requests. And so requests could be happening in the Azure portal, the Azure PowerShell, the CLI, or the REST client, which would be the API. And then you can see the two middle ones would use the Azure SDK. And in the middle, that's the gatekeeper. And so we have Azure Resource Manager. That's going to work in conjunction with your authentication, which generally should be Active Directory. I don't think you can swap that out for anything else. And then on the right-hand side, you're going to get access to resources. So this could be virtual machines, containers, databases, and storage. There's obviously a lot of Azure services, but that is what it is in a snapshot. So let's understand the concept of scoping, because this is going to help you understand all the components that are involved with Azure's Resource Manager. So what is a scope? A scope is a boundary of control for Azure resources, and it is a way to govern your resources by placing resources within a logical grouping, applying logical restrictions in the form of rules. And so let's now go break down what these scopes are. And so the first scope we're going to talk about is management groups. And this is a logical grouping of multiple subscriptions, just because you can have lots of subscriptions in your account, and you might want a subscription to a collection of subscriptions to belong to some kind of domain. So maybe it's for development or business or data sciences, whatever you want. Then you have a subscription, and this grants you access to Azure services based on a billing and support agreement. So the idea is that when you launch resources, you're going to choose what subscription to go under. It's just going to determine the billing, okay, under that, things you're going to pay for. Then you have resource groups. This is a logical grouping of multiple resources within a subscription. Then you have resources. This is the actual service itself, like Azure Virtual Machine. And I just want you to know that we're going to revisit the scope when we go look at role-based access controls, because that's going to really help it make a lot more sense, okay? But let's just go jump into some of these scopes in specific and talk about them a bit more. So let's take a look at ARM templates. And before we jump into it, let's just make sure we're familiar with infrastructure as code, because that's what ARM templates are all about. And this is the process of managing and provisioning computer-centered data centers, such as Azure, through machine-readable definition files, such as a JSON file. And in this case, an ARM template, because that's all it is, a JSON file. And rather than physical hardware configuration or interactive configuration tools. And just to simplify that even further, basically you're writing a script that's going to set up your cloud services for you. And with IACs, they usually come in two different flavors. We have declarative. That's where exactly what you write is what you get. And imperative. So you're going to generally define what you want, and then the service will guess what you want. It's going to fill in the blanks to save you a lot of time writing those scripts. And so ARM templates are JSON files that define Azure resources that you want to provision and Azure services that you want to configure. And with ARM templates, they are going to be declarative, so you get exactly what you define. They're going to stand up, tear down, or share entire architectures in minutes, and they're going to reduce configuration mistakes. And you know exactly what you have defined for a stack to establish an architectural baseline for compliance. So you definitely want to use ARM templates or IAC whenever you can, and try to avoid using the console unless you're doing development or test workloads. But let's just run through the big list of what you can do with an ARM template. I know this is a big boring list, but let's just get through it as quickly as possible, just so we know what we can do with ARM templates. So with ARM templates that are declarative, so what you see is what you get. You can stand up, tear down, share entire environments in minutes. You can reduce configuration mistakes. You can establish an architectural baseline for compliance. They're modular, so you can break up your architecture in multiple files and reuse them. They're extendable, so you can add PowerShell and Bash scripts to your templates. It has testing, so you can use the ARM TTK to test, make sure exactly what you've deployed is what you wanted. You have preview changes. So before you create infrastructure via templates, you see what it will create, built-in validation. So it will only deploy your template if it passes. Track deployments, keep track of changes to your architecture over time. Policy as code, so apply Azure policies to ensure you remain compliant. And then you have Microsoft Blueprints, which we did cover here, which establishes relationships between resources and templates. So it's just one step further where ARM templates don't have any relationship with the resources, where Blueprints is like a better version of ARM templates. And then you have CI/CD integration, exportable code. So exporting the current state of the resource groups and resources, authoring tools, I believe is the last on our list here. So you can use Visual Studio Code that has advanced features for authoring ARM templates. Makes it a lot easier to write them. So there you go. Okay, so now what I want to do is cover infrastructure as code for Azure. So there are two primary ways of doing infrastructure as code. We have ARM templates. The ARM stands for Azure Resource Manager, and the other one is Azure Biceps. We're going to focus on the first one. Infrastructure as a code is the concept of defining all your infrastructure as code. And that might be confusing because that might sound like the SDK or the CLI. And it is confusing until you start working with it. But the key difference is that when you use the CLI or the SDK to programmatically create resources, they don't keep track of the state. And so that is the key difference between that. Whereas if you ran a CLI command to create, let's say, a virtual machine, and you ran it again with the same parameters and the same name, it would attempt to create a second virtual machine. Whereas with infrastructure as code, if it's already there, it's going to either update it or say, hey, you can't update it. There's already one that exists. So the idea is that it's different in that process or in that sense. There is a word for it. I believe the word is idempotent. I always have a hard time saying it, but that is the key difference between those programming methods and IAC. So what I want to show you is ARM templates. And ARM, again, stands for Azure Resource Manager. It's part of resource groups. So if we type in ARM here, we're not going to really get a service or anything like that. We say Azure or Azure Resource Manager. Okay, you're just not going to exactly get that because it is something that's there, but it really is talking about resource groups. So when you deploy a resource group, it will always create an ARM template for you. No matter if you do ClickOps, you'll always get an ARM template. And this is something that is very different from other providers. So like when you use AWS or GCP, when you launch a resource, it doesn't necessarily will produce a template for you, but Azure is very unique in that sense that they will do that. So what I want to do is I want to go ahead and explore some things with ARM templates so you're very aware of how they work. And I believe that there is a way to deploy. If we type in template here, there should be something like deploy a custom template. Whoops. And that's how you would go about deploying a custom template. And they actually already have some common templates here. So maybe we can take a look at one as a quick start and try to understand what these templates look like. Another key difference between other cloud service providers is that it's not very common to write ARM templates by hand. In fact, it's very tedious and you would not necessarily want to do it as opposed to AWS where you have CloudFormation. Totally normal to do. And that's why having a layer on top of ARM makes it so much easier, like using, again, Azure Bicep or Terraform. But let's go ahead and create a Linux virtual machine here. And notice that I select the template and it has some options here. So what I want to show you here, this looks like the usual process for setting up a virtual machine. But if we go here, we can edit the template. And then it's going to allow us to see what this template looks like. So ARM templates, this is what it looks like. And I believe that they're only JSON. I kind of forget. Let's go ask ChatGPT. So are ARM templates in Azure only JSON, or can they also be YAML? The reason why I don't remember is because I work with a lot of cloud service providers. Usually they'll provide both options, but generally I always remember that ARM templates are only JSON, so there is no YAML support for it, but of course you could use YAML locally and then convert it over back to JSON. But anyway, so if we look at this here, we have some things. We have the schema that describes what the format of this JSON should be. We have some metadata, which probably gets auto-generated or is additional information to attach to the template. We have parameters, so these are going to be values that we're inputting that allow us to make our template reusable. And if we scroll on down, yeah, we got variables, which is probably the modification of parameters. And then we have our resources down below here. And, you know, again, if you've seen CloudFormation templates or Deployment Manager, GCP deployment scripts, these are going to look very, very similar. So we define the type for the resource. We have a name for it. Then it has its properties. And then it can depend on other resources to say what order they're performed in. But anyway, my point is that this is a template. And we can go ahead and actually deploy this template, but I'm not that interested in that part of it because this is not that exciting. What's more exciting is what happens when you do ClickOps. So I'm going to go over here and deploy a virtual machine. Yeah, I mean, we could do a virtual machine. I'm just trying to think what's easier. Maybe we'll go ahead and actually do, I've changed my mind. We're going to actually go ahead and do storage accounts. Again, I'm still in the free tier, and I'm just trying to make things easy for you as well. And virtual machines will spin up a lot of resources, so maybe I don't want something that complicated for this example. But what I want to do is I want to launch a storage account, and then I want to see how we can look at the template, and maybe we'll attempt to re-import the template and then delete the storage account and recreate it. So I'll go here, and I'm going to hit Create, and we're going to create ourselves a new resource group. I'm going to call this resource group my ARM RG, so ARM for Azure Resource Manager. And today it's really thinking. I don't know if I'm having internet issues here or if it's just really complaining or if Azure's slow. Azure's sometimes their UI is not always responsive. And we have to give this a name, of course. We have to make sure this is very unique. So I'm going to say my storage account, and a bunch of numbers, and then my initials. And it probably has too many letters, so it's complaining. There we go. And I'll just let it choose whatever region it wants. We'll have it on standard. That's totally fine. I'm going to go ahead and go to review, where we can see all of our options. Looks fine to me. We'll go down the bottom, hit create, and we'll give it a moment here to create. So I'll be back in just a second. All right, so that deployment is complete. And what I'm interested in is checking out the resource group. But notice that when we've deployed this, we have our inputs. It shows us what we've inputted. And we looked at the parameters of a template before. So it is creating literally an ARM template and then inputting the parameters. It's showing us the outputs of that ARM template. And then here's the template itself. So every time you deploy Azure resources, it is creating these IAC code for you. And that is one of the greatest advantages of Azure. As much as I complain about Azure, this is one of their really, really good features. And there's a few things you could do. Like it looks like we can add this to our library. We can download this. We can deploy it again. Let's go ahead. I usually don't fiddle with these too much, but we can import this template. And I can say my resource group. But just remember, you could have a lot of resources and really make that retemplated. I'm going to choose the same area here. And this will just be version 1.0.0 down here. I'm going to go to next. It shows me the template. Next. We can do some tagging. I'm going to ignore that for now. Review and create. And so now we have our own template. So that's kind of cool. If we go back to here, I'm not exactly sure where they, we have to hit create maybe first. It's not super clear, but so that is now, template has been saved, but where did it save to? It just says it's a template spec. It is really taking its time to load here. Okay, and so we have our template here. I'm not sure if we typed in templates here, if they'd show up here. I guess they show up under template specs. We'll refresh this. Not sure why it doesn't show up. We know that we created it. And, you know, I've said this in other videos where Azure doesn't always propagate things right away and you have to wait. So you have to have confidence in waiting for things to show up in Azure. So even though it's not here, I know I created one. Okay, so we go over here. It says template spec succeeded. So it really, I think it would show up here. And I really want to prove that it will show up here eventually. So what I'm going to do is just take a break. And I'm going to give it like 10, 15 minutes. I'm going to give it a good chunk of time here. And we'll come back and see if it appears. Just to give you validation and confidence that patience always pays off here in Azure, okay? All right, so I've waited a good chunk of time. I was just talking to Bako. And so I'm back, and let's see if it is here. We're going to give a refresh. And look, it's here. So I told you, you got to be really patient with Azure. It is really known for being slow for some particular resources. And when I say some, I mean a lot. So, just have that patience there. But anyway, what I want to do is I'm going to open up another tab. We're going to go back over every time I open that new tab and wants me to log in. That's great. But what I want to do is go over to our resource groups, and we're going to go into that new one that we created. And what I want to do is I just want to delete this resource here. And I want to see what happens if we attempt to redeploy our template there. I assume we're going to have to... we don't have to delete this one, but I just want to remove it completely and just try utilizing an ARM template. So we'll give it a moment there. And notice we have an upgrade button. This is definitely new. We might be going through I'm not sure why it's appearing all of a sudden. I've actually never seen that button before, so it's really interesting. And nope, I guess it's just maybe after a while they just kind of poke you. And over here we're getting our prompt. So it looks like we're starting to get some spend. And, I said earlier that Azure is really good about telling us about alerts and things like that, much better than other providers. And so, here it's showing in Canadian dollars that we've already consumed half our spend. Not sure how I did that because I haven't really done a whole lot. But what we'll do is we'll try to figure out where that free spend has been going. Still, again, that's a lot. So maybe it's overestimating that, or I left something running. Maybe that Kubernetes cluster is still running. I don't think so. Let's go double check. But anyway, I wanted that to happen so I could go back and show a video of that kind of stuff. Because all we created is a couple of virtual machines and some other things. Yeah, we don't have anything else running that should be costing us spend, but we'll go take a look there and see what we can figure out. So anyway, I'm going to go back here, give this a refresh. And that resource is gone. What's interesting is it also got rid of the template. Why did it get rid of the template? that was something we created separately. And so I guess it was linked to the resource group, and so that kind of defeats the purpose of us uploading our ARM template. So that's a shame. I guess what we could do is we could go and, I don't know. We could go and use the custom provider and launch a template, but there's not much interest in that, so I'm not really interested in doing that. Yeah, I think we're pretty much done here. I think we've proved the point that Azure is really good at producing these ARM templates. You're not going to want to write them by hand. You can ask ChatGPT to do it, but I would probably not do that myself. But I think that satisfies this video for ARM templates. So we'll see you in the next one, okay? All right, so we looked at utilizing ARM templates, and I think it'd also be really great to look at Azure Bicep. Because that is a more productive way to write infrastructure as code. And honestly, I really like Azure Bicep. I think it's really cool. So what I want to do is I want to go ahead and go over back to GitHub. We looked at creating a GitHub or creating a repo in GitHub back in our SDK video. That was a really messy video. I'm really hoping that it's not as crazy as that one, but I don't like editing out any of the challenges here because I want to give you the full idea of what it looks like when trying to work through these things. But what I'm going to do is go over to GitHub, and you should, of course, go ahead and create yourself a GitHub account. It has a free tier. And once you have your GitHub account, we'll make a new repo. I'm going to drop down here and go to Exam Pro. And, of course, you'll just have one name here if I have multiple accounts, so there's a lot for me to create stuff in. And what I'm going to do is make a new repo called Azure Bicep Example. You can call yours whatever you like. I'm going to make this public so that you can see the code. You can make yours private if private is available to you there. But I'm going to make it public because if you want to go find this repo at ExamPro Co. here and copy it and work with it, you can. So we're going to go ahead and use CodeSpaces, and CodeSpaces does have free credit usage. You could do this locally. on your local computer, but you'd have to install a bunch of stuff. I like using cloud developer environments, and Azure does not have one built into their portal. Most other ones do, but I think the reason why Azure doesn't is because Microsoft owns GitHub, and so you could just go over here and use CodeSpaces instead. So this, to me, is like using Azure, okay? So we're going to go ahead and create a CodeSpaces on main here. And understand, as long as the CodeSpace is running, we are consuming. So if you want to stop it, you could always go up to the command palette here, and we can just say stop, or it's CodeSpaces. There should be something here called stop, shut down. I did this the other day when we did that. Yeah, it is CodeSpaces. Whoops, it's loading, so it's bumping things out here. But if we go CodeSpaces, there is an option to stop the current CodeSpace. So I'm not doing that right now. I want my theme to be dark, so I'm going to go to this cog down here, go to themes, go to color, and we'll switch to GitHub dark. And we'll give it a moment to think because it's a bit slower loading. I greatly prefer Gitpod. The reason I'm using CodeSpaces is because the extensions are going to use the official ones with Microsoft, and it's just going to be easier to show you this here. In most other courses, I use Gitpod. So anyway, once that is loaded and we changed our theme, if that matters to you, we're going to want to do some Azure Bicep stuff. So on the left-hand side, I want you to go to extensions, and we're going to search Azure Bicep. I don't use Azure Bicep a lot, but I definitely know how to use it when we need to. So I know they have a really good extension for it, and it's like it writes code for you. It's the nicest experience I've ever had with an IAC tool. And this is the thing, because Microsoft built Visual Studio Code, and they own GitHub, they can have really amazing synergies for developers. So a lot of times I find it easier to work in VS Code and use their extensions to interact with Azure than it is to use Azure portal itself. And there are specific services like Azure Functions where you really have to use Visual Studio Code. So it's essential that you get used to using Visual Studio Code, whether it's local or in a cloud developer environment. So I'm installing this Azure Bicep extension, and this thing will help us write a lot of code. And it has like templates and other stuff like that. So that's what I want to take advantage of it. I don't remember the extension for Azure Bicep file, so we'll just go to the Azure Bicep website. I'm sure they'll have like a quick start, and we'll work through it here together. So I want to go here, and I just want to know what the extension is. It's .bicep, so that's what it is. So we're going to go here and make a new file. We're going to call it main.bicep. And something we didn't do before, and this is what I wanted to do in the SDK one, but we didn't actually have a use for it, is there's probably like an Azure like kit, Azure tools. There we go. And this is something you might want to install. A lot of these down below here, see how there's like one for databases, resources, functions. If you install tools, it installs all these other ones. Even have one for CLI tools. And it's possible that, see, like this one will autocomplete Azure commands. It'll do all sorts of fun stuff. Even for Azure storage and everything, there's something. But the reason we want Azure tools is because we can install Azure accounts. And this will allow us to quickly log in to our Azure account. Remember before we typed in AZ login, and then we had to get a device code and plug that in? Well, if we have this installed, we can just use the command palette and log in very quickly. And that's what I want to do here. So I'm going to go to the bottom left corner. I'm going to pull up command palette, and we'll try to do Azure sign in. Now, to be fair, I mean, this is not going to do much difference down here, but I think it installed the CLI for us. Because before we had to manually install it, right? So we'll go here, and we're going to have to choose device code. We have sign into Azure Cloud. Let's try this one first, see if that works. And then we're going to say, just so you know, Azure has different ones. There's like Azure China, Azure Germany, Azure US Government. So generally, we always want to choose Azure unless you live in one of these other regions, and you have to use that one. And this is going to open up, and we will sign in. We can now close this window. And I believe we are now logged into Azure. Also notice on the left-hand side, we have this little Azure icon here on the left-hand side. It will allow us to see our resources. We can also sign in from here. We should be signed in. Maybe it didn't work. I'll try this one more time. The extension Azure Resources wants to sign in. We'll say allow. Maybe it has to sign in separately. I don't know. We'll close this. There we are. So now we see our subscription. We are in here, which is great. And we can see a bunch of our services. So, if we had storage accounts, and we do have some storage accounts, we can see them here. This one, I think, is for our Cloud Shell. That's why it starts with CS and it has a random number afterwards. If we had virtual machines and other things, we could see them here. But yeah, working with functions, you often use them here. We could also probably right-click this and create a resource. And so here, there's a lot of ways to create some stuff. We create a resource group and some other particular things. But yeah, that's interesting. I also wonder if these are obviously things that were installed. There could be other extensions that we didn't install, like Azure Machine Learning Service or other stuff that could end up showing up there on the left-hand side. So I'm just kind of scrolling through here and seeing what might not be installed. So Azure Container Apps was not installed. Or maybe it was, and it's these other ones that have these little install words on here. But anyway, enough about that. Let's stay on track here and let's write some Azure Bicep. So now that we have that installed, we want to start writing it. So I just need to see a little bit of code to get a reminder here. So yeah, if we start typing, it should start suggesting, and that's just what we want to do is make a storage account. So let's go ahead and start typing that in. So I'm going to type in resource. And so already notice that it is auto-completing. And then let's just go check here. So the next thing is going to be storage account. And it should autocomplete. So yeah, I remember this being really good at autocompleting. Just give me 2 seconds and let's go figure that out. 1 second. Yeah, so I'm looking at it here and it's supposed to just start autocompleting when we type. So I'm not sure why it's not exactly doing that. We'll go back here. Sometimes Visual Studio Code doesn't do what we want it to do, which is totally fine. Storage account. And it's not really auto-completing. So I'm going to go ahead and save this for a second. Well, there it's auto-completing. So resource, storage. Am I typing it wrong? Is it supposed to be with resources? No, it's this. So it's really interesting that it's not auto-completing, but we could just copy this in here. Okay. I just wanted to show you how powerful it was because I was so impressed the first time I saw it writing all the code for me, which is not what the other ones do, that's for sure. So we'll just paste this in here. And I put a period here. Yeah, I guess I was expecting a little bit more from it, but whatever. I guess we'd have to work with it a bit more to find out. Again, I don't work with it every single day, but I am always very excited to use it. But the thing that I want to take a look at is let's look at where the actual reference documentation is. And so we'll go to resource reference here on the left-hand side. And I'm really interested to see where everything is. So if you know the resource type, you can just type it here in the left-hand side. That's fine. So we have all our resources here on the left. And so we are trying to create a storage account. So we can go over here and look for storage account. So that'd be storage and storage accounts. And so here it says to create a resource, add the following to your Azure Bicep. So just kind of getting familiar with it. It looks like this is going to be its logical name, and this is actually going to define the resource itself, and these are all its properties. And it looks like there are some that are required and some that are not. So it looks like, I think, that if we can find this tab back, I think we can name this whatever we want here. This doesn't actually have to be called storage account. So we can go here. It's just a logical name that we reference within this resource. So I can go here and say like storage account AB. It shouldn't matter. What's really interesting up here is that it's going to, looks like it's going to grab the resource group ID, and then what does it do here? It creates a deterministic hash based on the string. So it uses the resource ID to make a random string, and then it's going to say toy launch in the front of it. So I don't want toy launch. I'm just going to put in here bicep. And so I think we can do hyphens. Actually, I don't think we can. And so we should get an Azure storage account that's going to be bicep and some random value after this. And then up here, this is going to pull in the resource group. Now, what's interesting is we haven't created a resource group. It says return the current resource group scope. So I'm not sure how this is going to work if we don't have an existing resource group. But anyway, we've written our Azure bicep, and we probably want to go ahead and deploy this now. So we could probably just type in bicep down below. That's probably what the command is. Nope, that's not what it is. Maybe it's, what is it? I don't know. So let's go over to, back over here for a second, and let's see what the CLI commands are. Oh boy, we'll say bicep CLI. What is the commands? Just tell me what the commands are, please. We could use the command palette because they're probably all there. Like if we were to go into the command palette and type in bicep, like we get all those commands, but I really want to know what the CLI commands are. I really thought it would be bicep. It is AZ bicep, of course. So it looks like we can do AZ bicep and then just specify the template. Probably main is the default, so if we do nothing, it probably will pick that up. But I'm gonna go ahead and type in that. And so it's interesting, we installed the extension and we were able to log in, but we still don't actually have the CLI. So it looks like we do actually have to install the Azure CLI in here, which is fine. It's always great to get more practice. So we'll go ahead and type in Azure CLI install. We'll go to the Microsoft Learn website. We will scroll to Linux. We'll go to Ubuntu Debian because that's generally what Gitpod or Codespaces or what have you will be using. We'll go down, look for that one-liner, and we'll copy it. We'll go back over to Codespaces. We'll paste this in, hit enter, and that'll go ahead and install the Azure CLI. Now, we are logged in this in Visual Studio Code, and it could be storing the same credential files wherever on the local machine. So maybe we don't have to necessarily log in twice. It might be also interesting to see where that that file is. So maybe we can go ask ChatGPT, okay, so when you log into the Azure CLI, where does it store the credentials? What folder and file on the Linux machine? That's what we want to know. And the only thing I don't like about ChatGPT is that you can't go away from this tab while it's generating. And then sometimes it just gets a bit slow, but it goes out to the internet. So I think that's the reason why it's been slower than previous. I like previous models where it wasn't out on the internet because it could generate out faster. But yeah, this one's hanging on me. So let's go to 3.5. Let's just ask this one. I want it fast. Okay, so it's saying it's in the Azure folder. So that's something that we might want to take a quick look at. The Azure CLI is installed. I'm going to just type in AZ account list and see if we can list our accounts. Okay, so we are not logged in. So us logging in here, wherever it's storing, it's definitely not storing in the same place. But let's go take a look at that Azure profile directory. So I'm going to bump up the font a bit. I realize it's really small. And I'm going to go ahead and say cd and then make a tilde. That is above your tab key, and you have to press shift to make it. It's called a tilde. It's like a little squiggly. We'll do a /. I'm going to do period for a hidden folder, and we're start typing Azure. And so that folder is there. We'll hit enter. I'm going to do ls to list out the contents, and we have stuff here. I can do ls-la to list it in a nice, beautiful list. And if we don't want, no, that looks fine. And so I'm kind of interested where it's storing that configuration, probably in the config directory. So I'm going to just cd into config. Oh, maybe it's not a folder. I thought that was a folder. It is not a folder. Okay, so let's do cat to print out the contents. Cat stands for concatenate, I think. And so that doesn't store it. Does the AZ JSON file have it? Nope, that doesn't have it. But to be fair, we haven't logged in yet, so maybe the file will appear after we log in. So that's okay. What I'm going to do is go ahead and type in AZ login, and we'll say use device code, because I believe that's the flag we have to use. And we'll go ahead and copy this link. We'll go to the top here and paste it in to one of our available tabs. We have to go back and provide this code. And we'll go click next, and we'll click on our account. We'll say continue. We'll go back over to here and we'll give it a moment to think. There we go. We are logged in. So now what I want to do is type in ls, and it looks like there's more stuff there. It looks like there is. And did we have this before? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's definitely more stuff here. The new thing that's here is clouds config, so I'm just going to cat that. Let's see what's in there. So it at least tells us this is our default subscription, so we at least know where that's coming from. Let's cat the config. Let's see if anything's changed in there. That's the same. Let's cat JSON. There's still nothing in there. So it'd be really nice to know exactly where it is. Normally, other ones will tell you exactly where they are, and you can literally open them up and see the information there. I guess we could also just cat out the session. No, nothing. So anyway, it is stored somewhere. Where it is, I don't know. Does it really matter? No, but it's nice to know exactly where it is so that, let's say you wanted to delete it off your computer or something, but it's stored somewhere. Anyway, we should now be logged into Azure, so we'll go ahead and type in Azure AZ-bicep. I still feel like it should have told us the commands even if we weren't logged in. And I was hoping that it would print us out the subcommands. Let's try to do help and see if it actually does that. Okay, so it does. You just have to give it the help flag. And so we have a few options. We can do build a bicep file, build the bicep param file, decompile. So if we already had an ARM template, we could turn it back into a bicep file. That sounds really cool. I like that idea. Format a bicep file. You know, if there's something wrong with it, it could tell us if the format's correct. Install the bicep CLI, which I thought it already was installed. Let's go ahead and try that first, because maybe that's why I couldn't just type in bicep. Okay, so now what happens if I type in bicep? No. So why did I install it if it was already like that? Bicep. I'm hitting tab to autocomplete to see if anything's there. Bicep CLI. Well, whatever. I mean, we kind of still already have it, so that's totally fine. So we'll go ahead and type in bicep AZ bicep build. And it wants a file, totally fine. So we're going to give it a file. Build a file, and print all of its outputs to SDOut. I don't think it matters if we print them out. So before we do that, I just did Control-C to break that. We need to get back to our main folder. So I'm doing cd ... and I'm doing ls. Where is this folder? cd */ I'm so used to using gitpod, I can't remember where this directory is. I'm just going to scroll up here and take a look. It is workspaces. Okay, so to get back to this folder, okay, we're going to go to cd / workspaces. I'm hitting tab to autocomplete, and then this one's called Azure Bicep. It is really not autocompleting here today. Oh, I spelled Azure wrong. Okay, that explains that. I'll go fix that in the gitpod. I'll just rename it. But now we're back into here. So typing clear. So we're going to go Azure Bicep file, and we're going to provide it main TF, or I'm thinking Terraform bicep. We'll hit enter. And so that's going to go ahead and build it. Is misspelled or is not recognized by the system. Okay, we'll type in ls. I mean, it's right there. Let's go back and take a look at the documentation and see what it wants. Sometimes it might want like the file information, but I don't think so. It just shows main bicep. I'll copy this command. Oh, I forgot the word build up here. That's why. So it looks like it's now built. And so we now have a main JSON. We'll take a look here. And it's generated us an ARM template. At least that's what it looks like. Yep, that's what it is. So that looks pretty good. I'm noticing that, yeah, we have parameters up here. So now we can go ahead and deploy this. So it builds it. See here, we can build params file. Not interested in that. Generate params. And install the commands to your CLI. Oh, publish, maybe that's it. The publish command adds a module to the registry. The Azure Container Registry exists. I'm not sure if that's useful. I think that's if we want to reuse a template for later, kind of like how we had those template specs, I think. Okay, so if Azure Bicep just generates out the files, I'd imagine that we just probably deploy it the regular way using ARM templates. So I'll be back in just a moment. Most other IAC tools, like they'll let you build and deploy, but maybe Azure Bicep just compiles out templates. Just give me a moment. Yeah, so I just quickly asked ChatGPT, and yes, it did confirm it. My suspicions were correct. Azure Bicep is just generating out the resource template, and it looks like we're going to have to deploy it the regular or old-fashioned way here. So now here's a question. Could we actually use Visual Studio Code to deploy this? So if I right-click this, could we deploy somewhere with this? So that's what I'm really curious about. Let me go find. All right, so I believe there's a few ways we can do this. Of course, we could go and just deploy it the old-fashioned way by using this AZ deployment group. I was looking around myself, and I just typed in Bicep here. And I also noticed that they had a deploy step. So maybe it can do a direct deploy, maybe not through the CLI, but maybe it can do it through Visual Studio Code. There should be one for ARM templates in here. It's not showing up. I mean, ChatGPT seems to think that it can, but maybe there is another extension we're missing. So let's type in Azure. So we have Azure Tools. Is there one for developer? Let's go back here and take a look. So there's one here. It says Azure Resource Manager. Oh, it's an extension. Well, I thought that'd be installed already. Then that would be a really useful one to have here. So we'll say Azure Resource Manager. I thought it was there, but I didn't see it on the side. So this seems like a really good plugin. This is probably something I'd want to have. Let's go ahead and install this one. 1.5 million views. Yeah, I believe so. It's by Microsoft. I'm surprised it doesn't get installed with the tools. Oh, it's in preview. Okay. So I imagine when this is out of preview, I bet when you install Azure Tools, it will be installed there. Now, I've said previously, if there's a preview tool, you should try to avoid it because it might not be there in the future. This one, I think we can kind of get away with utilizing it. It might be the future and it's no longer in preview. So we'll go back over to here. And do we have any changes here? No, but if we go into our command palette, let's type in ARM deploy now. It was saying that that's something that we could do. Azure Resource Manager. Install this extension. Type in ARM deploy in our command palette. We did that. Yeah, so it doesn't show up. So, preview feature. ChatGPT might be telling us something else. We are using 3.5, so it might not be telling us the full truth there. And I don't really see any changes on here, so I guess we're not going to worry about that. But I would like to try the Bicep deploy. So we'll type in just deploy here. And scroll on down. We have deploy Bicep file. Let's see what happens if we do that. And so please enter the name of the deployment. Sure, we have to name the deployment. Good. Create a resource group, because remember that we didn't specify a resource group, so we'll have to create one on the fly here. So let's do that. We'll call this my Bicep RG, RG for resource group. It's now going to go ahead and deploy that. It says deploy failed. Provider's description does not have the resource type resource groups. Okay. That is something I was not expecting. Let's go ask ChatGPT and try to save us some time. So it says check your Bicep template file, ensure that you have defined the resources correctly. That is not useful. Maybe it's because it's not registered. So maybe when we use the UI, it will automatically register things when we use it, but we create resource groups all the time, so it's kind of surprising if that wouldn't be registered. So we'll go over to our subscription, And I'm just going to double check this here, but I'm not sure if it's going to make a difference. We'll go over to our, we're in our subscription. I'm looking for providers. There it is, resource providers. Sometimes there's like another extra blade. They call these blades over here, by the way. And so I was getting a bit confused. And so ChatGPT is suggesting maybe resources is not registered, which to me seems crazy. Oh, it is. It's right there. So I'm not exactly sure what it's complaining about. The other thing is that maybe Azure Bicep isn't logged in. So, I mean, that seems like a possible option. So maybe we'll just go stick with the usual way, which is using the Azure, this Azure deploy method. So I'm going to scroll back up here, and we have this command. Now, we did install in here in extensions, or I think it came installed, was the Azure CLI. And what that will do is when we write it out Azure CLI commands, I believe it will autocomplete for us. So here's scrapbooks for developing and running commands with Azure CLI. Create an Azure CLI files and use the following features. Oh, okay, so there's actually a thing called an Azure CLI file. That's new to me. But what we'll do is we'll go ahead and we'll just say new file. So we'll just say commands, and I'll just put that there. Rename that like that. That's what it's saying to do. And so we'll say deploy an ARM template, and we'll go back over here, and we'll see if it starts to autocomplete. So we have AZ deploy. It's not really completing correctly. It's just demonstrated. We'll go back over here and take a look at that again. So yeah, this one says demo.azcli. They're making a comment. So IntelliSense for commands and their arguments, snippets and commands, scrapbooks for developing and running commands in the Azure CLI. Okay, then work properly, please. Maybe it's not installed. Oh, we have to install it. Sorry. I thought we already had it installed. That's why. So we'll go back over here. And so now our comment is showing up. So we'll type AZ deployment. I mean, we probably want to create, right? It will have to have a name. So we'll just say my RG, my bicep deployment. We'll probably have to have a location. So let's just say, probably should place it in the same place as this one. This does not have a particular location, so probably default to wherever the resource group is. Yep. So let's say it's East US. There we go. There's probably something else we need. I'm not really sure. Let's go back and see what ChatGPT was asking for. The template, of course. We'll say template, and it technically is a file. So we'll go here and say main JSON. And by the way, we could bring these down onto new lines with this backslash. That allows us to have multiple lines in our bash terminal. Okay. And it also probably wants the resource group. So we'll go here and type in resource. It can't do multi-line. It is not auto-completing anymore. Resource group. Maybe we just hit the limit of it there. So I assume that it could handle multi-line, but I guess when we're doing multi-line, then the IntelliSense, the auto-completion, it can't handle it. So we'll go back over to here, and I just forgot what we called that resource group. We actually did create one, but Azure Bicep did fail the deploy because of some kind of permissions or settings. So I just want to go quickly find that name. Again, notice that sometimes in Azure, you have to be patient. Super, super, super common to wait around for Azure because of propagations in their UI. Super common. My internet's totally fine. It's Azure. And it's back here. It says, an error occurred when trying to fetch resources. Additional details from the underlying API might be helpful. Are we having an issue with service? So sometimes that happens. So we could be like Microsoft status page. Sometimes that happens and I got to walk away, come back to my computer. But maybe it's not because my internet seems to be funny. So, but if that's the case, then, oh yeah, it's me. I'll be back in a moment. Okay. All right, so my internet should be back here. I'm just reopening my connection here to my code spaces. And I'm going to go back over to here and we'll give it a refresh. And so I guess that resource group did not create. So we do definitely have to create a resource group first. Otherwise, it's not going to know what to deploy into. And I'm hoping that this reconnects or it's still running. So, but what I'll do here while we're waiting is I'm going to create a new resource group. I'm going to call this one my bicep RG. And we'll go ahead and review and create. And we'll go ahead and create that. We'll go back over to our other tab here. I would really like it to reopen here. I'm not sure what it's doing to figure this out. I'm going to go at the top and just type in github.dev. That's the primary site for these developer environments. So I'm hoping that it'll list the other ones. That's what Gitpod normally does. It seems real mucked up here. So I'm going to have to go back and we'll just have to type in bicep here. It's under Exam Pro, so I'll drop that down. Of course, you'll only have one. So we'll go into here and let's see if I can find that that previously working code space environment. So it's here, it is active. I'm going to go back and say open in the browser. Notice you can launch this in Visual Studio Code locally, or if you want to use Jupyter Labs, let's say you're doing something with AI or something, or machine learning, you could do that. So this should open back up our environment. There we go. That's great. And so we created that new resource group that's called this here. So I'm going to go ahead and copy that. And I'm going to paste it into here. Sometimes it's good to put double quotations around these things. I'm not doing that unless that gives us problems. So I think this is everything we need. We need to know the resource group. It's probably recommended to provide it a name. We'll have our location and our template file. So I'm going to go ahead and copy this and fingers crossed this works. Of course, we didn't really look anything up. Oh, this one says AZ deployment group create. So maybe we should make sure that's correct. But it did autocomplete create. So maybe that's okay. Well, wait, why is one deployment group? Wouldn't that create, hold on, we can hover over here and get some stuff. Manage the Azure resource template deployment at the resource group. Okay. Oh, that's really cool. If you hover over, it tells you everything there. Well, what happens if I take this name out then? Does this still complete? Starts a deployment at the subscription scope. So maybe both works. Let's just see what happens. It's really nice that it shows everything like that. I really like that. We'll go ahead and paste that in. We'll hit enter. And it's showing we're missing an argument. Resource group arguments. It doesn't like that one. Starts a deployment, creates a deployment, the resource group. Okay, so here we have a create, and then we have starts a deployment, the subscription scope, creates a deployment at the resource group from a local file template. So it looks like if we already have one, maybe this one would have created a resource group for us. So what we're going to do is take this one out, as I really thought we needed to have it, but I'm going to go and see what happens if we do this. The template resource location at line 12, line 17 is invalid. The template function resource group is not expected at this location. Okay, it's not there. I didn't put it in the template. So, okay. Well, what I'm going to do is undo and type in group. So I guess you got to be really careful when entering stuff in because it's going to give you some trouble. And this one looks a little bit more normal with the group create. So we have template file, resource group. I don't know if it needs a name. So maybe I'll just take the name out and then we'll try this one. And we'll hit enter. And unrecognized arguments, no location. Well, I mean, this one has it and this one doesn't. Okay, we'll take the location out. We'll try this. Well, I guess we don't have to specify a location because we've already created the resource group. That's why. So we'll try this again. Making a lot of trouble here. But it's a good way to learn. This is how you should learn, and this is what cloud's like, just goofing around till we get it to work, and then hopefully it's the right way. So this is going to go ahead and run, and we'll wait here. I'm not going to make you watch it here. I'll be back here in a moment, okay? All right, after a little bit of waiting, our terminal has produced some stuff for us, so it's suggesting it probably created the resource, so we're in good shape. Let's go back over to Azure, and we're going to go into our bicep RG, and we now have our resource. So we've successfully used Azure Bicep. So let's go ahead and delete this resource group. We are all done here. We're going to go ahead and commit what we have so that any future folks that are trying to do the same thing as us can just go get that code base. Good stuff here. We'll go ahead and hit commit, sync the changes. We'll say OK. That will push the changes. Excellent. And I'm going to want to stop this workspace. So we'll open up the command palette. We'll say stop. So say code spaces stop, code spaces stop current workspace. There we go. And that will stop the current workspace. So that is all good right there. And I'm going to fix the name here because it really should be named correctly so that you can easily find it in the future. Just be more patient and make sure you don't make mistakes and try to fix them the best you can. But yeah, that is Azure Bicep, and we'll see you in the next one. Okay? All right, so we are back. We showed you how to utilize an ARM template, Azure Bicep. I want to show you another way to do infrastructure as code that's very popular, and it's with a third-party technology called Terraform. Super popular because Terraform can work with every single cloud provider, and it's simply the most popular IAC tool. And it doesn't get a whole lot of attention with Azure, so I figured we should throw that in here because you're most likely to encounter it on the job, as Azure Bicep and ARM templates aren't used as much as Terraform, surprisingly. So what I want to do is go over to GitHub, and we're going to make another repo. If it will let me see where that button is. Sometimes it's a bit funny, so I'll go to the top right corner, create a new repo. There's lots of ways to create repos in here. I'm going to go to Exam Pro. I'm going to make sure I type Azure right this time. We'll say Azure Terraform example. I'm making mine public. You can make yours private. Again, it's better for you to make it private because that way you won't expose information by accident. And not sure why this looks a little bit different. Maybe GitHub just changed something on me, but what we'll do, because there used to be like a code button here. Maybe because I didn't create the README, that's why. Normally supposed to have a README. I'm going to go ahead and just click that button to create the README. Commit that. And oh, unexpected. What are you talking about? Well, now it is here, so I think GitHub is just having some hiccups. Anyway, we have a code button here. We'll go ahead and create our code spaces. And we'll launch that up. And we're going to have to go install the Terraform CLI. So I'm going to look up Terraform CLI install. And we'll go to the HashiCorp website. HashiCorp is what makes Terraform. And somewhere in here, they'll have one for Linux. We'll go over here. And we need to follow these commands here. Very straightforward. Not a one-line command, but they have additional commands here for security purposes. So this environment's open. Let's go to the bottom left corner, and we'll pick out a nicer theme. We'll choose a GitHub Dark. I'll just bump up the font a little bit. And we'll go back over to here, and we'll copy the installation commands. So we're copying the first one here. We'll say allow. Okay, we'll try this again. And it is not letting me copy paste. Sometimes you got to go up to this clipboard, make sure it allows. It is on continue. Copy. Right click, there we go. And this is going to install. Usually it's good practice to do an update on your packages. We didn't do that for the Azure CLI, but very common practice on Linux to do that. So that's what they're doing first. Then we'll go over here and we will grab the GPG key. GPG is a security key that does something. This output is normal. You should be seeing this. Why it prints it like that, I don't know, but I know it's okay. You can ignore it. We will paste in the next one. And that one was weird. That didn't look right. So I'll try this one more time. Paste it again. Hit enter. Oh, I had to hit Control C. When you see this, like this here, it usually means it's expecting more input. So I had to do Control C on my keyboard. That's when that shows up. So I'm going to try that one more time. I think what it did was when I hit up, it brought in that stuff. So we'll go back over here. I know it's a bit finicky. It's a bit frustrating. And so this looks normal. This is what I want. It's confirming the key. So so download the key and then verify its fingerprint. And then the next thing we can do is this will install the source for HashiCorp, so it can actually install the package. And notice that sometimes when you copy paste, you get some funny stuff. So you got to be really careful with your copy paste. Okay, I'm just going to type clear here. I'm going to try this again. Copy, right click, paste. There we go. Okay, so now it's acting normally. You know, I've been coding for 20 years and copy and paste gets me all the time. It's not much you can do about it. Now we can go ahead and install it. So I know that's a lot of steps. We probably could have just ran this and it probably would have worked. Okay. Also notice here, it accidentally downloaded this weird file. I'm going to go ahead and delete that. Not sure why it did that, but make sure you don't end up with junk files by accident. So now Terraform's installed. So Terraform, the way it works is you have the Terraform command. We hit enter here. I recently did a Terraform bootcamp, so Terraform is fresh in my mind, whereas you notice Azure Bicep was a bit more rusty. But we'll go ahead and make a main.tf file. That is how we create a Terraform file. We'll go to extensions on the left-hand side. There's probably a Terraform extension. And here is one. There's this one and this one. This one is by Anton, and I know Anton. He's super nice. And then we also have the official one. We'll go with the official one here today. Sorry, Anton. Don't get upset with me. They're both great. I just chose the official one for this video demonstration. Anton maintains the Terraform modules for AWS and a lot of other stuff. So he's very good at Terraform. But now that we have this installed, it should give us some syntax highlighting and auto completion. And so what we need to do is we need to get some code. Now, the reason I like Azure Bicep is because it really does generate everything in place. But with Terraform, you have to do a little bit of work. We're going to type in Terraform registry. And this is where we can find everything. So here it's the registry.terraform.io. And we're going to go to providers. Providers is our established connection to our specific provider. We're going to choose Azure. And in here in the top right corner, they have this purple button, and it's going to give us the code that we need to start working with. We're going to go ahead and copy this. And we're going to go over here, back to our code, and we'll paste it into our main TF file. So what this is going to do, it's going to say install the Azure RM provider so that we can interact with Azure through Terraform. And then we can configure Azure down here below. Normally the way it works for configuration, if we go to documentation, it'll tell us on the first page, how do we establish a connection? So we can authenticate using the Azure CLI, which is something that we have done. We can also use a managed service or a service principal. I mean, the Azure CLI is the easiest way to do it. At some point, you will have to learn how to create a service principal. So I kind of want to do that. Like that's kind of what I'm preferred to do at this stage here. But I have to make sure that this makes sense. So service principal and client secret. So this would be with a password. So let's click into this one. And I'm just trying to see where the syntax is here. I'm just looking at the code. So first log into here, create RBAC. No, I'll just do it the easy way. I won't make it too complicated for everybody here. I'll just use the Azure CLI. So what we'll do is we'll need to go ahead and install the Azure CLI. So you probably know it by this routine now. So we'll go Azure CLI install, and we'll go over here, and we'll go down, and we'll go to the Ubuntu Debian, and we'll scroll on down, grab the single line, go back over to code spaces, which is here. We'll drag this up. We'll go ahead and paste this in, and we'll hit enter, and that will install us the Azure CLI. Won't take too long, but it will get installed here in a moment. And so I'm thinking that if the CLI is installed, it should automatically, or it should already know how to deploy. So while that is installing, let's go back over to the Terraform registry, and we'll look at trying to launch something in Azure. So if we click back and we go back to the documentation, it has all the resources here on the left-hand side. So we've been doing storage accounts quite a bit here. So I'm just going to look for that on the left-hand side there. So we'll type in storage here, and we'll go into storage. And in here, I'm looking for a storage account. So it's right here. And we have some example code. So this is going to create us a resource group and then a storage account. So we'll copy this code and we'll bring it on over to here, and we'll just paste it on below. I'm going to have to jump this down a couple sizes here so I can see what I'm doing. And so we'll paste that on in there. And so now we have our resource group with a logical name of example. I'm going to rename this to be something other than this. So we'll say my Terraform RG. I don't want West Europe. I want something in North America. West US? Is that what it would be? I'm not sure if this will actually autocomplete for me. If it messes up, it'll throw an error. We need to give this a name, so we will provide some name here. We're not doing complex Terraform. Of course, you can pass in parameters with separate files and variables. We didn't do that with Bicep either. That's something we would do at a more advanced level. But let's go ahead and change this name here, and we'll put something else in. So we'll say my storage account, a bunch of numbers, and then AB. Okay, so this should work. Replication doesn't need to be on RGS, but that's still fine. It's a standard. That's fine, I guess. We have some tags. We don't need tags, but that's fine. So now what we want to do is go down below here, and we'll have to do an AZ login. Sorry, I meant to say AZ login -- use device code. Okay, and so we'll have to go to this address down below. And we'll open it on one of these other tabs we don't care about. And we'll go back here and grab the code. And we'll say next. And we'll click this. And we'll say continue. Great, we'll go back over to here. And so we have Azure Cloud. We are now logged in. So we should be able to deploy to Terraform. It should know that we're going to deploy to that subscription. Remember earlier we checked the that Azure file in our Azure config. I'm just going to show you really quickly. ~/.azure tab. And we're going to look in the config directory. It wasn't that one. Maybe it was something else. Clouds config. And that's how it knows what subscription it's going to target. Where those credential files are, somewhere in that folder, we still don't know. And the terminal's kind of messing up here. There we go. I had to just kind of wiggle it to get it to act normally. And so what I want to do is type a Terraform init. So that's going to install the Terraform plugins, the actual Azure provider for us to establish a connection. I'm going to type a Terraform plan. That's how you determine if your plan will work. It says insufficient feature blocks. At least one features block are required. What the heck is a features block? I don't remember there being one there before. Maybe it just wants us to remove the configuration completely. Let's see if that works. Nope, it wants it. So we'll go back here. I don't remember there being a features block before, but again, things change all the time on me here. And so we'll go back to the provider. It doesn't show anything here. Go back to the documentation, features. The features block allow configuration behavior for the Azure provider. For more information, go to the dedicated page. Sounds good to me. And here it says, this allows different users to select behaviors they require. For example, some users may wish to use the OS disk virtual machine, while others might want to do other stuff. So here it looks like you're supposed to have a features block, and then there are some settings you can set, additional settings. So that's kind of cool. I don't remember that before, but let's just give it empty features because I don't really want to do anything fancy. Okay, we'll go ahead and save. And we'll say Terraform plan. We'll give it a moment here. It's thinking. It's really thinking. That's a good thing, right? It usually doesn't take this long. um, what is going on here? I'll be back in a moment, okay? All right, so I thought there might be an issue with it, but we had to wait a very long time. It says insufficient feature blocks. So at least one feature's blocks are required. So I guess there's no way around it. We have to include a feature. So I guess I'll carefully look here and figure out what it wants. So here's all possible features. They say they're all optional. Then why do I have to? Why do I have to provide one if they're all optional? Okay, well, if there was one that we're going to do, let's go ahead and grab the resource group because we are using it. We are technically creating a resource group. So maybe that's a good idea to have that one in there. Really surprised that we have to, but whatever. So it says prevent deletion if contains resource. False. I mean, you might want it true, but the thing is, we're doing this temporarily, and I want to be able to tear things down, and I don't want to have any prevention on. So we'll go ahead and try Terraform plan again. Maybe it'll be faster. That'd be really nice. And we did do what it asked us to do, so. And again, I'm going to spare you the waiting. I'm just going to pause. Oh, nope, there we go. So what it's done is it's saying, and I'll just zoom out a bit more so it's a bit easier, or zoom back. So the way it works is when you run it, it's going to say, yeah, we are going to create these resources. See those pluses? That's what it's going to go ahead and create. And there might be even more than what you expect there to be. But nope, it's good. So now that we're ready, we can go ahead and do a Terraform apply. Terraform apply. It's going to ask us to confirm. It'll say like yes or no. We'll definitely say yes. We'll give it a moment. Okay. Other providers like AWS and GCP are a lot more responsive. I think it's just the time it takes to go talk to Azure. We'll type in yes. We'll give it a moment here. Again, it's thinking. And it's creating the resources. Great. So I'll be back here when it's done. It might just take a couple minutes. Might take 30 seconds, but I'll be back when it is created. All right, so like about a minute it took to create. So what we'll do is we'll go take a look at, and by the way, we really don't want to leave this. You really want to stick with this and after we deploy it so we can tear it down because the state file is all here. So when you use ARM, Azure ARM templates and Bicep, which just produces ARM templates, the state of the infrastructure is on the cloud provider. So Azure has the Azure Resource Manager, and it stores some kind of state file. You don't see it. We don't know what format it's in. But with Terraform, because it is an agnostic provider, it stores the state file here. Now, we could use Terraform Cloud, which has a free tier, and we could put it up there. But for our purpose, we just have it in here. You do not want to commit this ever to your repo. It could have sensitive information in it. So just be aware of that. In fact, we should have an ignore file in here so that we're not running into problems. So I'm going to go ahead here and just type in .git ignore. It's probably the first thing we should have done, but sometimes we do things out of order here. Git ignore Terraform. So we'll just go grab that because it'll give us the best stuff. GitHub has a recommended ignore file. We'll go ahead and copy that. And we'll go back here and paste this in here and save it. And that way, that state file will not be part of the source code. So notice it's not going to commit it, but the lock file will be there, which is fine. Let's go over to Azure and make sure that that resource was created. So if we go to storage accounts, we have an additional one there, my storage account, etc. It's there. So it's there. So if we were to lose that state file, we would actually have to manually delete the resource group. Because it would no longer be able to track it. But we do have the state file here. And so we can go ahead and delete those resources. So we'll go ahead and type in Terraform, destroy, and we'll hit enter. And that will tear down Terraform, okay? We'll give it a moment. It's just thinking. It is thinking real hard. There we go. We'll type in yes, and we'll have to wait for it to destroy the resource. I'll see you back here when it's done destroying, okay? All right, so after a short little wait there, that stuff has been torn down. I'm going to go ahead and commit these files. So changes, we'll just make a quick commit message there. We'll sync those changes. We'll say okay. Make sure those changes get pushed. If you need to look at my code, it's going to be in that repo. So just go back and look for it on the GitHub Exam Pro Co. Azure Bicep example. Yeah, we're good there. Let's make sure we just turn off this workspace here. So we'll say stop. Okay. And we have now stopped this workspace. We are in good shape, and we'll see you in the next one, okay? All right, so I've been in the free tier here, and I've been gathering a bit of spend while just clicking through resources. I was actually surprised how much spend has occurred, considering I haven't really done anything. But let's go take a look in our subscription and see if we can figure out what's going on with our spend here. Of course, you know, if you are in your paid tier, that could be problematic, but hopefully you are utilizing the free tier just as I am. And also, we might be burning through the free tier quicker because they're not treating, not giving us the free tier usage, and they're just treating everything as if it's fully paid. So here it says we have 200 remaining over $500. Still, I find that kind of crazy. We have spending rate and forecast, cost. Of course, we have no cost, so we're probably more interested in usage. But let's go take a look and see what's been causing this issue. So we'll go into here, into our cost analysis. And there is really no real cost. It's more just like us using resources. So I'm trying to make sense of this. It's a lot easier when it's real money and not pretend money. So we'll have to see here. We'll go cost by resource. Let's see if we can make sense of this breakdown. And I mean, these are all under $1, so I'm not exactly sure what it means here. So this is not going to be very useful in our free tier. Maybe what we can do is go over back over to our subscriptions here, because really we shouldn't really have any kind of spend. It's I think it's Azure tricking us, because I know all the resources we've been spinning up, and they're not. We have not had them up for very long, and there's no way they could be. As much as it's reporting here. So maybe a better thing might be usage. If usage gives us some indication here. I rarely ever have free tier, so it's not always very clear to me what's going on here. And so what we're seeing here is this is the quotas or usage of resources. So if you were to exceed this, you might have to request a quota increase. So this is not that useful. This is more about current usage and usage there. So yeah, I'm not 100% sure where free spend occurs. So just give me a moment and I'll go find out, okay? All right, so Microsoft is suggesting some things here. I don't necessarily mean that I believe that this is where it is, but let's go take a look and see if they're being honest with us here. So we're in our subscription, and it's suggesting that we go over to where? Spending rate and forecast. So that's what we were on earlier. If we go back over to the right tab, if we go back over to overview, it was this here. We go to view details, and I was trying to break it down a different way. Okay, so we'll go back over here. Cost by resource. Show the cost of individual resources. Top free services by usage. This area only appears for free count. So if you don't have a free count, the area isn't shown. Well, I'd love to see that. That sounds very useful to me. So let's see if we can. I'm going to close this tab. It keeps messing me up. If we can see that here. I mean, I'm not really seeing that here. All right, let me really carefully read it, okay? All right, I think what it's saying is that on that overview page, it'll have that on the right-hand side. I don't think I saw that, but I was going pretty darn quick. So to be fair, it could be my fault. And we're just gonna go back to subscriptions here on our overview. It's over here, so we'll view all free services. They say this only is provided in our free services for 12 months. So notice this is talking about all usage over 12 months. And we can sort this based on usage, I suppose. And we're only seeing usage here. So you can see that we're not really utilizing much. Like Cosmos DB has a free tier. That's something we spun up earlier. Virtual Machines has a free tier. I don't think AKS has a free tier, but where is all this money going? That's what I want to know. How do we go from $500 to $200 in a day? Your remaining $200 of free credits expire in etc. Maybe we only get 200 free. Maybe it's not $500, and I'm just crazy. Let's go ask ChatGPT. How many credits do I get in Azure for the first 30 days? Maybe it's just 200. I mean, that sounds more reasonable than 500. I think I'm just kind of forgetting. I remember GCP once had like a lot of free credits, like thousands. And ChatGPT is really taking their time here. So let's go out to the internet and, oh, no, here we go. It's $200. Okay, so, all right, our spend isn't crazy. It's just down by a little amount of money. It's still not showing us what is fully outstanding. Again, it's so hard to see this when the spend is so low. So I guess we really are not spending a whole lot there. We can go back to notifications and see it. I mean, it did show up here, notifications. And notifications is taking time here today. That's great. Come on, notifications, you can do it. It's really not appearing here today. And I can't go back. There we go. Yeah, so I guess maybe it wouldn't show up there. Maybe it would show up in the advisory. So most providers have advisories, and that's maybe where that pop-up came from. So we'll go back to subscriptions. And I think I saw it here on the left-hand side. We had like advisory recommendations. And we have none right now. Okay, so that's okay. All I wanted to know was, do we know where we can see our spend? And apparently in the free tier, we can go over here and see stuff. Since we're not in the paid tier, there's not a whole lot of information that is interesting that we can see. But maybe make note of this, that when you are in your first 12 months of your account, go over here and check and just see what your utilization is looking at, and just be very aware of what you have access to. So clearly we have Cosmos DB, we have storage, we have some virtual machines of very particular sizing. We get some SQL database, which is really nice. Public IP addresses. This is something that was not charged for previously. I don't know when Azure started charging for it, but all providers now charge for IPv4 addresses. So that's another additional expense. Cognitive services, which we do a lot in the AI-900. So that's a lot of AI stuff. You got a load balancer for free, which is nice. And a bunch of databases down here below, and more virtual machines. So one's probably the Linux, one's probably Windows. So a lot of fun stuff there. But anyway, hopefully that gives you an idea of spend a little bit more. But of course, it'd look a lot nicer if we had more spend. And maybe I'll make a separate video showing more spend, okay? See you in the next one. Ciao. So Azure Monitor is quite a beefy service. There's a lot going on in it. And so it's a comprehensive solution for collecting, analyzing, acting on telemetry data from your cloud and on-premise environments. So here's an example of one of the things it can do, which is provide you a visual dashboard. But it can create smart alerts, automate actions, log monitoring, and a lot of different things. And many Azure services by default are already sending their data to Azure Monitor, so you can use it right away. Now, I just want to introduce you to the concept of the pillars of observability. This isn't a thing specific to Azure, but it's something that in DevOps that you need to understand, and it's just going to help you contextualize the offerings of Azure Monitor and other cloud service providers. So what is observability? That is the ability to measure and understand how internal systems work in order to answer questions regarding performance, tolerance, security, and faults with a system and application. And in order to obtain observability, you need three things. You need metrics, logs, and traces, and you have to use them together. Using them in isolate does not gain you observability. So let's go define those three things. The first thing is metrics, and that is a number that is measured over a period of time. If we measure the CPU usage and aggregated it over a period of time, then we would have the average CPU metric. Then you have logs. These are text files where each line contains event data about what happened at a certain time. And then you have traces, and this is a history of requests that is that travels through multiple apps and services so we can pinpoint performance or failures. And I like to make the joke that it looks kind of like the Triforce of observability once you've constructed it there at the end. Let's look at the anatomy of Azure Monitor, which is a little bit complex, but I'm sure we can work our way through it. So the first thing is that we need sources of data. So this is what data can be sent into Azure. So you probably want application data, operating system data, data from Azure resources at your subscription level, your tenant level, which is going to be associated with Active Directory, and custom sources. And once you get those into Azure Monitor, you have to store them somewhere. And you're going to put them in logs and monitors. And these are just data stores that are within Azure Monitor that you're going to be able to work with. And once you have that data in there, you're going to be able to leverage different services to do different things. And so we will call these functions. So you can perform insights, visualizations, analysis, response, and integration. So we'd look at insights. We're getting insights into our virtual machines, our containers, our applications. For visualization, you might be making dashboards. You could be using Power BI or creating workbooks. For analysis, you might be using the log analysis or the metric analysis tools. For responses, you might want to create alerts or start auto-scaling. And for integrations, you might want to use logic apps or export APIs to connect things up. So there you go. I want to quickly touch on log analytics. And so this is a tool used to edit and run queries within Azure Monitor logs. And so the idea is it kind of looks like something you would use to connect to a database, because it really is structured like a database with tables and columns and things like that. And it has this its own query language called KQL. And the idea is that you input your queries and it's going to output results for you. And that's something we're going to look at in greater detail, is that KQL language, so that we know how to use that panel. But let's go talk about workspaces. So when you use log analytics, you're going to probably want a workspace, and this is a unique environment for Azure Monitor log data. Each workspace has its own data repository and configuration and data sources and solutions, and are configured to store their data in a particular workspace. So it's really interesting, because if you go over to Azure Monitor, you can use log analytics without creating a workspace. But I believe that if you want to isolate a lot of your data and install maybe collect data outside of Azure services for other things, you're going to need a workspace. And it's going to also have a lot more robust options. So that's something you're going to end up doing, is creating workspaces, and it's a good habit to do. But there's not a lot to talk about there. But let's move on to the query language, which is really the meat of log analytics. Let's take a look here at Azure Alerts, and this helps us be notified when there are issues found within the infrastructure or application, and this allows us to identify and address issues before the users of your system notice them. And so they come in three flavors. We've got metric alerts, log alerts, and activity log alerts. And when an alert is triggered, you can be notified or have it take action. So here is kind of the anatomy of an alert, and we have the alert rule. This defines who we should monitor, like the service, and the definition of when it is triggered, which is going to be the next part here. So a resource such as a virtual machine designated as the target resource will emit signals. So it's going to be emitting a data payload, and it could be of the following types. It could be a metric, a log, activity log, application insights. You can kind of see how that ties to the types of alerts. Then you have the criteria or logical tests. This gets evaluated and determines, are we in a triggered state? It could be like percentage CPU greater than 70%. Then you have your action group, which contains actions, and those actions will be performed when it is triggered. And actions could be things like run an automation run book, use Azure Functions, ITSM, Logic App, webhooks, or a secure webhook. On the other side there, we have this box over here, and this is all about the state of your alert. And so we have monitor condition alert state. So monitor's condition is set by the system, and alert state is set by the user. But the idea that is there is so you can define where it is, because you might want to have a history of saying, okay, I've resolved this issue, so I'm marking this as closed, and that'd be like an alert state there. And so there you go. Let's take a look here at Application Insights, and this is an application performance management service. So it's an APM, and it's a subservice of Azure Monitor. Let's talk about what APMs are. So these are monitoring and they do monitoring and management of performance and availability for software apps. APMs strive to detect, diagnose complex application performance problems to maintain an expected level of performance. So why use Application Insights? Well, it automatically detects performance anomalies and includes powerful analytics tools to help you diagnose issues and to understand what users do with your app, designed to help you continuously improve performance and usability. Works for apps for .NET, Node.js, Java, Python, hosted on on-premise, hybrid, or any public cloud. And I know that it works for other ones that are not part of the supported languages. So there's one for Ruby. But the thing is like Azure's only providing official support for a bunch of languages, but you might still have libraries out there for them. And it integrates with your DevOps processes and can monitor, analyze telemetry from mobile apps by integrating with Visual Studio App Center. And if you're running an app, you definitely want to have an APM installed. If you ever use Datadog or Skylight or New Relic, that's what APMs are, or what those providers offer. But let's take a closer look here. And this is kind of an example of an application. And what you're going to see is that we have a front end, a back end, and workers, just to kind of represent how you can instrument your applications. And when we say instrument, it just means install like this piece of code that runs on it to send data back to Application Insights. And the idea is that when you instrument it, you're just installing the instrument package SDK, or in some cases, you can just turn it on where it's supported. So you don't necessarily have to install it in an app. You might just press a button and it will install it within Azure services. And there's many ways that you can view your telemetry data. So the idea is that the agents send that information to Application Insights, and then you're going to be able to leverage that in alerts, Power BI, Visual Studio, REST API, continuous exports. A lot of services can ingest Application Insights. So apps can be instrumented from anywhere. So if you're running on AWS, you can install it on your servers there. When you set up Application Insights monitoring for your web apps, you create an Application Insight resource in Microsoft Azure. So it's a physical resource. And you open this resource in the Azure portal in order to see and analyze telemetry collected from your app. And the resource is identified by the instrumentation key, also known as the I key. And I just got a big old list here just to tell you all the things you can do with it. So what does Application Insight monitor? Well, request rates, response time, failure rates, dependency rates, response times, failure rates, exceptions, page views, load performance, AJAX calls, user and sessions count, performance counters, host diagnostics, diagnostic trace logs, custom events metrics. So there you go. That's a big old list. And on the right-hand side is where can I see my telemetry? And we saw a little list, but let's go through the big list. And that's smart detection and manual alerts, application map, profiler, user usage analysis, diagnostic search for instance data, metrics explorer for aggregated data, dashboards, live metric streams, analytics, Visual Studio, snapshot debugger, Power BI, REST API, continuous export. And there you go. So you can see that it can collect, and you can use it in a lot of places. Definitely install if you're using or you're running a web application.